So, good morning to all the dignitaries, professors, and participants present today. On behalf of MIT University, Uttar Pradesh Department of Computer Science and Engineering, MIT School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for the keynote address for Conference 2022, 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would like to invite you on our campus and have the keynote session in person, current world scenario impede us from doing so. Luckily, we are grateful to have the opportunity to keep keynote session in virtual mode so that our student can reap the seeds from the knowledge gathered in this session. Today, I extended to take the opportunity to invite our honorable speaker, Dr. Mario Devin. He's a professor and head of data science research group at the National University of La Pampa. He is honorary professor of MIT University Noida since 2016. His scientific interests lie in data mining, stream mining, high performance computing, big data, IoT, data quality, measurement and evaluation. His interest area lies in data science, stream mining, high performance computing, big data, Internet of Things, and measurement. Sir will be delivering talk on towards real-time measurement aware decision making. Sir, we invite you on the platform to share your thoughts on the with us. Yes, sir.
Thank you very much. So, right. Thank you for your kind introduction, Dr. Chandra. Let me start the presentation here, right? In this opportunity, I will talk about towards real-time measurement aware decision making. Before I start, I would like to give my thanks to all the organization, MIT University, and all the people behind the scene for this wonderful conference. Thank you for the opportunity. So this talk is organized around 4 topics: a brief introduction to the importance of the measurement, the relationship with the data quality, and the impact on the decision-making process. The next point is focus on the quantitative perspective, the impact on the measurement process in the decision-making support. After that, I would like to analyze the role of the real-time data collection systems and how the data quality impacts directly on the decision-making, in the real-time decision-making. And finally, I will try to synthesize a proposal around a simple experimental design explained in a single file, a self-contained file using an ontology. So the introduction will focus around this relationship, how we can get a numerical value to interpret what is the numerical value in a given context, what is the meaning, what represents, what is the impact on the given measurement process, what is the aim related to the measurement process, how the IoT and edge computing develop different roles in this data collection strategy. However, we need to understand that the IoT edge computing involves different concerns related to data ownership, data security, among other aspects, but also about the heterogeneity, the device heterogeneity. And that is a challenge in terms of data interoperability, in terms of syntactic and semantic data interoperability. Why that is a particular aspect? Because we need to use data to support different kind of decision-making process. And if we need to support the decision-making process, we need information or data. Data is a captured fact, something registered in some place, but we need to be sure about the consistency, the truth, the interest, and the technique about the data to support a given decision. That is the point in which I difference between data and information. Even when I have information, I need to create different models, maybe to provide recommendations, maybe to anticipate future decisions, or to support or to recommend future actions based on the current data or information. In such aspect, it's where the artificial intelligence play a very important role. So we are seeing 4 different areas, but with a strong relationship around the decision-making process. From the measurement standpoint, we need to understand that the measurement process needs to be defined, repeatable, and extensible. Defined because we need to ensure that if we want to implement a measurement process on a site 1, site 2, or n a number of sites, the measurement process needs to be the same steps, the same instruments, the same method to get a numerical value. Why that is important? Because we need that the measure need comparable each other. For example, to know if the value in a time t is upper, lower, equal with another value in a time t plus 2, t plus 4, t plus 6. Something that could sound elementary, but that is essential. If we cannot ensure that the data are comparable, the measurement process is not very useful. Why repeatable? Because if we get good results in a given site, we will want to replicate the experience in another site. Even we will want to add new requirements, new perspectives, new features that we need to quantify for a given reason. So it is highly probable that the measurement process will be extended over time. The use of the measurement ontologies is a very useful thing from the perspective that we need to share a common understanding about different concepts. For example, what is the concept of a metric? What is the concept of an indicator? If we see, for example, SLO or SLA in services, you will see that SLO establishes a threshold. SLE is a given metric that provides you a numerical value. But that is a bit confused because, for example, if you get a metric, you establish a given method with an instrument to get a numerical value. If you want to interpret the numerical value, you need a specific knowledge about a certain field or area to know what is the meaning of a given value in a given context. For instance, 34.5 Celsius degree. Oh, right. That is fever or not? I don't know. To interpret the numerical value, I need a specific knowledge from the medical field. So the device will say me 35.5 Celsius degree. That is all. It's a very important thing, but the number is not the interpretation. We need to discriminate the metric from the indicator. For that reason, the use of an ontology is very important. To understand, for example, in a given measurement project, what we are understanding for a metric, what we are understanding for an indicator, among other concepts. In this scenario, the importance is evident. Maybe I have the most sophisticated model, but if I provide scrap to the model, I will get a new model with the scrap. The utility is not good. I need to be sure about that the data I provide to the model are representative around a given situation, a given phenomenon, to get a useful model. In this context, maybe we could try to understand the data quality at the data source. For such a reason, the use of conceptual model for understanding the different properties related to different kind of conceptual models are useful. For example, if we can to understand the data quality from the perspective related to the ISO 25012, maybe we can understand that there are properties related to the data quality that are specifically related to data, and other properties related to specifically to this, to the system, and a set of properties related to both the system and the data. When we are talking about properties related to data quality associated with data, specifically, we are talking about accuracy, completeness, consistency, credibility, and currentness. However, when we are talking about properties focused on the system, specifically dependent on the system, we are talking about availability, portability, and recoverability. However, there are a set of attributes dependent on the system and the data themselves, such as accessibility, compliance, confidentiality. Maybe in confidentiality, I could use encryption using TPM 2.0 or encryption based on software or another kind of alternative, independently the data content, efficiency, precision, traceability, and understandability. The quantitative perspective, focus on how can we define this experimental design in order to different devices can collect data in a consistent way. How to replicate this measurement process in different devices. For such a reason, we use a strategy named GoKMSB. GoKMSB is the acronym for Goal-Oriented Context-Aware Measurement and Evaluation Strategy with support for entity state scenarios and visualization. What is the idea? The idea is to define the project aim or the objective related to the measurement process, to specify the concept or the entity category to monitor, what kind of attributes related to an entity we want to quantify, what is the context or a scenario, the context or environment in which an entity can play some, can develop or can perform some activity, and how the environment can vary over time. For such a reason, we want to define scenarios and entity states. After that, we define how to quantify every single attribute related to an entity or context property related to the environment. And after that, we specify how to interpret every numerical value for a given metric. Finally, we define how to visualize, how to perform the visual communication related to the set of indicators. This is the methodological perspective. From the implementation, we want to characterize this outpatient, an entity category. Why entity category? Because we will have a set of entities, Peter, Jason, Sarah, etc., under this umbrella entity category. The outpatient will be characterized by the heartbeat, the corporal temperature, systolic blood pressure, diastolic blood pressure, among other attributes. And the same way, the scenario. Maybe from the environment, I would like to know some information about environmental humidity, environmental temperature, environmental pressure, and how is the interaction between these context properties with the operation. The relationship between attributes or context properties with sensor are established through the metrics. We establish the metric in where we define the measurement method, the instrument to be used, the association with the sensor, and that is important because when we read 35.5 Celsius degree, we understand that that number corresponds to the corporal temperature for the occupation 1 coming from a given device. This is important because it allows us to reuse devices, mainly thinking about the environmental monitoring. The devices could be reused to keep track on different entities, running, walking, playing, among other activities in a given place. It is very useful to optimize budget, allow us to cross data in different projects, concurrently are monitored in different areas. Of course, we need to keep into consideration different concerns that data privacy, ownership, and security, and that will be aligned with local regulations. From the perspective of the real-time data collection, once we have the project definition, the experimental design, how we pretend to obtain the numerical value and to interpret every single number, we need to inform this measurement project definition, the experimental design, in a friendly way. The receptor will be gateways and measurement adapters. The measurement adapters are semantic bridge. They are connected directly with sensor, and they will receive the measurement project definition. They will match every single sensor with the project specification, and they will inform, okay, this sensor corresponds to this metric, and 64.1 is environmental temperature in this location. And that is informed to a central repository or another device close to it. For informing the project definition, we have three alternatives: brief PD, JSON, and XML. This is a new data format that we have created at the end of the last year, and it is very interesting from the point of view of the size. For example, here you have a single, a part of a real message. For the same information, BreadPD use 65 bytes against 175 required by JSON and 379 required by XML. A very different situation. Once we have communicated this single file to the measurement adapter and the gateway allows us to establish a track associated with different measurement adapters, and the measurement adapters establish the relationship directly, establish the relationship between sensors and the experimental design. Every single measurement adapter will inform data plus metadata to a central location. Data are the number, 64.5, okay. Metadata are the tag ID associated with the metric. So when the data are informed, the measurement adapter will say, in this time, I'm informing 64.5, a context property for the operation one, and correspond to environmental temperature. All that information with a simple ID, because all the previous definition is contemplated in the experimental design. That allows us to communicate data metadata together and to process a set of measurement adapters, different gateway, heterogeneous completely between them, in a centralized way, allowing to interpret different scenarios and entity state concurrently, allowing to keep track about different measurement projects, allowing to process statistically the information, or applying different incremental classifiers, such as a coefficient 3, to detect typical or atypical situations, risky or non risky situations. Okay, but what is the role of the measurement ontology in this important thing? To create this single line explaining all the information of the scale that you see in the last part of the XML, we agree different concepts through a given ontology. The ontology is available in the ontology registry and repository. Here you have the link if you want to analyze the different definitions, but it is important in this point to highlight that concepts such as metric, attributes, entities, the relationship between an entity category with the attributes and context and the context properties, and how the metrics are related to the attributes or the context property are established in this ontology. So the devices use the hierarchical organization of the concept to create or to read the content related to the message. It allows us partial updating or verification, and also all the content of a single file, all the content of the experimental design is contained in a single file. The single file can be expressed in BriefPD, JSON, or XML indistinctly. But this new data format is better in terms of space and associated times. The new data format avoids the use of tags directly, and it is possible to inform multiple projects in a single message. For example, this is a simulation over time where you can see that the required time to create a single message, the same message, using JSON and BriefPD change let me check, sorry. There. If you see, BriefPD is the line blue. That is the total time to pass from the object model to a single BriefPD. The consuming time, details more or not, are 77 milliseconds. That is the required time for generating the self-contained message. The analogous under JSON data format is 154, the double that BriefPD. The same information. Even the time to regenerate from the single file to the object model is 4.57 for brief PD, and in this case, JSON was a bit faster, 4.3 milliseconds. But the difference is tolerable. That is an opportunity to improve the library. Here we are comparing JSON library from Google with our implementation of the brief PD data format, available on GitHub, of course. However, from the size point of view, the difference is higher. If you see XML, we need to use a secondary axis to show the difference, because the same message under XML is for 100 projects, more or less, 13 megabytes. And without compression, with compression is 399 kilobytes. The JSON alternative is 3 megabytes, 3.4 megabytes, and without compression, and 1.6 with compression. The same information expressed by brief PD, the new data format, is 149 without compression and 16 kilobytes with compression. It is a huge difference between the different data formats. So the initial difference related to this project is satisfied or gained on the other hand in the size of data to be transmitted. So results associated with these simulations and results can be reproduced in this Ocean capsule, freely available, and the details about the brief PD data format, how to express the experimental design using a single and self-contained data in one single file and using ontologies is available on this recent article on future generation computer systems. As a synthesis, 3 points to remark in this information, in this necessity to make decisions based on information, based on measurement, but the measurement is related to information itself, because if we are thinking, sorry, a measurement project is associated with a specific aim or objective. Every single numerical value is responding in some way to the objective. So we are reading information that we need to support that decision making. If we are reading a number, the number is associated with an attribute from an entity or a context property from an environment. So we want to know something about such a characteristic. In such aspect, the data interoperability is a critical thing from the semantic and syntactical point of view. For such a reason, we insist with the use of an ontology, a measurement ontology, because we need to communicate an experimental design to ensure a consistent, repeatable, and extensible measurement process using heterogeneous devices. And for such a reason, the real-time data collection focus on the reusability. The reusability is associated with heterogeneous devices, heterogeneous environments, and we need to collect all data and inform data, showing with metadata, describing what is the meaning of the data, to make easier the data interpretation before designing. Finally, the ontology-based content allows us to get a portable project definition. It is important to share or to get a shared concepts among different actors or roles in the data processing collecting strategy. And finally, it allows partial updates and verifications. That is very important, mainly in big measurement projects. Some readings that I recommend if this topic is interesting for you. The first one is an article from Knowledge-Based Systems, and it focuses on the metadata-based measurement transmission by Merkle tree. That is an interesting way in which the project definition, the experimental design, can help us to optimize the way in which we can transmit data smartly or cleverly. This is the last article that I told you before. It talked about the brief-PD data format and how to generate and read this kind of content. And the last one, an architecture for the real-time data stream monitoring in IoT, will show you how to articulate from the measurement process definition to the IoT implementation and to establish a channel between based on the read information. Thank you for your attention.
Thank you, sir. Thank you for your enlightenment word. It was a pleasure to listen to you giving insight about real-time measurement of your decision making. On behalf of MIT University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing you how much busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to you, sir. Thank you, sir. Thanks a lot.
Thank you.
Thank you, sir.
Thank you.
Good morning to all dignitaries, professors, and participants present today. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Conference 2022, 12th International Conference on Cloud Computing, Data Science and Engineering. For this session, we are having Professor Bernhard Feringer, who received his PhD degree from the University of Technology in Vienna, Austria in 1995. He's a professor with Department of Computer Science at University of Waikato in New Zealand. His interests span a range of data mining and machine learning subfields, with a focus on streaming, randomization, and complex data. He's a professor in Computer Science Department at University of Waikato and also a co-director for our new AI Institute. We welcome you, sir. Nidhi ma'am, is the slide visible?
Yes, Garima ma'am, it is visible.
Can I play?
Yeah.
Due to some reasons, Professor Bernhard Feringer is not right now here, but he has recorded the video and we are going to live the session. Ma'am, just let me know, is it fine?
Good morning.
Yes, ma'am. It is
Thank
audible.
you.
Let me share my screen in full screen mode before we start. Okay, here we go. Thank you, everyone. Thanks for inviting me to giving this presentation here. My name is Bernhard Feringer. I'm from the University of Waikato in New Zealand. And this talk today is going to be called Simple Self-Training Approaches for Semi-Supervised Image Classification. Now, before we go into the details, let me just give you a little bit more background about myself. And I might just move this window out a bit here. Well, here you see some nice pictures of our campus in Hamilton. Hamilton is a small city. It's only about 150,000 people, so we have a lot of space, and we get enough rain so that it looks green all year round, mostly. Hamilton is in the North Island, not quite in the center, but kind of middle, if you want, and pretty close to the biggest city, Auckland, which you can read here. Just to give you an idea of where New Zealand actually is, if you haven't seen that before. So this is a view of the world. And it's always good to look at its nearest neighbor. We just use a simple one nearest neighbor here. So we would look at, for an unlabeled example, its representation. What's the closest representation of a labeled example? And we take that label. There's an interesting algorithm called LLGC, or local learning with global consistency, that tries to be better than that by then propagating predictions and updating things in interesting ways. We included that just out of curiosity and because we hoped it might improve on the one nearest neighbor. And of course, it's always good to have good baselines. So maybe we can just use cross entropy loss as well from the softmax score. Now we need to evaluate. For evaluation, we need data. We always need data in machine learning. We chose a couple of standard benchmark data sets for images. So MNIST, you have heard of that, I'm sure. Handwritten digits, fashion MNIST, which is a variant of that. Then street view house numbers supplied by Google, which just is like MNIST, but harder because it's real world images from the cars driving around for Street View. CIFAR 10 is a very well-known collection of about 50,000 examples from 10 different natural classes, like trucks and boats and some animals and ships and a few others. And then we also added something out of curiosity, which is called Plant Village, which is about 35,000 examples of more than 30 classes, whereas all the other problems here have 10 classes, which makes it more interesting. And also the classes are very similar because they're all about a small number of plants and various diseases that they can have. So you get a healthy looking leaf from a certain plant, and then you get leaves that have been affected by various diseases, like this yellow one here, or this one with the red dots, and so on. So here, all the images are much more similar to each other, so we thought it might be an interesting, harder problem, not just because more classes, but also there's a lot more similarity inside the classes. And also, all the original other 4 data sets have small images. Plant Village has larger images. So we were able to downsize them to different sizes to see what size might have as an influence. Okay, here are the first results. So this is classification accuracy. With the different loss functions. So you see cross entropy, triplet loss, contrastive, and arc phase. And LLGC actually is LLGC applied on the triplet loss, which actually wins here in this case. But if you look across, we'll chase for the bold. You see bold here once, twice, 3 times, 4 times. So 4 out of 7 times here, triplet loss wins, and then cross entropy has 1 win. Well, I said LG had 1 win, and also contrastive loss has 1 win. Arc phase, interesting, doesn't have any wins here. So we included arc phase because it's a very high performing loss function specialized on for face recognition. We thought maybe it might work well here too, but apparently it doesn't. Also, what you see is sometimes the results are all kind of in the same ballpark. Sometimes there are quite large differences, like here, for instance, for street view house numbers. Gross entropy 85 and triplet loss 84, so they're kind of close to each other. Then LGC a little bit worse, and then contrastive 10% down, and arc phase another 10% down. Okay, so I said before that we included LGC, hoping it would help, but here we actually see that the opposite is the case. It seems to overfit to some degree, and we played around with these parameters, but we never got around to kind of make it more robust against overfitting. So what you see here is the labeling accuracy. So the pseudo labels, how good are they actually? The initial ones are really good, high 90s, and then over time, we label more and more examples, not the natural, see a drop, but what we see is the drop is the worst eventually for LLGC. And if you compare softmax and one nearest neighbor, see the one nearest neighbor always has a slight advantage. So this is what we usually use then. Okay, that was the first approach. Now the second or variant is to look at so-called transfer learning, further improve things. Transfer learning is the idea that we have large networks that have been pre-trained on large data sets, like generally ImageNet, but also others, that people make available. You can download hundreds of pre-trained models these days. So why not use a pre-trained model and just try to improve it with our small amounts of labeled data? This is basically the key behind transfer learning. So in our setup, what it means is this is our labeled data and this is our large pre-trained network. Put them together, update the network, fine-tune it. Fine-tuning can be done in different ways. And then we're back to the regular loop. We have the unlabeled data that we pseudo-label. We select the percentage, we merge it with the labeled data. We repeat the process a number of times. Now this works quite well, to be honest. Well, I guess it was to be expected, but it's not that clear because you only have a small number of labels and you might have this large pre-trained network starting to overfit that. So we use generally so-called wide ResNet 28.2, which is a reasonably sized network. And what we see here, the interesting column is this 2 columns in the middle. Oops, that was wrong, sorry. 2 columns in the middle, labeled self-training with approximately a triplet loss. And then we see random weights, and then we see pre-training with different sizes of the pre-training data. And not surprisingly, our data is usually 32. So the pre-trained 32 versions usually win out, not always. Also, the pre-trained usually wins over the random weights. Now, what we also see here is kind of lower and upper bounds. This is just the first iteration of pre-training. This is just on the actual labeled data that we are allowed to use. So we would always like to get better than that. And here on the right, what if we had labels for all the training data? What would this setup achieve? This is like an ideal upper bound. Usually what you find is we get sometimes quite good improvements over the lower bound, and we sometimes get reasonably close to the upper bound, like here for 94 to 96, but not always. Here, like 89 and 99, there's still a large difference. But we get improvements. Now, another way to look at that is here, just one run, one data set with 4,000 labeled and 46,000 unlabeled examples, and then a separate test set with 10,000 examples. This is the lower bound, this is the upper bound. These are 3 training runs. This is a randomly initialized network. With the pre-trained network, our lower bound already starts quite a bit higher, and our higher bound is also a bit higher. And you see all the 3 different runs. On average, they all improve over the lower bound. They not quite reach the upper bound, and in this case, they're a little bit above the final accuracies for the randomly initialized weights, but we get some gains. So simple method, works well, easy to incorporate. Now, more interesting, more recent and very intriguing idea is this idea of self-supervised learning, where you invent some labels to train a network with a large amount of data, and then you use the actual labels on this pre-trained network. Because we already know now pre-training works, right? So what if we can use our unlabeled data to improve our pre-training? So people have tried lots of different approaches, but it turns out that one simple thing works pretty well for images, which means rotating the image by 90, 100, 270 degrees, or flipping it left, right, or flipping it upside down. So basically from one image, you can generate 6 different variants, and then you label them with the operation. So this is the original one, rotation of 0, and these are all the others. And then you train a network to distinguish between those operations. So you give it this image and you hope that the network predicts, oh, this is an original that was flipped from left to right. As I said before, this works surprisingly well in some other published research. Now, looking at self-supervised learning, how we could, or in what stages we could incorporate that into our training pipeline, what you'll find is there's unfortunately a number of different ways. So we've investigated 3 of them. We just use it all the time, everywhere, This is called combined self-supervised training. The downside of that is that now we have always got a lot of amount of data to work with, so this is the slowest approach. The other extreme is to only pre-train the network with the self-supervised labels beforehand, before we do our standard semi-supervised learning. And then a kind of compromise between the two is doing it, the combined thing, for only the first step of the 25 meta iterations. And it turns out that this last one is the most effective one. It is also the most efficient one because we only have one step where we have a lot of data for training the network. And after that, we always have those labeled subsets, which are generally much smaller. So looking at the same kind of illustration again, now we have the unlabeled data, and we use that, like we take out this head of a duck, generate all those unlabeled or pseudo self-supervised labeled data. So we have 6 times as many examples, and we combine that with our true labeled data. And we have a combined loss function that takes into account the self-supervised loss and the truly labeled loss to have a pre-trained network getting improved or a randomly initialized one. And after that, we go back to our regular loop. So after the first step, it's the same as it's always been. Now looking at that, that gives us really good results. Usually, again, better results if we use ImageNet pre-trained networks to start with, our self-supervised pre-training on top of that. But there's one exception here, which is the simplest problem. And if you look at that, those differences might actually not be statistically significant. So maybe it is the same here. So it doesn't matter for the simple problem. And then for the more tricky problems, it does matter. Unfortunately, in all these cases, it seems that cross entropy actually outperforms triplet loss, which is kind of a little bit disappointing from our point of view. But on the other hand, it's nice to have a simple method like cross entropy work really well. Okay, so I'm running out of time, which is good reason now to wrap this up. So in summary, what this PhD work has achieved is it has investigated the application of metric learning ideas and losses for self-training in semi-supervised learning, and especially looking at one nearest neighbor and LLGC as an alternative to just using gross entropy. And at least in this first setup, the simple one, where we just have self-training with labeled and unlabeled examples, it is the case that these alternatives give you as good or even better results than gross entropy. Now, the negative result is that if we start in a more sophisticated way, like with approaches 2 and 3, the picture somewhat changes back into favor of gross entropy loss. But what the second approach has shown that transfer learning generally is beneficial. So if you have a good pre-trained network, it's always a good idea to use that image classification and fine-tune it for your problem rather than learning something from scratch. Unless you have a very large problem or problems that are very, very dissimilar to the problems that you've trained your network on. So for instance, for medical scans, ImageNet pre-trained networks usually don't work well at all. But that's just because medical scans are so different. So in these specialized domains, you want to collect your own large amounts of labeled data, or you want to do something simple like the first approach. And finally, this really intriguing idea of self-supervision has come around recently. We've shown how that works, and how that works really well when we incorporate it. And so the final message is probably that if you have a setup like that, what you really should try, you get a pre-trained network and you use self-supervision, at least in the first meta iteration. That should be reasonably efficient, it should be really good results. So Atolla has been successful in publishing that work, the various parts of the work as conference publications that you can all access. But even more importantly, you can access all this code. So at the bottom, you see a GitHub repository referenced Atolla's name and / self-training. So hopefully some of you might find it interesting and build something interesting on top of that. Thank you very much. That's all for today. You can, of course, join the rest of the conference.
Thank you, Professor Bernhard, for your enlightening words. It was a pleasure to listen to you and give insights about simple self-training approaches for semi-supervised image classification. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude, knowing how busy you are. We appreciate that time you took to impart us with your valuable knowledge. We are highly grateful to you, sir. Thank you so much, sir. Now all students are requested to join the inaugural session in room number 1. Thank you so much.
Hello, Professor Rehan. This is the IT host from MIT University, Noida.
Yes, good afternoon.
Sir, very good afternoon. Sir, would you like to share your presentation while we are in
Yes.
practice session?
Yes, I have to share it.
Yes, yes. Please share and check while it's working or not.
And in the meantime, Simon sir is trying to join. We can start with the Dr. Rehan's session.
Okay, ma'am, you start. I'll make the session live.
First,
give me 1 minute.
So sir can just check whether he can share his screen or something. And
Okay,
then,
okay, ma'am. Just let me know, ma'am, once you want me to start.
Is it visible, Smriti ji?
Yes, sir. It's perfectly visible.
Okay. So this is the title of my talk. Role of
So
data.
let me introduce and let's take the session live also.
No, I'm informing you actually.
Okay.
It was not mentioned in your email, so I am sharing only the title.
Yes, you have already shared that with me. I've noted it down, sir.
Okay, fine. Thank you very much.
Sir, can you stop sharing now? Once ma'am introduce yourself, then
yes, I'll stop.
Robinson, once you please make it live, just let me know.
Okay, ma'am. Okay, give me 1 minute time, ma'am. Ma'am, we are on live. You can start, ma'am.
Okay. Thank you, Mobin. Good afternoon to all the dignitaries, professors, and participants present today. On the behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering of Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Conference 2020-22, 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you on our campus and have the keynote session in person, but current world scenarios impede us from doing so. Luckily, we are grateful to have the opportunity to keep the keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Today, I elated to take the opportunity to invite our honorable speaker, Dr. Mohammad Rehan. Sir is a professor of electrical engineering with experience of about 20 years. He is gold medalist of BTech Electrical Engineering and has done significant research work in the areas of smart grid and solar energy. Both areas are under the national mission. He is also working as a founder coordinator of the Center for Grid Integrated Green and Renewable Energy in the campus to address the research challenges presented by high penetration of renewable energy in the grid. He is also elected fellow of the IET UK, India and IETE. He is a senior member of IEEE and elected vice chair of executive committee of IEEE UP section. He's a member of Executive Committee of Delhi Local Network of IIT UK. Dr. Rehan is also heading the entire electricity setup, both conventional and renewable, of the university since December 2015 as a member in charge. The campus has a huge electricity network of 8.5 MVA capacity and annual budget of about 30 crores. He acts as the technical, financial, and administrative head of the department and report to the vice chancellor, the executive head of the university. He's a leading team of 122 employees, including assistant engineers, junior engineers, account staff, and other technical staff. His responsibility in this role requires ensuring that all related works and purchases in the department are done adhering to the technical and financial guidelines formed by the Government of India. Sir, we invite you on the platform to share a few words with us.
Thank you, Dr. Smiti, for introducing me. And before coming to my talk, what you have mentioned in your introductory remarks, I'll add to that, and that I would like to congratulate the organizers. And I have been in touch with the MIT University people for years now, and I have seen that MIT has been contributing a lot towards promoting sharing of knowledge, research, and all that. And in fact, especially in organizing conferences, the record of MIT is exceptional. Your conferences are of very high quality. This I have observed as a member of IEEE XCOM also over the years. So, and particularly in these testing times when it is difficult even to conduct our routine works, you are conducting very good conferences like this CONFLUENCE also. So I congratulate all the organizing committee members, all the staff, and I extend my wishes to the participants also who have joined this session. So now I'll share my screen and I'll talk about this topic. I think I have about 20-25 minutes, and then I'll have the questions from the participants. No, Dr. Smiti, can you confirm my screen is visible?
Yes, sir, it's visible.
Okay. So my talk is on role of data in green energy transition. I'm sure when...
Sir, sorry to interrupt you, sir. If possible, please, can you turn on your camera?
My camera is on. I have not turned it off. My camera is on.
Sir, your camera is not on, sir. I'll send you the request. Please accept the request, sir.
Okay.
Yes, sir. Now it's, I can...
Can you see now?
I think, sir, it's okay, sir. You can continue.
Okay. So when Dr. Smiti was introducing me, I'm sure some of you would have wondered that a person who is more towards electrical engineering, power grid, solar energy and all, what he is going to talk in a conference on which is mostly devoted to data and data analysis and big data and cloud computing. So the idea behind this talk is only that I want to highlight that the new field of the evolving, or rather the new grown-up field of electrical energy has a lot of potential to offer for the work which you are doing in the area of data analysis, data interpretation, use of data, and all that. So the topic of my talk is role of data in green energy transition. So I'll try to highlight the importance of data in this green energy transition. And of course, the first part will be to convey what is green energy transition and what kind of opportunities it offers, what kind of challenges it offers for people who are working in the area of data and its analysis. So I'll start with a very, I would say, a development which was very well covered by all kinds of media. In the month of November, there was a conference there was a meeting at Glasgow, United Kingdom. This is known as Conference of Parties, COP. So it was this 26th edition of Conference of Parties, and it is an initiative under the United Nations. So, and it is an annual event which is devoted to climate prevention, protecting the climate from adverse effects. So in this meeting, 26th edition of COP, the Prime Minister of India has declared 5 very important targets for the country to achieve. What are these 5 targets? 50% of electricity from renewable energy sources by 2030. 5 lakh megawatt of renewable energy plants in the country by 2030. Reduction of 1 billion ton CO2 emissions by 2030. Reduction of 45% of CO2 emissions as a percentage of GDP by 2030. And 5th and the most important is achieving net zero emissions in the country by 2070. So I am mentioning these 5 announcements because you see, if you look at these five announcements, you will find that the energy and particularly electrical energy is at the heart of all these 5 announcements. And it is not so that with these announcements we are starting the developments in the area of renewable energy. In fact, for last 10 years and especially for last 5-6 years, there has been a lot of development in this area. And this is what I am calling as the green energy transition. That when the energy setup, not only in India, but around the world is moving from conventional to a new setup in which this sector is dominated by green energy or renewable energy. Now the question arises why this transition is required. So I'll be very brief in highlighting why this is required. So what has happened that, especially since the start of industrial revolution, we have been using fossil fuels. We have been burning fossil fuels at a very fast rate. And what has happened that burning of fossil fuels led to increase in CO2 concentration, carbon dioxide. I'm sure every one of you know what CO2 is. And the increased CO2 concentration led to increased greenhouse gas effect. And increased greenhouse gas effect led to increase in temperature of the earth. So what is happening? The earth is getting warmer, and which is known as by a term global warming. So CO2 emissions led to global warming. And I have mentioned some numbers also. The CO2 concentration before industrialization around 280 ppm, and now as per the latest measurements it is almost 420 ppm now. So this has led to an increase of almost 1.1, more than 1.1 degree in the overall average temperature of Earth's surface compared to pre-industrial era. So this is what we call as global warming. And realizing the damages which has already occurred and the potential it can lead to existential crisis for humanity, the United Nations have started to limit the temperature rise to 1.5 degree by 2100. And if we are unable to limit it to 1.5, we cannot allow it to increase beyond 2 degrees. This is the most important target. And for that to achieve, of course, since it is connected with CO2 emissions, we need to we need to reduce the CO2 amount of CO2 which we are emitting. So this is the crux and the target. So in fact, there are if you connect this target with the actual estimates, so we need to reduce by CO2 emissions by almost 45% from 2010 levels to 2000 in the next decade, that is 2030, so as to reach net zero carbon emissions by 2050. So basically, we need to reduce the CO2 emissions in a very fast way. That is the idea. Now, what connection it has with electricity? Now, you see, electric energy is right now one of the most important forms of energy. Started with it was used historically only for lighting. Then, slowly it started extending its reach. And now everything, whether personal or official, our homes or offices or residences, everything is now being run on electricity. And in fact, your digital age is completely driven by electricity only. So it has increased not only in terms of number, the volume required, but in terms of criticality also. And in India, especially, you see, as we are a developing country, our electricity network is expanding in a very fast way. In fact, in early 90s, we had only 86 gigawatt or so, the total electricity network, which has now expanded to 390 gigawatt. And I have mentioned some numbers that how in by 2050 we will cross the requirements of USA and Europe, and our electricity network will expand by almost 8 times by 2050. So, but the problem is that if for this increased requirement we follow the conventional system, I'm sure you know that conventional system of generating electricity has been you burn coal and you generate electricity. But when you burn coal to generate electricity, it leads to substantial amount of CO2 emissions. That is, if you generate 1 unit of electricity by burning coal, you will release almost 850 gram of CO2. So 1 unit equal to 850 gram. That is the direct connection between electricity generation using coal and the environment. So if you want to protect the environment, and of course you want to meet your requirement of electricity also, what you need to do? You need to decarbonize your electricity system, electric energy system. So, and there are 3 ways which are mentioned. First is shifting generation from coal to, say, solar or wind, which does not contribute to CO2 emission. So green energy, when I am saying, it is the energy which does not lead to CO2 emissions. Then, of course, increasing energy efficiency, conserving energy, and shifting sectors like transport to electricity, from fossil fuels to electricity. So this is how we are decarbonizing the energy system. And when I said that green energy transition, so this is what I meant by the green energy transition. So what is happening? You see, one of the most important developments which is playing its role in green energy transition is this kind of power plants. I hope the participants have seen some of the power plants in this form. You must have seen solar panels on the rooftops or on the grounds. So you are generating electricity using these panels. So you see, there is a rapid adoption of these kind of plants. But from the point of view of electrical engineers, this has changed the way power grid has been operating. You see, in the conventional system, this was the arrangement. You generated electricity at some remote locations, then through transmission lines, you transmitted the electricity to some areas, then distributed to the consumers. This is what we used to call the trickle-down approach of electricity from generation to utilize. Now with this, I have shown you the distributed solar plants distributed near the loads. We are evolving a meshed system, that is load. The generation source is also near the load. although these sources are connected with the power grid also. So we have developed a meshed system now, highly distributed meshed system. So you see, it presents a major challenge in terms of operation and maintenance. This system was a completely different system, and this system is a transformed system. So in this scenario, 3 Ds are very important to understand for a successful transition to green energy. One is decentralization, which I have already mentioned, that we are installing small green energy plants near the load. So that is the decentralization. Second is decarbonization. That is like we are using electric vehicles. So that is the decarbonization. But equally important third aspect is digitalization. So there is a consensus that you cannot achieve this transition successfully without substantial use of digitalization. When I'm saying this, I'm not saying that in the conventional system there is no role of digitalization. In fact, I'll share with you very interesting recent event. I hope you remember that in April 2020, the Honorable Prime Minister of the country gave a call to switch off the lights for 9 minutes. And simultaneously, people followed and simultaneously switched the lights off for 9 minutes. And you see the impact was that 31 gigawatt, almost 31 gigawatt of load was suddenly switched off, almost 1/4 of the total load of that time. But still the grid was managed. So a very important role which was played in successfully managing this event was because of the already increased use of digitalization in the grid. But for green energy transition, this role will be further increased. And in fact, for the new grid, there is a saying that it will be using megabytes to move megawatts. That is the kind of role digitalization is playing and is set to increase. This role is set to increase. So, for example, in case of solar and wind energy, forecasting becomes very important. You have to forecast not only the load, but the source also. And based on that, you will allocate the energy resources. So in advanced forecasting, using artificial intelligence and big data, very important role. Then real-time monitoring, very important for a highly distributed yet connected grid. So the role of IoT increases. Then you see the nature of distributed plants. For example, in AMU campus, we have right now 41 solar plants distributed throughout the campus. So as the number of plants is increasing, their monitoring, control, management becomes challenging. So you need increased role of IoT-like techniques to provide better real-time information. Then making sense of this data is also very important. You are getting huge amount of data. You have to utilize this data to generate some useful actions. Apart from solar plants, smart meters are being deployed. They have very fast sampling rate. Then another very important component, PMU, is coming up. That also has very fast sampling rate. So you need to analyze this large amount of data and make sense of it. You need to take important decisions out of it. Then sometimes when the energy generated is more, you need to curtail the generation. So that is also an important area of concern, and where data analysis and proper actions can play a very important role. Then another very important development is transactive energy, peer-to-peer energy transaction. Like this Airbnb, I'm sure you are aware of it. The similar concept is being extended to energy when a customer has excess energy and he is transacting this energy with another customer without any third party. So blockchain has come up as a very important, useful tool for it. Already a pilot project in UP has also been completed. But I am saying that again, this involves a lot of transaction of data and its analysis. Then for asset management, your assets are getting distributed. Automatic detection of failure in real time. Of course, the more information is close to real time, the better actions you can take. A very important related development which has occurred in India, we have developed 11 renewable energy management centers located in different cities strategically. So what we are doing through these 11 centers, we are monitoring 55 gigawatt of solar and wind energy plants. A very important role of these centers is AI-based forecasting and scheduling. So you are trying to get, on the one hand, you are trying to get better data in the sense that which has higher sampling rate and which is more close to real time. And you are also trying to involve certain kind of intelligence in it for its better analysis. In fact, different studies in the world have shown that up to 30% improvement in forecast when you are using artificial intelligence combined with big data. So this is leading to better monitoring and situational awareness in the power grid. So with these centers, India has joined this League of Select Nations, 5 or 6 nations only in the world, which have such kind of facility. So I in the end, I would say that we are going through a very, not only India, all over the world, and India particularly, there is a huge transformation. But for a successful transformation to this new green energy setup, as well as its effective management, we need this data is critical. Data as well as its analysis is critical to this transformation. Because you see, the new system requires a complex coordination between the grid operators and the that is the smaller system-based operators. So data, and of course, not only data, but its access to the data, quality, equality, all are the important factors which we need to ensure. And in fact, there is what we are seeing is ultimately it may lead to a setup which is Internet of Energy, which will look like the internet which we have today for Internet of Data. We may evolve a system which is Internet of Energy, and a lot of important functions and a very crucial role is being performed by the data and its analysis in this green energy transition. So that is all from my side. Now I'll have your questions. If you have any questions, you can ask.
Thank you, sir. Everyone, please write your questions in the chat box if you have any. I guess there are no questions. Then thank you, sir, for your enlightening words. It was pleasure to listen to you to give these insights about the data that we can use in a green energy transition. I believe your words have set a new level of expectation in green energy and this transactive energy, which was like peer-to-peer energy that our students would actually aspire for. We should actually see how data can be acquired, analyzed, and then how can that be used for your energy transition. So thank you so much, sir. On the behalf of this Amity University, Uttar Pradesh, I would like to extend my warm gratitude to you. Thank you so much.
Thank you.
Good afternoon, everybody. So let's move on to our next session. Good afternoon to one and all the participants which are present there in this session. We will continue with this session with our Dr. Simon Simon. On the behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I extend my warm welcome to you, sir. It is my pleasure to invite you for the keynote session. Sir is currently the Dean of the School of Computing, Engineering and Mathematics at the Western Sydney University. He was previously a professor of IT at the University of Technology, Sydney. Prior to UTS, he held academic positions at the University of Sydney, the Middle East Technical University, Ecole Polytechnique, the University of Netherlands and Istanbul Technical University. In 2006, he was a BIT professor at the Free University of Bolzano, and the University of Toronto. He is founding director and a fellow of Institute of Analytics Professionals of Australia. Currently, he is an editor of ACS Conferences in Research and Practice in Information Technology series in Computer Science and ICT. Prior to that, he was the associate editor of the American Society of Civil Engineering, Journal of Computing in Civil Engineering. Currently, he serves on the ASCE technical committees on data and information management and on the intelligent computing. Sir, we heartily invites you on the platform to share your valuable knowledge. Over to you, sir.
Thank you, Dr. Segal, and thanks for the invitation to Amity. During Dr. Richen's presentation, I changed my background because he was talking about United Nations Sustainable Development Goals, and our university is quite heavily committed to that. That's the university, that's the Western Sydney University. I'll share now my slides, starting, but midway I'll change back to the Amity conference because I associate myself very closely with Amity, and yes, and it's always enjoyable to present to you and to the students of Amity, and this year in particular, you can see the slides. Yes, just checking. Yep, all coming. Okay. Yes, this year in particular, I was probably influenced by the other session in the program, which was saying industrial session, first industrial session. And I think, excuse me, students, the practical aspects, what happens in industry related to machine learning projects in different forms, are quite important for the students that are coming from the academia. That's why I decided to present on how causality and interpretability in machine learning is handled in industrial machine learning projects. So this will be a relatively focused keynote, not the technical, but more on the importance of the things of understanding of the outcomes of machine learning projects, because this is the result of the change in data analysis about which Dr. Richen was, the importance of which Dr. Richen was talking. This is, I have to acknowledge my industry partner, and this is a very entertaining work for me because I'm coming from the academia, and this has been developed with an industry practitioner in the field of machine learning and data analytics. So this is Dr. Ina Kolishkina from an Australian company. She's an owner of that, and analytic.com. That has quite substantial range of several millions of dollars in terms of annual income from analytics projects. Very quickly, I know that Western Sydney University is known with Amity, but this is just to give you a quick snapshot. The student population by Australian standards is quite big. We are one of the largest universities in Australia with nearly 49,000 students now. And And we're now within the top, actually, this is a little bit old slide. We're now in the top 34 universities, young universities in the world. And we are scoring quite well in on the impact rankings around the United Nations Sustainable Development Goals. This is very big. This agenda is very big with our university, and analytics is also part of it. Data science is also part of it. Quickly about my the outline of my talk, and as I promised, I will change my maybe my yeah, no, I couldn't make it. Just a second. Yeah, yeah. So the outline, I'll talk a little bit about the specifics of industrial machine learning projects as opposed to those that we are doing in-house, and then I'll talk about what is the interpretability causality in industrial machine learning projects. In my previous presentation last year, I talk in details about that, so I wouldn't talk now much here. I'll talk why it is a need for explicit treatment of interpretability and causality in machine learning process methodologies. What does it, why it is required, and why do we need that? And I'll be sort of giving the update. Last year I presented on CRISP-ML, cross-industry standard process methodology for machine learning, and which includes interpretability, and I'll present about how actually it has been updated to deal with causality, and I'll give you some examples of that, and that will be concluding after that. So now, industrial machine learning projects, why I focus on industrial machine learning projects? This is because they have always definitely the aims of conducting them is really to improve business performance. How that is measured is a matter of defining the project, and you'll see in the examples, but it is focused on improving business performance, which differs from research, from blue sky research that could be for discovering a new knowledge, new principles, moving science forwards, and so on. On the other hand, they include a lot of stakeholders, and I have started with the modeling team that can be either external or internal to the organization, and those who are finishing engineering, finishing computer science, they have quite with quite high probability they will be involved as machine learning engineers, as data scientists, and so on. However, part of these projects include, part of these project teams are also executives of the organization. These are high-level standing people who actually operate in high-level terms. They may not necessarily be that technical, but they operate with the customers. Sometimes we may have involved domain experts, end users, could be a legal team, representative of the legal team. The organizations usually have a business intelligence team that converts what is found and what is done with the data into actionable sort of knowledge, specific actions, and they need to understand actually what they're doing and why. And of course, the information technology team that implements the solutions, whether it's an embedded machine learning solution or it's some additional infrastructure. And at the bottom of the slide is one of the papers that you may wish to have a look on for the details of many aspects of these methodologies. Now, as I promised, interpretability and causality in industrial projects. In the early days, and until recently, I would say until 2014, 2015, mostly machine learning data science projects were focused specifically on accuracy, on predictive accuracy, as of the solutions, not much on anything else. Interpretability came later when there was success in neural networks, in deep learning, and that success led to the massive use of black box models, which you provide them with some input and they produce some output. That may be a very accurate output. However, areas like medicine, doctors have difficulties in trusting that output because there is a little understanding of how it has been achieved. So causality came as part of the interpretability to further refine these aspects. And for instance, when there is need for an intervention, let's say medical treatment, policy change, maybe some specific change in the environment along the lines that the previous keynote speaker talked, then it is important to know what may cause what kind of input or what kind of interventions can cause what kind of output, what kind of outcomes. And currently there are lots of frameworks. Again, in that same paper we discussed that there are many frameworks, methods, and algorithms and software that offer partial means for utilizing in interpretation and causal insights. However, in many of them have just been developed or in early stages of development. They are still not completely completed. And the combination of interpretability algorithms with machine learning algorithms and data analysis algorithms is not that well established, and that requires this need for having an opportunity to guide the teams that conduct machine learning projects in composing the right combination of methods for doing the data analytics and methods for the interpretation. Because still more than 80% of the data science actually projects fail to achieve their goals. So a project is considered a failure if it hasn't achieved the starting goals. Many times this is because the starting goals were set up in a way, in a very demanding way that cannot be backed up by the available data or the choice, later choice of the machine learning methods. Hence is the idea, and I have put quite a bit of text on the slides, but this is knowing on Zoom that it is better to give you an opportunity to read some of them. Hence, that's why it is important to have explicit treatment of both interpretability and causality in the machine learning process methodologies. And again, in that sense, I would say that we're doing some pioneering work. And last year, again, I reported of how that has been done here at Amity. Again, why it is important is because the gold standard for establishing causality remains the experiments, the scientific experiments, where you actually can select the factor that you're measuring by the design of experiment and the appropriate data analysis methods. However, currently, we are drowning in observational data that is collected just because it has been collected. The process from sensors, from other sort of areas, or sometimes it is not ethical to conduct an experiment, right? So for instance, a lot of things are coming out of social media and so on. So to derive causal insights from such data, there needs to be some conditions put in place in the project, so that it is important to have an appropriate domain expert who can actually provide some guidance in terms of how these bits are done. And also, why is that becoming again so important to be aware of the limitations? Is because predictive modeling methods, if used with such data, perhaps with some bias in it, perhaps with some other elements of noise, they may, if they're used for causal inference, they may actually result in quite questionable insights. And last year, actually, I presented a little bit of that with in the domain of selecting pre-selection for positions in companies when these things are done based on facial analysis and attempt to derive features for features related to character of the person. And the training data set was actually taken from from the wrong, not the wrong, but from irrelevant sample of people. Anyway, so that's why we need. This is still the motivation part. Now, what has changed since my last presentation, since the presentation last year? If there were some people at that one present, I mean, CRISPR-ML. I would just remind to everyone that this methodology it is industry neutral, can be applied anywhere, and it's method neutral. So it allows combination of methods. It is capturing just it has the requirements for capturing the appropriate combination of the methods that are used. It reflects the recent advances in machine learning, and its biggest feature is the explicit embedding of interpretability and causality aspects. A key aspect in CRISPR-ML is the establishing of shared understanding across all key holders that I mentioned in the beginning, all those people involved in the project, about at what level they agree for interpretability, whether they who needs what kind of what degree of interpretability, who needs to understand the algorithms, who needs to understand to have only algorithms that are actually operating with the outcomes of the machine learning algorithm, and provide some like SHAP, like LIME, and provide some form of interpretability data. And now, as I promised, we'll demonstrate that on some examples. This is the process diagram, and today we'll just really focus in this keynote. I'll focus on only on first and second step from the process diagram. Again, it is this is another paper recently published in IEEE Big Data 2021, where and presented there, where the details again of each of these steps is discussed it's discussed in details. So stage one is that's what is important. It is where the stakeholders are establishing and agreeing on what is the necessary level of interpretability and causality, and whether causality should be present or not. There is on this slide, there is a list of questions that a machine learning solution should be answering. I mean, what decision it should make to help, it should help to make, and what are the risks with these decisions, Is it used for causal decisions, or it is used just for predictions? For instance, if we take the university environment, is it used to predict just how a student will perform, or it is used to find the reasons why a student may have difficulties in a specific subject? That's where causal decision is done. What is the minimum acceptable level of interpretability accuracy balance? Because in some sense, those methods, machine learning methods that have explicit and explicit are interpretable, are human interpretable, like decision trees, like various kind of decision trees, or various kind of regression, linear, non-linear, logistic, and so on. They provide sometimes less accurate results, easier to explain, but less accurate. Which one is of greater importance, whether the interpretability or the accuracy? And an important aspect here is also the development of trust among the stakeholders in the building aspects and in the models that are coming out. And as I mentioned, the second stage is playing crucial role in this sense here. Is if we have agreed in the first stage, if the stakeholders have agreed on a necessary level of interpretability and causality that should be achieved in the project, is the data quality, is the data sufficient first? Is the data the appropriate quality? And if there are any issues, how they can affect what has been agreed in the beginning. That's the point that I made earlier, that this is where you're sort of setting whether the project will succeed or not. You may wish to lower expectations or agreements because the data source is not sufficient. And of course, find the domain experts, especially if there is a causality aspect there, to work with them for embedding domain-specific knowledge. For instance, recently with the COVID, periodically there was coming new domain-specific knowledge, which helps analyzing finding causal relations there. And as I mentioned, if causality is part of what is planned in the project, then domain experts have to be there to look with the usually with the causal models, usually they're graph models, and to consider what are valid things and connect and provide kind of semantic connection with the domain in which these things are happening. I will sort of give you in the third example. So the first example, and these are very high level presented examples, just to illustrate you. The first one is from an easy area, credit risk and the loan default problem, especially with the financial difficulties that have been around. So obviously, there are a lot of solutions there. The banks are usually having these solutions to assist with which loans the bank should predict. When they specify the objectives, what is important here is that there are no decisions related to policy changes, right? So there is not much big need in any causality here, right? So so what is important in terms of interpretability accuracy balance? Well, at least 85% of the variability among the population that applies for loans should be explained by the model. And the model must be clearly and easily interpretable, because if you don't get the loan, you have the right to ask why I didn't get the loan. And the Freedom of Information Act in Australia, for example, allows you to pursue that. You may have, sometimes there may be some industry or sector requirements that the solution needs to comply. So, for example, here it is sometimes in finances, industry regulator forbids model features that are related to include in modeling features that are related to race, for example, country of birth, or even the letters, the number of letters in the surname, right? So, so these are rules, and the other thing is that in the financial area, historically it has been expected always that the outcomes and the algorithms, if they work, or the models that are coming out, should be presented in a linear form, so that they are, again, easier for explanation. And at the bottom of the slide, in the colored box, is just what kind of solutions can be taken in the first step, in that first step. So, for instance, logistic regression or elastic net regression can be applied, used for the modeling, and also on the second stage, as I showed before, there will be a separate analysis of whether the applicant's history with the bank is sufficient for getting the appropriate solution. Now, in public health, it's much. This example has a bit more aspects into it. That's the here it is. It's focused on the early childhood, age 0 to 4, where the development is critical of the kid, and it's taken from a project done with an Australian state, one of the Australian states, that wanted to reduce related issue and with the kids, and identify immediate interventions. That was phase 1 of the project, as well as a roadmap of strategic development for the next 3 years. That was phase 2. So the data that was available was pretty large amount of data was available there, quite big amount of data. However, not necessarily of the best quality. That was with missing values. This was census data, geo and climate, socioeconomic data, and so on. You can see on the slide public health data. Lesser requirements towards variability by the model. Again, clearly interpretable model, because it was necessary to find the connections, the causes and effects, but there were no legal or other requirements for the solution. So again, any well-fitting interpretable machine learning model can be suitable for, if multicollinearity is addressed. At this stage, there was no need to select a specific model. Just the only thing was to be interpretable. And in phase 2, additional causality aspect came in presence, because it was necessary to define what were the reasons in order to avoid them in the next 3 years. So that again adds another twist to the project. And domain knowledge was used in that at that stage, like knowledge of some specific of child population, some family knowledge about families, about culture in those families. That was added in the data. And very quickly, the third example is in the oil and gas. That's just to give you a quick idea about the domain expertise in causality. In this particular case, this is an Australian sort of oil platform, and there was an issue with stripping of the unnecessary components in the oil that has been extracted. Stripping is a process that takes away physical separation of some of the components of the oil that comes. And this, what you see here, was the causal model that came out of the algorithm. don't focus on methods and etc. Just imagine that an algorithm has been applied, and this is the causal model that came. Every arrow shows the impact that the attribute in the beginning of the arrow has on the attribute at the end of the arrow, and the causal impact. So to what extent the strength of that causal connection. The number on the arrow shows the strength of that causal connection. And when we looked as analysts, well, it was very difficult to make some sense. But then what happened was that the domain expert took that model and put it, all those nodes, he has put them on the actual device, on the actual schema that operates and with all those points that are operating on the refining of the oil. And it was identified, going back to this, that in the upper end, the circ pump node with its 86% impact on stripping gas pressure really has been the main cause of the issues that were happening, and the issues were really much lower quality of that. But more importantly, what came out was the impact of that secret pump on the input, this inlet differential, which when it was seen here on this diagram, became much clearer in the process. So I'm almost at the end, but again, why we focus on the interpretability and causality? Because of the risks in the decision engineering. And this is a snapshot that I have put last year in the presentation, and you can see that in the definition of artificial intelligence by the World Economic Forum, the ontology, and you can see that in 2021, there were only a couple of attributes related to ethics and values and human enhancement and assistance. This year, 2022, just now before presenting to you, almost everything, I have not included AI and COVID, but probably that can be included too, is related to the aspects of human presence, not to the technical aspects, and include those issues that we are talking about: the need for explainable AI, the need for interpretability and causality in machine learning. And in conclusions, the most important is to establish the shared understanding. That's number one, which then reduces the risks of selecting an approach with low chances to reach project objectives and spend the money for nothing. And well, it's CRISPR-ML has proved that to assist, and in general, process methodologies that include interpretability and causality have proved to assist in achieving that. Thank you so much. Thanks, everyone. And any questions?
Thank you, sir. Any questions from the participants? Please, you can write them in the chat box. Okay, then. Thank you, sir. We feel very privileged to have your supervision backing on us. Your talk handling causality and interpretability in industrial machine learning projects was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth in the field of machine learning. It was great to hear about your update on CRISP-ML process methodology from the last year presentation and the various examples that you gave. It was very useful, and how it had led to reduction of risk in various projects. Thank you, sir. Knowing that you are so busy, we appreciate the time that you have took to impart us with your valuable knowledge. We are highly grateful to have with you, sir. Thank you so much, sir.
Thank you. Wishing you a great conference. It's a pleasure.
You.
It's been pleasure, and enjoy it. Thank you.
Thank you so much, sir.
हेलो मैम, लीना मैम,
हाँ जी, हाँ जी, हाँ जी।
नीचे देखिए स्टार्ट स्टॉप वीडियो का ऑप्शन दिख रहा होगा आपको, जहाँ से माइक अनम्यूट किया ना आपने।
हाँ, स्टार्ट वीडियो।
हाँ, उसके साथ में एक एरो है मैम, छोटा सा, उस पर क्लिक कीजिए, चूज वर्चुअल बैकग्राउंड
वर्चुअल
दिखेगा।
बैकग्राउंड।
हाँ जी, उस पर क्लिक कीजिए मैम। अभी देखिए राइट साइड में विंडो खुली होगी, उसके राइट साइड में एक प्लस का आइकन बना हुआ है छोटा सा, उस पर क्लिक कीजिए। हाँ, उस
ऐड इमेज।
ऐड इमेज। अब मैम विंडो ओपन होगा जहाँ पे आपने वो इमेज कॉपी करके रखा होगा
डाउनलोड कर
डेस्कटॉप
रखे हो।
पे या
हाँ,
डाउनलोड में,
हाँ, हाँ,
वहां
वो
से
मैं
इसको
कर।
सिलेक्ट कर लीजिए बस।
ये उल्टा क्यों आ रहा है?
मैम आप एक बार कैमरा ऑन कीजिए। मैम देखिए वहीं पे एक रोटेट का ऑप्शन है, आप वीडियो सेटिंग में जाइए।
हाँ, वीडियो, जहाँ वीडियो है वही।
हाँ, वीडियो सेटिंग ओपन कर लिया मैम आपने, सबसे नीचे। अभी आपकी वीडियो दिख रही होगी, ऊपर देखिए सबसे उधर राइट साइड में एक छोटा सा घुमाने का रोटेट का ऑप्शन दे रखा है।
हाँ, रोटेट 90 डिग्री।
नहीं, तो आपका कैमरा रोटेट हो रहा है मेरे ख्याल से। हाँ मैम, ये इमेज ही तो उल्टा नहीं है, एक बार ये इमेज ओपन करके देखना जरा।
नहीं, इमेज सीधी है, मैंने चेक कर ली।
ऐसे कैसे हो सकता है? एक सेकंड
2 बार चेक कर चुकी है, मुझे पता नहीं है क्यों ये उल्टा क्यों आ रहा है मेरे में। या मुझे भेज दो, कोई और है तो। ये तो पूरा ही रोटेट हो रहा है।
हाँ, ये पूरा रोटेट हो रहा है, इसमें ऐसा होना नहीं चाहिए मैम, ये ऑप्शन मैं चेक करता हूँ मैम एक सेकंड ना।
अच्छा, हाँ।
बाकी आप बोल दीजिए जो हमारे गेस्ट हैं उनको ज्वाइन करा दीजिए।
अच्छा, एक देविका स्टूडेंट वो कर रही होगी, उसमें होगी।
हाँ कोई नहीं, अभी ज्वाइन हो गए तो मैं उनको एडमिट कर लूंगा। अभी
हाँ,
ज्वाइन।
देविका और करणदीप, बस ये दोनों होंगे।
ओके मैम, ओके।
मेरे को ये बताना फिर एक बारी।
हाँ हाँ मैम, मैं देख रहा हूँ।
And examination don't say that it is going to be student type of examination, but certainly we like to see what type of take home you are going.
हेलो,
you are taking from it. So
मकसूद एक बात बता, वर्चुअल बैकग्राउंड उल्टा कैसे लग सकता है यार?
And our own purpose is that
वर्चुअल बैकग्राउंड उल्टा आ रहा है, उल्टा मतलब उल्टा।
we must do it differently and we must.
हाँ, नीचे का हिस्सा ऊपर हो गया।
That what is the outcome that is generated.
हाँ वही मैं कह रहा हूँ, ये कैसे हो सकता है?
Communication tool without saying it goes.
नहीं यार, वो कह रही है, मैंने बोला मैम इमेज तो आपकी ऐसी नहीं है। ये नहीं, इमेज ऐसी नहीं है, ये ऐसे ही आ रहा है। हाँ वो तो सीधी दिख रही है मुझे, उसका खाली वर्चुअल बैकग्राउंड जो लगा रही है ना वो उल्टा आ रहा है।
The importance of great communication in business cannot be understated, and there is no shortage of communication tool on the market. So I was going through some of the communication tools that are available over here, a digital communication tool.
Hello ma'am.
Bring all of that
Leena ma'am.
together under one system. It is simplistic.
हाँ मोबिल।
मैम वो इमेज तो सीधा है ना, मैंने क्योंकि जो हमारे और कलीग्स हैं मैंने उनसे
शेयर करके दिखाऊं? हाँ मैं दिखाऊं आपको, मैं बिल्कुल सीधा है वो। ज्वाइन करो देविका।
मैम वो इमेज मुझे व्हाट्सएप कर देंगे?
हाँ मैं करती हूँ मोबिन, अभी करती हूँ। मेरे को नंबर यही वाला है आपका व्हाट्सएप का?
हाँ जी, हाँ जी, यही है।
मैं अभी करती हूँ।
मैम, लीना मैम।
हाँ जी
मैम मैं चेक कर रहा हूँ, मेरे को सीधा दिख रहा है, मतलब आई मीन मेरे सिस्टम पे ठीक
है,
वर्क कर रहा है।
ठीक
तो
है
आप
फिर,
एक
ठीक है।
काम कीजिए मैम, अगर नहीं हो रहा ना तो एक बार लीव करके ट्राई करके।
मोबिन प्रोफेसर वासिल इज हियर, एक बार जस्ट एक बार चेक कर ले।
यस यस
सर गुड आफ्टरनून। सर यू आर म्यूटेड।
Hello, good afternoon. Can you hear me?
Yeah, sir. Absolutely. I'm hearing you.
Can you see me?
Yes, sir. You are absolutely fine. Sir, can you put
Yeah.
the... Sir, can you
To share the screen?
Yeah.
Okay. Where was sharing? Sharing here. I'm sharing my screen.
Yes, sir. Absolutely
Show
fine.
from again. Yep, I'm ready.
Yes, sir. Yes, sir. Just give me 5 minutes. We will start. It's only the 5 minutes.
Okay, so it is 5 minutes to the beginning.
Yeah, it's 5 minutes to begin because right now it's
Okay.
2:10. We have to be started at 2:15.
Yeah, okay, I'm ready. So whenever you give me a signal, I will start.
Okay, sir. Okay. So, sir, you are here?
Yes, I'm here.
Yeah, okay,
Just give
fine,
me a
sir.
signal.
Yeah,
Just
okay,
give me a signal when to start.
Oh, yes, sir. Yes, sir. Yes, sir.
Hello, sir. This is the
Hello?
IT. Yes, this is the IT host, sir. Your presentation working fine. Can you stop sharing once ma'am read your profile? After that, you can share, sir.
Okay, so stop sharing.
Yes, yes, please, sir. Thank you, sir. In 2 minutes, we are going live.
Okay, ready?
Ma'am, we are on live. You can start, ma'am.
Okay, okay. Yes, Devika, start.
Thank you, ma'am. Good afternoon to all dignitaries, professors, and participants present today. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I, Devika Soni, a final year student, feel privileged to extend my warm welcome to one and all to the keynote address for CONFLUENCE 2022, 12th International Conference on Cloud Computing, Data Science, and Engineering. Even though we would like to invite you to our campuses live, but having the keynote session in person, current world scenarios impede us from doing so. Luckily, we're grateful to have this opportunity to keep the keynote session in a virtual mode so that our students can reap the seeds of knowledge gathered in this session. Today, I'm profoundly elated to take this opportunity to invite our honorable speaker, Professor Vasil Vasilev Sir. He's a professor for AI and Intelligence Systems and head of Cybersecurity Research Center at London Metropolitan University. Sir has contributed diligently in different forms of collaboration with academic and industrial partners from both the UK and the overseas, joint structural and research projects, innovation projects, consultancy, and knowledge exchange is a man of distinct vision. So you are a vibrant example. So you're an idol of knowledge, experience, and inspiration to many of the domains such as AI, hybrid intelligence, semantic technologies, and the applications to cybersecurity, whereby Sir has graduated with MSc in Electrical Engineering from the Technical University in Sofia and obtained a PhD in Artificial Intelligence from the Bulgarian Academy of Science. So you hardly need any introduction. Sir has founded the Department of Informatics at New Bulgarian University and led several EU.
Hi, the signal was interrupted. Is it on my side or your side? I don't know.
Our side, the signal has been interrupted.
It's back. Should I start?
Yeah, so just give me 1 minute.
Okay.
Yes, Devika, please continue. I think your signal has been interrupted.
Apologies, ma'am. So sorry that we're all in this virtual world. Humbly apologize. Sir graduated with MSc in Electrical Engineering from the Technical University in Sofia and obtained a PhD in Artificial Intelligence from the Bulgarian Academy of Sciences. Sir, you hardly need an introduction. You founded the Department of Informatics at the New Bulgarian University and led several EU-funded projects dedicated to the transformation of higher education in Bulgaria. With so much on board with his technical acumen and distinguished work, so we invite you on this platform to share a few words with us.
Thank you. I'm sharing my screen. Can you see my screen?
Yes, sir.
Yes, sir. First of all, good afternoon, Delhi, and good morning from London. I'm currently based in London. I don't need to repeat the words. I would like only to say that this is my third time appearance at Amity University. After the first time I visited in person. Unfortunately, during the COVID, we were unable to come back again, but obviously the people remember me because they keep inviting me, and this is my third time presentation. This time, I'm going to talk about parameterization, containerization, and orchestration of data services, which in a sense continues my last year talk at Amity, but of course it goes further. What I'm going to talk about today. First, I will give you some history of the current project. Then I will very briefly touch the design principle behind the cloud-based data platforms. And then I will consider two use cases, namely the threat intelligence framework of the Cybersecurity Research Center here in London and the Smart City framework of Gate Institute in Sofia in Bulgaria. And I'll finish with a few words about the European data spaces as a new European movement. Some history first. Our center at London Metropolitan University is dealing with cybersecurity mainly. Some cloud-based cyber security services are already available from the leading cloud providers such as Amazon, Google, Microsoft. The big organizations, though, are still a bit reluctant to send data to the cloud for processing for various reasons, obviously. The small and medium enterprises are, on the other hand, unable to afford such services due to the high costs, while the managed data centers, which are providing services to small and medium enterprises, are unable to provide such services due to the high investment cost needed. So this creates a bit of a problem for small and middle range organizations dealing with security services. The Cybersecurity Research Center of London Metropolitan University has several roles within the academia. First, we are running Cisco and Palo Alto academies. Secondly, we are operating our own security network, which is not connected to the university network, but directly to the internet for teaching, research, and innovation projects in the area of sensitive areas of cybersecurity, of course. We managed to establish, and we are currently running our own private cloud based on Kubernetes. And for several years, we've been working on developing our own security framework for threat intelligence and security services on the cloud. Our funding comes from various sources. We started with Lloyds Banking Group and some private companies in London, a few government grants from UK government research agencies, and finally, through our partners, we are also obtaining some European Union funding. Unfortunately, after my visit to Noida 2 years ago, the COVID-19 struck. Actually, my visit to Noida was one of the happiest moments of my time before these pandemics. Since then, for a year and a half, I haven't been to the building of my university. We've been working from home. We started the threat intelligence framework several years ago with two projects for Lloyds. But when the COVID-19 struck, we realized that we are in the void. So this is why we immediately looked for Plan B, and Plan B existed at the time, thanks to my good relationship with my home country. Gate Institute of Sofia University, the biggest university of the country, newly established organization funded by European Union, which provided the opportunity to work since our center was closed and the university was closed. The follow-up of all this, which I will present shortly today, is currently on the way. We are currently trying to apply for a new grant from the MOD of UK to propose our framework for security and safety of the nation. But staying in Sofia gave us the opportunity to look into neighboring areas. So we worked with GATE on the so-called Urban Data Space project, which actually started in London as a collaboration between our center and the Communications Technology Center of the university, mainly exploring the various opportunities provided by contemporary IoT. But when we started working with GATE, we went into the real world, and the first phase of the City Digital Twin project on the GATE platform will be touched today. So briefly, the design principles behind the cloud-based data platforms in general. Last year, in my talk at Amity, I talked extensively about the vertical layering and the theoretical foundations behind this. Today, I'm going to concentrate more on the practical side, the horizontal integration, which is based on the service-oriented solution which the cloud provides. It has several dimensions. First, the data processing journey from the moment the data is generated to the moment the data is presented, the interpretation of the results of the analysis of the data is presented to the end users. Secondly, the containerization, which requires parameterization of the applications, configuration of the containers, and deployment to the cloud container management system. Thirdly, the orchestration of the services, which requires workflow configuration, execution and monitoring of the workloads in the cloud environment. And finally, the synchronization, which requires tidy control over the data access and operation rights, isolation of the various operations, and synchronization of the events. The technological backbone of this is the private cloud infrastructure we have, and which is affordable to small and medium enterprises, to mid-range organizations. It is essentially service-oriented architecture running its own private cloud. The major components of such an infrastructure are, first, the data unification, the possibility to use metadata description to separate physical and logical data types, abstract and specific operations using unified data. Secondly, it's the operation hybridization, combining of domain-specific ontology with domain-independent logic of data processing, which is actually one of the strongest points of our own framework. Program code parameterization is required to make the data analytics real, reusable, and working within this environment. Software component containerization requires packaging of the applications, putting them within containers, and deploying them to the cloud. This may include automatic generation of the configurations, but it can be also done manually, so there is a big flexibility here. And finally, service orchestration, which deals with execution of the components within the container workflows for following specific tasks. All this technological means allow you to achieve multiple advantages of the framework: modularization, robustness, interoperability, reusability, extendability, scalability, maintainability, and even explainability, which is one of the hot topics in contemporary AI. Of course, this requires a variety of technical inventories. First of all, we need different protocols. In our framework, standard protocols: TCP/IP, HTTP, MQTT, Kafka. We need multiple repositories for storing the data, the metadata, and the knowledge graphs which are dealing with the knowledge models. For this purpose, we are using HDFS, NoSQL, and SQL databases, knowledge graph repositories such as GraphDB, Neo4j. We need to be able to process the data in different modes: at the edge, on the fly, in storage, in memory. At the same time, we should be able to perform this processing in a different time modes: completely offline, completely in real time, in pseudo real time. And this should be done by using a variety of different algorithms: statistical, machine learning algorithms, deep learning algorithms, reinforcement learning algorithms. So huge inventory of tools. What this can give us is the possibility to devise use cases using suitable data sources and data processors, which suits every need within the scope of the available resources. So this diagram, for example, shows how we can combine various modules on the cloud in order to do certain useful work for cybersecurity protection. It can deal with initial detection, more advanced classification and correlation, up to prediction in order to devise a potent strategy for prevention of security threats. The threat intelligence framework of our cybersecurity center in London deals with this variety in a pragmatic way. We started with the edge, with IoT based on standard components, CSP, controller, Arduino, and Raspberry Pi kits. Using our partnership with Cisco and Palo Alto, we are also using some Cisco and Palo Alto equipment. As far as the transportation of the data on the net, we are using FireWire, Firebase, Mosquito, Kafka, and NiFi. The databases we've been using Postgres database, MongoDB, NoSQL database, Hadoop HDFS, Neo4j. For data analysis, we've been working with a variety of machine learning algorithms. I will mention some of them, I'll give you examples of them, mainly written in Python and Java. In the future, we are also projecting embedding Spark into the framework. For ontological analysis and leveraging the use of knowledge intelligence graphs, we are using the standard languages of the semantic web RDFL and SWRL. The containerization of the components and the orchestration of the services and monitoring the execution on the cloud, we are using standard containers such as Docker, container management systems, Kubernetes, MLflow, Airflow, all public domain software. Actually, you don't need to pay anything for this. And that's how we've been doing it. Conceptually, we are considering the two sides, the client side and the server side. The client side at the edge, where the data is generated, transporting this data to the cloud for centralized processing behind the curtain of the cloud, using a variety of methods. The off-the-shelf software we installed on our cloud server, for example, and later on we did the same for Gate Institute in Sofia, is shown on this picture, starting with the standard operating system Linux, application management using the Docker container management using Kubernetes management system, service management using Airflow, MLflow, Zookeeper. All of this, again, public domain or community versions of commercial software. The only commercial software here, MongoDB, Cesium, Ion, we've been using them through the community versions. So practically the entire infrastructure we created for establishing our client server and services on it is based on public domain software, free software. Our server opens a number of ports for external use and some ports for internal use for inter-container communications. This table summarizes the open ports both for outside and inside use. How we are collecting the data? We are collecting multiple sources both internally and externally, but for the purpose of the first project, after several years working with real data at Lloyd's, we generated our own data. We generated our data within a protected environment. We used Sandbox, running infected software and generating bot traffic and log events, which we can analyze on the cloud. We were transporting this data to the cloud, using MQTT protocol, using Kafka protocol, and we were letting the cloud do the analysis there. In order to prevent unauthorized intrusions and damaging of the data, we experimented with a number of encryption algorithms for encrypting the data, which is shown on this diagram. But essentially, we were concentrated more on the processing than on the encryption. On the cloud, we were performing 3 different levels of analysis of the data gathered from the edge. First, the preliminary analysis is based on purely statistical method. We were using correlation algorithms, Pearson correlation, to compare the traffic packets with the flow of events generated by the network analyzers. Then we were doing some initial recognition of the suspicious packets in the network based on algorithms for classification. We use support vector machines here. And finally, after the data was gathered in a sufficient volume, we were performing some deep forensic analysis of the trends in order to predict the appearance of malicious package and to organize prevention. That's just a summary of results of the classification using SVM and the prediction using convolutional neural network we implemented on the cloud. In the first version of our framework, which we finished just before the pandemics, our dashboard was running out. We implemented very sophisticated standalone application, which was able to create the network for orchestration of the services and to manage it in real time. Unfortunately, after the university and the cybersecurity center was closed, we weren't able to continue working there. So we continued working remotely. And because of this, we adopted the standard tools for monitoring and managing the workflows on the cloud. For this purpose, we use Airflow, which allows you to orchestrate the analytics engines on the cloud and monitor their execution together with Airflow. That's pretty much the brief about the cybersecurity project we finished in July. Based on this, because of the goodwill of Gate and the success of this project, Gate decided to employ us for the initial phase of their urban data space project, which was meant to transfer the city digital twin project results to the cloud platform. Gate was an European Union project funded under Horizon 2020 with 50 million from Europe, plus 15 million matching funding from the Bulgarian government, and the support of 2 Bulgarian companies, Real Solutions and OnToday. Their partners include, first and foremost, the project partners from Sweden, Chalmers University in Gothenburg with the Knowledge and Innovation Technologies Institute attached to it. And next, several partners from European Union countries, from Switzerland and United States and UK. In the Urban Data Space project, the idea for utilizing the data platform is similar to the idea we used to utilize the platform for cybersecurity purposes, but here the data, the business cases are quite different. So for example, here we are dealing with sensor data coming from the life environment in Sofia. We are dealing with citizens' complaints about the pollution, and we are analyzing this data in order to find the polluters, the potential polluters, in order to provide decision support for the decision makers related to designing of the urban spaces. There are several different sources we used in this project. First, historical data about the environment pollution in CSV files gathered over a period of 5 years. Then hourly updates in real time of the outdoor conditions using real-time sensor measurements, which generates JSON stream of measurements. The citizen complaints from a help desk database provided to us in the form of Excel files. The indoor conditions in specific buildings, again, measured and formatted in JSON streams. the 2D map of the city, and the 3D model of an urban area of interest for Gate Institute, and finally the ontological model of the metropolis in RDF. There were 8 main data services foreseen in this pilot project. First was the data collection from the sources, both sensors, files, and databases, external databases. The data pre-processing at the source, the transportation to the cloud, the post-processing on the cloud for filtering, correlating, buffering of the data, the data ingestion into the different data sources, the visualization on the web, the analysis, and finally the migration of the data to the data lake, which currently runs on Hadoop for providing support of the future Gate urban data space. 5 use cases were in focus of this project we just finished a few days ago. First, it was the statistical data analysis for detecting the pollution of in the city based on the sensor data. Secondly, it was formulating the trends by analysis of the historical data about the air pollution. Thirdly, identifying the polluters by performing some logical data analysis, combining logical data and sensor data. Fourth, to issue warnings concerning the air quality by correlating data streams containing measurements of relevant indoor factors, indoor and outdoor factors. And finally, predicting the tendencies by matching historical trends and current trends. This diagram shows the of the system we implemented on the private cloud of Gate, which we created similarly to the cloud we have in the Cybersecurity Research Center. This illustrates the visualization of the city terrain using OpenStreetMap, which runs within a container on the cloud. This URL is live. You can attend it and see the actual operation. This slide shows the heat map of the pollution within Sofia based on the air quality data gathered from the stations in real time. And this is also available online, and in real time, you can also test it. I know that in India, there are several projects related to air pollution. And I was very surprised when I was in Delhi to understand that in 5 years, Delhi solved the problem about the air pollution. I hope Sofia will do the same, because Sofia was one of the most polluted European capitals, and it was penalized by the European Union for the quality of the air. Some examples of correlation of the indoor and outdoor data, which are showing that there is a negative correlation between temperature and humidity in the indoor sensor data, but positive correlation between the temperature and humidity in the outdoor sensor data, which is not a surprise. This correlation is performed by standard Pearson correlation. As a next phase of this project, we are considering meeting the European standards. The European Big Data Value Association is monitoring the activities within the European space, and a special role in this play 2 organizations, International Data Space Association and Gaia-X, which are initiative of Fraunhofer University in Germany. There is a huge European a movement towards building and providing open source components which allow you to build data space in different areas, led by Fileware, which is a non-profit organization of the European Union, established under Horizon programs of the European Union. Gate Institute is committed to work in this direction in order to become compatible with the network of organizations across Europe, and London Metropolitan University, as a partner of Gate Institute, is considering this as in its own agenda. In order to move to this new phase, we are considering gathering the data into a data lake which runs on Hadoop. Of course, there are a number of different distributions of Hadoop, and currently Gate is expecting the commercial version he purchased from Cloudera. But during this pilot project, we used the free Apache Hadoop, the original Apache Hadoop, which we installed and configured on the server completely from scratch. That's the diagram which illustrates the Hadoop ecosystem on the Gate cloud server. As you can see, we installed not just the core services needed to run Hadoop as a storage, but also elements of the Hadoop ecosystem which allow you to ingest the data and even to analyze it, as well as to interface the data repositories we already have on the cloud. Enabling data spaces requires certain amendments of the cloud infrastructure so that we can support additional services needed to meet the standards of International Data Space Association. First of all, this is identity management. Next, it's the data management, operation management, and finally, it's the service management itself. All this requires some additional work, which is a subject of the second phase of the project we are about to start with Gate in Sofia. Again, my team from London, together with the team in Sofia, will work on this. In summary, parameterization of analytics enables the reuse of service-oriented architectures on the cloud. The containerization supports analytics of demands for various businesses. Orchestration of the cloud services allows us to operate workflows of data processing operations capable of performing complex tasks. And finally, the hybridization allows you to execute more complex use cases, which combine not only data, but metadata and ontological models. So that's my talk. And now the podium for questions, if any.
Can you start?
I just stop sharing.
I said it's going on virtual, so there is no question right now.
I know that it's a tight schedule, so thanks once more for giving me the opportunity to talk. I hope next year it will be live in Noida.
Yes, absolutely. Yes, Devika, start.
Absolutely, sir. We really look forward for the same. Thank you, sir, for your enlightening words. It was a pleasure to listen to you and all of the insights you gave about parameterization, containerization, and all about data services on private cloud, etc. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth in the field of artificial intelligence. I believe your words have set new levels and also for the students to incline their aspiration and inclination. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart your knowledge upon the studenthood. We're highly grateful to have you here with us, sir. Thank you so very much.
Thank you for the kind words. I want to say only two things. It wasn't only my visit to Noida which created my relationship with you guys. I already supervised 2 students from Amity University on a placement during the pandemics, and they successfully finished their assignment. Plus, for my partners in Gate, I recruited one Indian guy from Chennai, and he is actually responsible for setting up the Hadoop infrastructure on Gate. So I hope the next time more people will come and we'll be able to work together, both here in London and in Sofia. Thank you very much for the opportunity. Good luck to the conference. Until next time.
Thank you, sir. Thank you so much.
Thank you, sir.
Bye. Bye from me.
Yes, sir. Our next keynote speaker is ready. Gabriela Caslino, are you here?
Yes, I'm here.
Yeah. Just give me 1 minute for your introduction. Yes, Devika, start.
Thank you so much, ma'am. Good afternoon to all dignitaries, professors, and participants present today. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I, Devika Soni, a final year student, feel privileged to extend my warm welcome to one for the keynote's address for Confluence 2022, 12th International Confluence on Cloud Computing, Data Science and Engineering. Even though we would like to invite you on our campuses just with us to have the keynote session in person, Current world scenarios impede us from doing so. Luckily, we are grateful to have you having this opportunity to have the keynote session in the virtual mode, and our students to rehab the seeds of knowledge gathered in this particular session. Today, I'm profoundly elated to take this opportunity to invite our honorable speaker, Professor Gabriela Casalina, ma'am. She's an assistant professor at CILAB Laboratory and working for the Department of Informatics, University of Bari, Italy. Ma'am's contributed diligently and workings in machine learning techniques applied to the web economy domain. She's a woman of distinct vision. Ma'am, you're an idol of knowledge, experience, and inspiration. You hardly need an introduction, though I'd like to put forward her research interests span in the field of data analysis. Her works cover different domains such as text mining, hyperspectral imaging, bioinformatics, anomaly detection, so on and so forth. She's been awarded by the Italian Ministry of Education with a grant covering 3-year period of her PhD, with so much on board with her technical acumen and distinguished work. Ma'am, we invite you on this particular platform to please share a few words with us.
Thank you very much for your introduction. I would have loved to be there with you in presence, but as you said, it's not possible. But I hope that in future I will be able to attend one of your future conferences. It is an honor for me to have been invited as a speaker, and I hope that my talk will interest you and some collaboration could start. Can I start with my talk?
Yes, ma'am.
Okay. So just a second that I share my screen. Okay, now you should see my screen. And now my presentation, isn't it?
Yes, ma'am, it's properly visible.
Okay. So good afternoon. I suppose that it's afternoon over there in India, is it? I want to thank again the organizer for having invited me. I really appreciated their invitation. I'm Gabriela Casalino. I'm an assistant professor at the University of Bari in Italy. And my position has been funded by the Italian Ministry of Education through an European project, Attraction and International Mobility. The work I'm going to present is a joint work between my university and the Polish Academy of Sciences. And in this talk, we discuss how to analyze acoustic data stream for supporting bipolar disorder monitoring. I work in the Computational Intelligence Laboratory of the University of Bari, where we focus on nature-inspired approaches such as fuzzy logic, neural networks, and evolutionary algorithms. Bari is the second biggest in the south of Italy after Naples, that is much more famous. We are in the Apulia region. This one, that is the hill of the booth, as you can see from the figure. In the pictures, you can see our university, our computer science department, our laboratory, and our group. And this is me. Okay, let's start with the topic of this talk, bipolar disorder. The bipolar disorder is a chronic mental illness characterized with the changing alternate episodes that range from depression, mania, mixed state, and euthymia. Because of the recurrence of these phases, pharmacological and psychological approaches are important to prevent further episodes. However, the frequency of control visits is usually insufficient to provide early intervention at the start of the episodes. And therefore, in recent years, there is an increasing interest for real-time monitoring of bipolar disorder with the use of smartphones. Acoustic features about speech that are obtained from the interaction of the patient with ad hoc applications are regarded as promising markers in detecting the states of bipolar disorder patient. Acoustic data are daily collected and they very often change gradually or abruptly due to the mood, noise, and environmental conditions. So we need algorithms able to manage and predict these changes during the time. To this aim, string data classification algorithm will be used in this work. Although acoustic data collected from smartphones are relatively large, their psychiatric labeling is usually very limited. We are talking about just 1 week in 1 month, since only medical experts can verify the actual state of the patient. So semi-supervised approaches are needed to analyze this kind of data. Moreover, such multiple large data streams about acoustic features are collected under condition of uncertainty, such as phone calls are collected in a patient natural setting, or mental state of a patient is addressed during psychiatric interviews, etc. To cope with these uncertainties, the use of fuzzy clustering is explored. And finally, there is also a need for a human consistent analysis illustrating the structure of data and discovering patterns about the relations to the mental states, since the results need to be understood by physicians. And so visual analytics and linguistic summaries will be used for explainability purposes. In order to cope with the first 3 research goals, almost real-time analysis, lack of labels, and uncertainty, we have proposed the use of the dynamic incremental semi-supervised fuzzy means algorithm. It is a classification method for stream data based on semi-supervised fuzzy clustering algorithm, and it incrementally learns the model since it is applied to non-overlapping chunks of data to enable continuous update of clusters. The incremental nature of the algorithm allows the processing of the current chunk without keeping the old data. Indeed, information coming from previously seen data is injected in the new model by transferring to the next chunk the cluster prototypes derived on the current chunk. Moreover, splitting and mapping mechanisms are used to dynamically adapt the number of clusters and clusters in data. We will see that this algorithm is able to cope with the non-stationary nature of the speech data, and the learned clusters are updated to reflect changes in the observed data stream. Just a brief sketch to understand how the algorithm works. Data are divided in the subsequent chunks containing labeled and unlabeled data. As you can see, data in each chunk could have labels such as the a priori known classes red, green, and blue. But there could also be unlabeled data, the white dots, and moreover, data distribution could change during the time, as in the example where the second chunk, more data belongs to the green class, and in the third chunk, a new class appears, the blue one. So let's focus on a single step. At each time, the dynamic incremental semi-supervised algorithm is applied to the data in a chunk, and it returns fuzzy clusters, that is, a membership matrix where each sample is assigned to each cluster with a certain degree, and label prototypes that summarize data belong to the cluster. Clusters results are then used for classification. Indeed, the label of the closest prototype is assigned to each sample. When a new chunk arrives, the process is repeated, started from the prototypes of the previous chunk. In this way, the information about the old data are injected in the new chunks. The old model could be no more suitable to describe the new data. So a splitting mechanism based on the reconstruction error and the conditionally fuzzy clustering is used to create two new prototypes. You can see them here. and assign them to the most similar data. In this way, the model dynamically adapts its structure to the incoming data. Again, a new prototype for a new cluster is created to represent data belonging to the blue class. And a new prototype, we can see here a new prototype. So again, the model is adapted to the structure of the new data. Let's see how the algorithm performs with the bipolar data very briefly. In a very recent work, we have compared our dynamic algorithm with the WISC-Net, a distributed ensemble algorithm for semi-supervised stream data classification on benchmark data sets and on data belonging to one patient affected by bipolar disorder. This algorithm was the state of the art in this domain. In this work, we used the frequential train test evaluation and we simulated unlabeling by considering 4 labeling percentages, 100%, 75%, 50, and 25. And here the results for the bipolar disorder data. We observed that our algorithm obtained better results for all the labeling percentages and very low testing times, because we just need to compare data with the closest prototypes. On the contrary, our algorithm takes longer time to train the model, but the comparison is not very fair since the algorithm, the other algorithm is distributed. On the contrary, our algorithm run on our laptop. So in future work, we will handle this problem. But now let's focus on the explainability. When predicting the disease of the state of a patient, the interpretability of the predictive model is of fundamental importance to understand the decision of the model. While the priority remains on giving an accurate prediction, medical experts need to be provided with an explanation of the reason why a given call is associated for a specific state of the disease. As a first step in this direction, we applied visualization techniques to display the outcome of the semi-supervised clustering, to highlight patterns in data to be used to interpret the disease state of a patient. Then we have introduced the linguistic summaries with fuzzy clustering to explain acoustic data in bipolar disorder episodes. So, the primary purpose of visualization was to illustrate the characteristic of dynamically created clusters that reflect the structure of data in each chunk. For visualization purpose, we applied the PCA in order to reduce the data dimension from 10 to just 2 dimensions. These figures illustrate the relations between the original psychiatric labeling made by the medical expert in the first column and the cluster-based classification provided by the algorithm on the training and the test sets in the second and third column. This is the case for 25 labeling. In the first columns, for each chunk, the distribution of training data and their labels, we can see red dots for class 0 that refers to calls belonging to healthy subject, the green dots belonging to patients affected by disease, and the gray dots to unlabeled samples. The second and third columns show the cluster labels in blue and orange assigned for the same chunk to the training and test set. In order to exploit the files information coming from the cluster results, increasing dimensions are used to show the similarity between each dot and the cluster center to which it has been assigned. Abrupt changes can be observed from one chunk to another. Indeed, for example, in the first chunk, healthy patients, the red dots, are on the left part of the graph, and patients in the disease state are on the right one. This is completely inverted here in the second chunk, and then again, a similar distribution as in the first chunk appears in the chunk 3, even if the classes are slightly rotated and shape is changed. Nevertheless, the cluster-based model that we have here in the second and third columns is able to capture the original classes quite well. Indeed, the orange and blue dots will reflect the green and red points distribution that we have on the left. Thanks to this visualization, we are able to observe how data changes during the time and how the algorithm is able to adapt the structure of the model to these changes. Prototypes of a specific run are visualized as colored heat maps to immediately highlight patterns in the results. Since prototypes are representative of data in each cluster and they are mapped with the original classes, in this case, healthy and disease, these representations are useful to analyze the average values of the features that we can see on the rows in each cluster that we can see in the columns that have led to the resulting groups. Figure shows visualization of 4 prototypes created from chunk 3 in this case with 100% labeling, and prototypes 0 and 2 are mapped with the healthy classes and prototypes 1 and 3 with the disease class. It could be observed, for example, that phone calls in cluster 0 that refer to healthy patients have high values for the feature F, M, etc. For the phone calls in this chunk that refer to patients in disease episodes. Of course, in this graph, I have represented the 4 prototypes obtained from one chunk, but we have similar representation for all the chunks, so we can observe how data change from one chunk to another by observing the prototype's composition. And we could observe, for example, that for some features are more important in defining data belonging to one chunk than another, and so on. This analysis can help physicians in their data understanding, and particularly it could help in detecting patterns useful to recognize the onset of a different state. Finally, in order to further analyze data in each cluster, we use swarm plots to represent data distribution of each feature for a given chunk and a given cluster. This illustration is complementary to the previous one. For example, it shows that values of the second features have high variance and some outliers, differently from the other features that appears to have less outliers. Moreover, it is clear from the plot that data belonging to the first cluster have positive values only for the first 2 features, and both positive and negative value for the remaining features. These results are intended to show how the algorithm can be used for an intelligent data analysis in the context on monitoring status of bipolar disorder and facilitate discovery of further patterns in data, for example, by the medical expert. Linguistic summaries describe with natural language the general facts about the evolution of numerical data sets and are adapted for this study as human consistent features about acoustic data streams. To take into account the uncertainty of acoustic features, we propose the use of fuzzy sets to describe acoustic features and derive acoustic linguistic summaries. So linguistic summarization with fuzzy clustering, this is what we proposed. is implemented in the 3 steps: falsification of acoustic features using clustering prototypes learned by the semi-supervised algorithm that I've explained before, that we have granulation of acoustic features, and then we have derivation of linguistic summaries. So prototypes resulting from the dynamic algorithm are used to construct the membership function of the fuzzy sets, the linguistic terms describing the acoustic features, this one. In the feature, linguistic variables and their fuzzy sets are shown, and for each acoustic feature, type 1 fuzzy set represented by trapezoidal and triangular membership are constructed to reflect the linguistic terms. To calculate the parameters of membership function of the 3 linguistic sets, low, medium, and high, quartiles have been used. So once acoustic features are represented by fuzzy sets, we granulate them into high-level concepts representing attributes of a call. For each call, 4 high-level attributes have been derived, and they were manually selected by based on the analysis or the related work and the support of clinicians. So we can, these are the 4 different groups that we have derived: loudness, that granulates loudness related features such as level of loudness and logarithm of signal energy, for example. The reason is that patients in affective state are expected to speak louder compared to euthymia. This is what we are going to verify with our linguistic summaries. Pitch, that granulate pitch-related features, and patients in affective states are expected to speak with a higher or lower tone of voice compared to euthymia, so in the healthy state. The spectrum, that granulates spectral-related features, because patients in the affective state are expected to have lower dynamics of changes in the speech signal spectrum. And finally, quality of voice, that granulates quality of voice related features, because patients with depressive symptoms are expected to speak less clearly, less fluently, more monotonously, and the intensity of voice fluctuation more, and they have more asthenic voice. On the contrary, patients with maniac symptoms speak less clearly, more fluently, chant less, and the intensity of the voice fluctuates less. These high-level attributes are derived by applying a T-norm operator to fuzzy set, describing each feature on each group. So, starting from attributes and their description through fuzzy terms, we specify the underlying structure of linguistic summaries, also called fuzzy quantified sentences, using a protoform. The linguistic summary is based on the extended protoforms enabled to capture relation within and between groups of parameters. For example, in the state of mania, most of calls have low loudness and low tone compared to the state of the euthymia, that is the healthy state. Quantifiers, most, minority, about half, were defined as fuzzy numbers. Next, we linguistically summarize the results to see whether there are differences between data identified as healthy and the considered disease states. In this case, they were mania and hypomania. Figure gathers in the upper rows relative summaries in mania and hypomania based on short protoform for which the degree of truth was equals to 1, and linguistic summaries based on the extended protoform in mania and hypomania. Then we have analyzed the relative extended linguistic summaries to understand the further relation between high-level parameters. We can further learn that, for example, most calls with high loudness in hypomania have high spectrum compared to the state of the euthymia. This information is complementary to the linguistic summaries based on the short protoform. Indeed, the extended protoforms enable retrieval of less frequent patterns. It is also observed that most calls with a low pitch in hypomania have a low spectrum compared to the state of euthymia. And interestingly, most of the summaries for the maniac state are consistent with the hypomaniac state, but there are some exceptions. For example, it is observed that most calls with high loudness in mania have low spectrum compared to the state of euthymia. This summary, although relatively simple, they are very intuitive for medical experts and easy to compare to the state of the art in this field. The experimental results indicate that summaries derived by the proposed summarization approach provided the clinician with very clear and usable information about the patient's affective state. Since certain speech properties seem to change with the phase change, the psychiatrist could be informed that, for example, the patient is no longer in the healthy state. This can make it very easy for mental health professionals to identify an episode, especially one that occurred some time ago between visits. One of the main limitations of the proposed approach is the need for prior knowledge about the acoustic parameters to group them adequately. This is a challenging task also due to the fact that acoustic data coming from sensors are subject to various transformations. So interdisciplinary work is needed to transform them into human-centered characteristics to be used by clinicians in their practice. So this is what we have done until now, and I want to conclude my talk with our future directions. We are working on implementing multi-label classification starting from weak labeling. Indeed, the patient status can be described with the substates, and at each time T, he can belong to different substates. We want to improve the explainability, and to this aim, different techniques will be studied. We are actually working with the neural network right now. And finally, we have shown results obtained from a single patient. And this is correct from one hand because there is a high variability in patients' behavior. So single models are needed for each patient. But from the other hand, we want to assess the effectiveness of our method on different patients. So all the patients available will be compared, will be analyzed. If you are interested in this work, you can refer to mainly to this work, but particularly to the previous one, the first and the second one. So again, thank you to MIT University for having invited me. And if you are interested in my research, you can contact me through my email, or here you can follow the link to my homepage where you can find all the information about my research, and we can stay in touch. So thank you again very much.
Thank you, ma'am. Just give me 1 minute. Yes, Devika.
Yes.
Thank you, ma'am. Thank you for the enlightening words, ma'am. It was a great privilege and honor to had hear your insights about the explainable stream of data analysis and the depth of the case study to the bipolar disorder disease. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge and expanding their growth in the fields of data analysis. I believe your words have set new levels and expectations for the studenthood that they aspire and intend to. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with all the valuable knowledge. We're highly grateful to have you with us here, ma'am. Thank you so very much.
Thank you, ma'am.
So much, ma'am. Thank you very much.
Thank you very much.
Talk.
Thank you. Thank you.
Ma'am, you are
Good afternoon to all the dignitaries, professors, and participants present today. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Conference 2022, the 12th International Conference on Cloud Computing and Data Science and Engineering. Today, I am excited to take the opportunity to invite our honorable speaker, Professor Dr. Neelam Duhan. Dr. Neelam is working as an associate professor in the Department of Computer Engineering at J.C. Bose University of Science and Technology, BIMC of Faridabad. She is currently holding the additional responsibilities of Director, University Computer Center and Digital Affairs, Nodal Officer, Academics in PEQIP 3rd, and Nodal Officer, National Test Center at University Lake. In her academic credentials, she has an experience of 18 years and has successfully guided 45 MTech dissertations and 5 PhD with 100+ research publications in reputed journals and conferences. Her research interests include data mining, machine learning, computer vision, and image processing. She has recently been awarded by prestigious AICTE Best Teacher Award by Honorable Education Minister of India for her contribution in technical education. She is also the recipient of Governor Chancellor Gold Medal by Honorable Governor of Haryana for her teaching excellence. She has been presented the Influential Woman Award in 2021 by Local for Vocal, Delhi NCR. Besides these, she has got recognitions from District Administrations Faridabad and Red Cross Society Haryana branch for her selfless services during COVID-19 pandemic. She has also been recognized 4 times by NPTEL for her contribution in promoting massive open online courses. She, with her team, has also successfully developed and deployed a digital learning management system during these COVID times to continue teaching learning process, and also developed a COVID help desk on behalf of her university to serve the humanity. She is working efficiently in the direction of digital learning and in making the society more digitally empowered. Ma'am, we invite you on the platform to share a few words with us. To you, ma'am.
We welcome you, ma'am.
Yeah, thank you so much. Am I audible properly?
Yeah, you are audible.
Yes, ma'am.
Yeah. Namaskar and a very good afternoon to everyone present here. First of all, I would like to congratulate the organizing team of Conference 2022, 12th International Conference on Cloud Computing, Data Science and Engineering. And I congratulate to you for organizing this conference on such a relevant theme and on such an international platform. Today, my topic would be the bio-inspired computational intelligence. So, bio-inspired computing is the field of study which seeks to solve computer science problems using models of biology. It relates to connectionism, social behavior, and emergence. Within the computer science, bio-inspired computing relates to artificial intelligence and machine learning. And this computing is a major subset of natural computation. Bio-inspired computing can be distinguished from traditional artificial intelligence by its approach to computer learning. And this computing uses an evolutionary approach, while traditional artificial intelligence uses a creationist approach. So bio-inspired computing begins with a set of simple rules and the simple organisms which adhere to those rules. Over the time, these organisms evolve within the simple constraints, and this method could be considered bottom-up and decentralized. And in the next few minutes, I'll be going to discuss the different types of bio-inspired computational intelligence and its applications in the different areas. First of all, let me share my screen. Hope my screen is visible.
Yes, ma'am, it is visible.
Yeah, what contents I'll be delivering? So I'll be delivering the basic talk on the natural computing and what are the various bio-inspired models that we can research, that we can use in the research of today. And I'll be sharing the details and some of the research applications of the bio-inspired computing. As we see, what do you mean by the natural computing? Natural computing, what it means? Now, it means that we have to investigate models and the computational techniques which are inspired by nature. Now, natural computing, what it does, it attempts to understand the world around us in terms of the information processing. It is basically a field that basically connects the computer science with the natural science. Now, in this area, we have the three kind of computing. We have the nature as inspiration, in which we have the genetic algorithms. We have, you can say, we have the neural networks. We have the ant colony optimization, particle swarm optimization. Second area is we have the nature as implementation substrate, in which we have the, you can say, quantum computing, and we have the molecular computing. And the third field is the nature as computation. Now, in this case, we basically talk about our system biology, synthetic biology, and the cellular computing. So my main talk of today would be focused on nature as inspiration. Now, when we talk about the nature as inspiration, we are talking about the cellular automata, neural computations, which basically inspired by the working of the brain. And we talk about the evolutionary computation, which is basically inspired by the behavior of our genes. Now, we talk about the swarm intelligence, which is basically inspired by the, you can say, the group behavior of the swarms, like fishes or the birds or the ants. Okay, so we also talk about the immunocomputing, which is inspired by our immune system. We also talk about the artificial life, membrane computing, and the amorphous computing. So what the bio-inspired, or you can say the nature-inspired computing is. Now, in the last 3 decades, various researchers have developed the various machine learning tools, which have been inspired by the biology and the nature, in which most of us, we have studied about the artificial neural networks and genetic algorithm, artificial ant colonies, particle swarm intelligence. And besides this, many other kind of algorithms are there, like the cuckoo search, bat algorithm, etc., which have also been developed by the researchers to find the solutions of the complex problems. Now, what bio-inspired models basically share some common properties. Now, the very first thing is they are inspired in nature, or they're inspired by the nature. They are automatic. It means no human intervention is there, and they're the non-linear kind of algorithms. And how they work to provide the efficient solutions to some NP hard problems. Like we talk about the traveling salesperson problem, scheduling problem, profit maximization, and we talk about the pattern recognition systems. So we can find out all the solutions to these kind of problems by the way of the bio-inspired models. Now, what the need of bio-inspired optimization algorithms is? Now, what the need is, as they provide the highly efficient solutions to multidimensional and the multimodal problems. Now, by using these kind of algorithms, a problem can be solved by the less computational effort and the less time complexity. It means, suppose we are talking about the minimization or the maximization problems, which is having the 5 or the 10 or the 20 variables. So simply we can't solve it by the way of the, you can say, the classical solutions. So we have to go for some kind of the, you can say, rigid solutions for this, and the bio-inspired computing can go for this. And all these kind of algorithms, they're using the stochastic approach to find the best solution in the large search space. It means we are using the hit and trial kind of approach. And these kind of algorithms have various, you can say, applications like the digital filter designing. If we're talking about the pattern recognition systems, image processing system, we're talking about the various machine learning systems transport and the vehicle routing systems, digital integrators and the differentiators designing, and the face recognitions or the computational intelligence that we are talking about. So many applications of these models we can see in today's world. So this bio-inspired computation, how it is different from the classical computation. Classical computation is basically good at the number crunching, okay? And we basically, the problems which we can basically solve by the pen and the paper kind of, you can say, support, and these can be solved by the classical computing. And here we are using the rule-based reasoning. And we are basically, what we are doing the repetition of the well-defined actions in the classical computing. But classical computing is also bad at the pattern recognition, okay, robustness to damage, and dealing with the vague and the incomplete and the noisy information, okay. And when we are talking about the intelligence, it means learning. It means the classical computing is bad at that kind of thing. Now, in these kind of scenarios, when we are talking about the computational intelligence, it means we want our machines to acquire the intelligence. Then what comes? That comes are bio-inspired models for the bio-inspired computation. Suppose now we have to design a robot that can make a cup of tea for me. Okay, so I have to design a software. That software can basically form the railway timetables in a robust way. Okay, suppose we have given the pictures of the leaves, different leaves, and we have to detect what kind of disease that can have. So how we can design such kind of softwares? It means we want to design some softwares which can intelligently work. It means a robot which can intelligently work to make a cup of tea for me. So it means I have to think in a way like my human brains work, human brains think. So it means we have to design some models which are basically, they are more working like the human brains or the human genes. Okay, so I have discussed a lot of problems. So in such kind of problems, like we are talking about the pattern recognition, or we are talking about the general computation techniques. So in these such kind of behaviors, we are talking about the bio-inspired models. So next, I'll be talking about some of the bio-inspired models and a very short way how these kind of networks or how these kind of models are working. So the very first one, the bio-inspired or the nature-inspired model, artificial neural networks, genetic algorithms, and colony optimization, particle swarm optimization, and many more algorithms are there. So as I talked, in the last 3 decades, the research is going on in these kind of areas. So there is always a way of optimizing these kind of algorithms. So first of all, if I talk about the artificial neural networks, so it means basically what it does, artificial neural networks basically simulate the behavior of a human brain. Like if I ask a question from all of you that which one is better, human brain or the computer, then you will say, yeah, my human brain is better because I have a way of thinking. But someone will say that computers are better because they can do the faster computations. It means in some way the computer brain is better, in some way the human brain is better, in the other way computers are better. It means if we can combine the behavior of all these two, it means human brain and the computer, it means we'll be having an optimized solution for the problem. It means if I can do the computation at a faster rate, but with the human brain, so that will be the best solution for any problem. So what the idea behind the neural network is that we have to simulate the behavior of loads of densely connected brain cells of the human inside a computer, so that we can have the capability to learn, think, to acquire knowledge, and to make decisions. It means suppose my brain is looking at a pattern, and by looking at the pattern in a repeated way, so I'm going to learn that pattern. So in the same way, computer systems are working. So we're going to learn them to recognize patterns and to make decisions in a human-like way. Okay. So how it works, how we have to simulate the behavior of the human brain with a computer system. So what basic idea is that we have to build a neural network, which is basically the set of the interconnected input output units like this way. So we have the input layer, we have the output layer. It means in those layers we have to connect the nodes, the artificial nodes. Okay, and some kind of hidden layers we have to build up. In the hidden layers, again, we have to connect some random number of nodes. So the input layer and the output layer, that is well defined in nature, but the number of the hidden layers or the nodes in the hidden layer, that can vary. Okay, so artificial neural networks, it means that encompasses only the two components, the main components. The one is the neurons, which are the artificial nodes in my neural networks. And the second thing is that for each and every node, connection of the node, I have to assign some kind of weights. Okay, so this kind of structure, this kind of topology we have to build in the computer systems. And now this topology, how it will work? It works on the concept of the back propagation. What the back propagation is, that is the neural network learning algorithm. Now it means we have to define the input layer, output layer, and the hidden layers, and we'll pass some inputs in the way of the zeros and ones to the input, and that will pass through the hidden layers. Okay, so my input will be propagated forward, feed forward through the hidden layers to the output. And then what we'll do now, we'll find the error in the output. It means what output I expected and what output I am gaining. So I have to find the error. If the error is acceptable, it means my network is learned. Otherwise, what we have to do, we have to basically back propagate the errors so that my network learns at a very less error rate. Okay, so neural network, now a lot of applications are there for the neural networks. So it can work as a classifier. Suppose we have to classify, it means what persons will buy the computer and what persons will not buy computer, and who are the insured persons. It means who will get the insurance from the insurance company, and who are the persons who will not get the insurance from the insurance company. So for both the continuous model as well as the non-continuous, it means the discrete models, we can use the neural networks. So it has many weaknesses. It means the long training time. It means we have to learn the network. Poor interpretability is there, but it has a lot of strengths like high tolerance to the noisy data. And this is able to classify the untrained patterns, continuous inputs and outputs, as well as the discrete input output. It is basically suitable for. Okay, so this is the analogy what we are using in the neuron. It means we have some kind of input vector, we have the weight vector, and we have to calculate the weighted sum for the input and the weight vector. And we have to use a bias. Bias is basically what it does. It basically simulates the behavior, accumulates the behavior of the human brain. Or we have to use an activation function to basically find out the output of the neural network. So some kind of the sigmoid function or the activation function we have to use in the neural networks. So it is more like the human brains. You can see it means the input vector is there. They basically analog with the dendrite of our human cells. So what kind of activation function I'm using, that is basically inside our human brains. Okay, so our nucleus does all these kind of things. So the output basically branches or the output nodes, basically they analog with the axon terminus of our brain. So it means the whole computer brain we have simulated its behavior in our computer systems. So that is the neural networks. Okay, so this working I've shown. So what we have to do, simply we have to initialize the weight, we have to propagate the input forward, and we have to calculate, we have to calculate the difference between my output and the target output. Then we have to calculate the error. If the error is acceptable, it's okay, then terminate. Otherwise, what you have to do, you have to back propagate the error, and we have to update all the weights and bias according to those errors, and we have to terminate. It means when the error is acceptable, then we have to terminate. Okay, so I will not go into the details, but these kind of functions, you can see these kind of functions we are using while learning the neural networks. Okay, so what the efficiency of the neural network is, basically that is O big O, the size of the database and the input vector. So you can see the complexity is very, very high, but you can see the performance is very, very good. The second kind of bio-inspired models, that are genetic algorithms. It means what basically in these algorithms, what basically we are doing. So we are simulating the behavior of our genes. So it is basically based on the Charles Darwin theory of survival of the fittest. It means only those persons or those species are going to survive. They are the fittest in nature. Okay, so we are basically simulating the behavior of our chromosomes in the genetic algorithm. So we are giving some kind of coding schemes to the various chromosomes. So chromosome is a combination of the 0 and 1. So 0 and 1 represent here the genes, and what we have to do, we have to collect the population in this, like the population of chromosome we have to get. In the same way, we have the population of the different kinds of rules or different kinds of the applications what you're talking about. We have to get the you can say we have to get the collection of those chromosomes in our computer systems, and we have to simulate the behavior. So what it is, it is based on the genetic behavior of the chromosomes in the population. So what the population is, that is a collection of chromosomes. And what we have to do here, we have to basically define a fitness function for the population. It means how we can find out how fit my population is. It means my population is fit. It means the best solution is there. Okay, so every time I have to calculate the fitness of my population. So randomly I'll be updating my population. Now, if it reaches a fitness function which is acceptable, then I'll stop. So what we have to do here, so every time we have to cross over and mutate our chromosomes to generate a new population. Okay, and in the new population, again the fitness function is find out. Okay, and that has been compared, that has to be compared with the previous population. It means hit and trial kind of method is there. When the fitness is best, then we have to stop. So this way it is working. So we have to initialize the population. We have to find the fitness of the population. Now, if it meets the threshold, it means we have the best fitness value. It means we have to stop. Otherwise, what we have to do, we have to select the best parents from this population. It means having two parents having the best fitness value from this population, and we have to cross over and mutate them, and then we have to find the new population. Again, the fitness is generated, again threshold is compared. Like this we have to do. Okay, so it is more selective breeding than you can say the natural kind of evolution. So these kind of crossover functions, we can have 1-point crossover, 2-point crossover, uniform crossover. It means we have to basically what we have to do, we have to swap the part of one chromosome with the other chromosome. That is basically the crossover. And what the mutation is, we have to randomly flip the bits of one chromosome. So that is called the mutation. Okay, so these genetic algorithms, they can be best suited for the classification processes. It means when we have to find out the classification rules, then we can use our genetic algorithm. For example, we have a rule like if A1 is there and not A2, then we have the class C2. It means it can be represented by, this can be, A1 can be represented by 1, not A2 can be represented by 0. Suppose C1 class is 1 and the C2 class is 0, then it is 1, 0, 0. So what we have to do to solve these kind of problems, we have to generate a random set of rules in the way of the zeros and ones. Okay, we have to find the fitness of all the rules. Okay, and we have to generate the offspring. So you can say you have to generate the children by the way of the crossover and the mutation purpose process. And again, the new population is generated. Again, find out the you can say again find out the fitness of all the rules. It means how many rules are basically fitting on my testing data, so that we have to find out. So this way, it means hit and trial method, we have to find out the best set of rules. So it means again genetic algorithms are very slow, but they are easily parallelizable. So last I'll talk about the swarm optimization models. So what the swarm optimization models are? So what we can say that swarm intelligence is the collective behavior of decentralized and the self-organized systems. It means when I'm talking about the, you can say I'm talking about a group of fishes, a group of birds, okay, a set of ants I am talking about. It means the behavior of those nature inspired basically species we are taking into the consideration, and we are simulating their behavior in the computer systems. So these are swarm optimization models. Like you can say some kind of the cooperation between all the birds and all the ants is there. It means suppose we have two, you can say two fishermen, like the orange one and the green one. If they communicate with each other, so they can easily find out the source. It means they can easily find out the fish, or that too at the you can say global maxima. Global maxima they can find out, not the local maxima or the minima they can find out. So it means if they cooperate with each other while finding the depth of the, you can say, pond to find the fishes. So if they cooperate, they can find the global optima very well. Okay. So these kind of, it means cooperation behavior between the ants or the birds that can be simulated in the computers. So two kind of main algorithms are there. The one is the ant colony optimization. The second one is the particle swarm optimization. So what ants basically does, all of us know the behavior of ants. What they does, ants are basically very great at finding the closest source of food. It means when some sugar is there, they will easily find out the sugar in your kitchen. So what they do, they use pheromones. They release the, you can say they release the liquid that is called the pheromone to communicate information. If some ant is going, that releases the pheromone, the next ant comes and that basically realizes the pheromone level, and that goes beyond that particular ant. Okay, so it means they follow each other to find the best source of food. Okay, so ant colony optimization works on this principle, and they can find the discrete solutions to the problem. And how the particle swarm optimization works, that is basically based on the behavior of our birds. How birds are, it means how birds are doing. Birds basically use two things. The one is the velocity and other is the directions. They are very excellent in finding the multiple sources of food simultaneously. Okay, so they are best at finding the continuous solutions. So particle swarm optimization, that was in 1995. So how it works, simply I'll show you the diagram. See, these are the various, you can say, the birds which are moving around, and this brown one, that is the source of food. So see how they are working. They have some velocity and the direction. Arrow shows the direction. So see how it works like this. They are easily finding out the global optima. It means they're easily finding out the solution to the problem. And how ant colony optimization works, as I told you, that is the behavior of the ants. Okay, so how they're working, see how they're working. Suppose this is the nest where from ants are going, and this is the food source. So some kind of obstacle can be there in between. So how the ants are going, you will see the behavior soon, that how they are working. So they will revolve around the obstacle, and soon they will settle down and they will follow the same path because of the density of the pheromone level, and they will easily find out the food source from their nest. Okay, so actual scenario is that ants are almost blind, but they are using the synergic communication via the pheromone trails. It means they are following each other to find out the shortest routes pass from their colony or from their nest to the feeding source. So ACO and the particle swarm optimization, they can be best suited for the traveling salesman problem and finding the route optimization problems, and the pattern recognition systems. Our neural network is best. So different kinds of things are there. So what the conclusion is, so bio-inspired models are the meta-heuristic approaches for solving the very hard combinatorial optimization problems. Like we're talking about the NP hard problems, they can be solved by the bio-inspired models. And they are basically going to be the new revolution in the computer science. And the research is going on in these areas very frequently. And lots of optimization problems, like I talked about, the industry and the engineering problems that I talked about, they can be applied on those problems, and they can be used to find the best solutions to that problems. So thank you so much, everyone.
Hello, ma'am. How are you? Thank you so much for accepting the invite.
Yeah, thank you so much, Madhulika. I'm fine.
Sunil, sir. Sunil, sir.
So, thank you for your enlightening words, ma'am. It was a pleasure to listen to you give insights about bio-inspired computational intelligence. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth in the field of bio-inspired computing. I believe your words have set new level of expectation that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to have you with us. Thank you very much, ma'am.
Yeah, thank you so much, sir. And thank you so much to you also for giving me this opportunity to be here to deliver my talk and to interact with you all. And thank you so much, everyone.
Thank you. Now let me introduce the Dr. Muhammad Helmi Bahav. Good afternoon, sir, and good afternoon to all. Good afternoon to all the dignitaries, professors, and participants present today. Again, on behalf of Amity University, Uttar Pradesh, the Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Conference 2022. Today, I'm excited to take the opportunity to invite our honorable speaker, Professor Dr. Muhammad Bahav. Sir is currently working as a professor and former head of Intelligent System Lab at the Department of Computer Engineering, Faculty of Electrical and Electronics Engineering, University Tun Hussein on Malaysia. He has completed several research grants, won several medals in research and innovation, awarded several publication and teaching awards. He has authored and co-authored 2 books in database and web application, published several local and international book chapters, as well as published more than 100 technical papers in conferences and peer-reviewed journals. His research interests are in data mining, artificial intelligence, computer vision, wireless computing, and web-based applications. He is currently a senior member of IEEE, IEEE Computer Society, IAENG, and IACSIT. Sir, we invite you on the platform to share a few words with us. To you, sir.
All right. Thank you very much, Dr. Sunil. And thank you for the organizer for inviting me to give a little bit sharing on the work, what we have done in our lab. All right, so we already listened the interesting lectures on computational intelligence by Dr. Nilam, which is very inspiring. And then let me change the topic. Now we are talking about this smart application, okay, to support the elderly and disabled people. So this is basically the real work that we have done at our lab, at our universities. And the application is ongoing, and some of the application is already finished, and we are in the process of the pilot testing and before we apply for the commercialization. So the talk today is about this development of the tools, okay, that can help support the elderly and disabled people. All right. So this is a little bit about me. So I have been introduced by the chairman for the session, and I'm currently a senior lecturer and a visiting research fellow that working in the Center of Excellence of Advanced Computing, University of Malaysia, Perlis. And I also the IEEE senior member. Then I'm serving for the executive committee for IEEE Systems, Man and Cybernetics Society Malaysia chapter. So this is in line with the tools, with the application, with the research that I'm involving now. All right. So this is a little bit about my university. So as we all know, that my university is located at the southern part of Malaysia. Okay, it's about 1.5 hours from Singapore Airport, and it's about 3 hours from the Kuala Lumpur International Airport. Okay, so this is the technical university. We have 4 technical university in Malaysia. One of us at the southern part is the University Solution on Malaysia, and we have the other 3, okay, University of Malaysia Pahang, University of Malaysia Perlis, and University Technical Malacca. So all these kind of 4 technical university, we are working on this industrial engagement and provide the community-based application to help this community surrounding the Malaysia. All right, so this is our new building of libraries and then the chancellery. Okay, so this is a little bit info about my university, and then it was established as early in 1993. Okay, it's still it's a quite new university, and it's one of the public university in Malaysia. It is under the government of Malaysia, and it is located in the it's a quite a rural area in the Batu Pahat, Johor, Malaysia. All right. Okay, so this is a little bit about the Advanced Telecommunication Research Center when I'm serving as the Principal Research Fellow. So I'm working in under this center, working on the IoT application. All right, and currently we have 43 PhD and master students under this center, and we have about 951,000 total grant so far. Okay, so the main core things of the talk is about the one of the application that falls under one of the category in the IR 4.0 components. As we all know, the Industrial Revolution 4.0 has inline 11 components, and one of its component is the Internet of Things. Okay, so that Internet of Things has taken place nowadays, okay, in developing the smart application in so many sectors, okay, ranging from agriculture, medical, health, transportation, manufacturing, and so forth. All right, so instead of the IoT, we have another 10 components in IR 4.0 can be included together. All right, so the talk today will focus on the development of application that related to the Internet of Things. Okay, so this one is a little bit about the history of IR, Industrial Revolution. Okay, as we already know, we are in the era of the IR 4.0 as the early 21st century. Okay, now in this century, we call it the AI revolution. So most of the AI application has been included. Okay, from ranging from embedded, from the interface, from the engine, from the whole overall system. All right, so that the first IR 4.0 starting from the 18th century industrial revolution. Okay, at that moment we only have the steam-based machine. There is no electricity yet at that time. And we move to the 19th to 20th century industrial revolution. We have some kind of electrical energy-based mass production, which is the first electric conveyor system has been introduced at this time. And then during the late 20th century industrial revolution, we have the computer-based and internet-based knowledge in order for most of these systems are computerized. And then we move to the now the era of the IR 4.0, and then the era of AI, data-driven solution, which is also we know as the closing the gap between the real world and the cyber world. We call it the cyber physical system. All right. Okay, so when we talk about the technology for disabled people, okay, so technology can help in reducing many barriers that people with disabilities face. And this kind of technology is also known as assistive technologies. So many types of disabilities, including physical disabilities, hearing impaired disabilities, and visually impaired disabilities. Okay, as we all know, AT has been utilized in assisting them. However, developing an AT is expensive, making their selling price high. Okay, as we all know, the environment in Malaysia nowadays, we are trying to make the disabled people compliance. Okay, so we provide all these disabled people parking, disabled people toilet, disabled people facilities, route, okay, at the shop, at the shopping mall, and everything. We try to make the facilities for all disabled people to enjoy the normal life as the normal people. So that as the coming of the IR 4.0, so there is a lot of technology can be introduced to help them. Why this is important? Because we have so many form of assistive device, and we have a lot of the millions of seniors require some of the form assistive device. All right, and then 80% of those 65 are living with at least one chronic disease. For example, for the elderly people here, all right, so as we can see here, The elderly people in Malaysia, we declare about 60 years and 60 years old and above. However, the WHO define people with 65 years old. Okay, we consider is adult. And elderly is a chronological age at 65 years old and older. And population of Malaysian more than 60 years old in 1995 is 5.1%. Into year 2000, 6.0%. In 2009 is 7.31%, is about 2 million. And then we are projected percentage in 2020 is 9.8%. Now we are in the 2022, perhaps it's already 10 or 11%. Okay, based on the projection numbers we have. Okay, all right. So that what we can say about this problem, this scenario. Okay, we try to think at our area, our surroundings in the rural area. So we can see that most of the elderly people or disabled people at home. Okay, all right. They have some difficulties in managing basic electrical appliance, such as to switch on the lamp, switch on the fan, because normally the switch are placed at the height of the 150 centimeters, while the comfortable height for the wheelchair user up to 150 centimeters. So that moreover, there is a need to avoid electrical shock when users switch their wet hand. In addition, difficulties in moving the wheelchair in a home due to a lot of furnitures, all right, and locate the correct position to make them able to reach the switch. All right, so we can see that this kind of scenarios, okay, how to assist wheelchair people to switch on the electrical appliance alone. Okay, once they are stay at home, so it is very difficult for them to switch on because they need to place the position, okay, near the wall like that, okay, as illustrated in the picture, so that the switch is located at the top here, and one of the switch is at the bottom one. All right, so the wall switch might be too high. Okay, it is very difficult for them to switch on the light, switch on the fan. All right, and even though to plug in something, okay, at the top. All right, and then also the movement limitation because of the home is full of the furnitures, full of things, okay, so that it's very difficult for them to move, all right, and then change adjust the location. All right, so tackling this real problem, so this solution is proposed. All right, so we are proposing this first prototype is a Bluetooth-based home automation system for disabled people. That means we try to develop some kind of mobile apps that can control and act as a switch for them. Okay, so we install this kind of prototype, and using the mobile apps, the wheelchair people do not need to move to the switch. They just stay and then just switch on the mobile apps and then can control the electrical appliance online. All right, so this is we use these some kinds of the microcontroller. We use these some kinds of relay to develop these things. All right, so the objective of these tools is to design an Android-based application that capable to control the lamp and speed to fan at home via Bluetooth technology, develop a prototype to demonstrate capability of the application in controlling home electrical appliance remotely, and evaluate the application performance in terms of its accuracy and reliability. All right, so this is the system architecture, so that we have some kind of for the first prototype, we use sensors, we use fans, and we use lamp to prove that this concept can work. All right, and then we use this Arduino Uno controller as the prototype microcontroller, equipped with this Bluetooth module and relays, and we connect all these kind of devices into the mobile apps, so that the mobile apps can send the signal once there is connection established between the mobile apps and the main control unit. Okay, so this is the algorithm of the Arduino Uno controller that we use. Okay, we just put in the flow chart. However, the code is embedded in the microcontroller. We burn it out, and then we have some kinds of the GUI on Android. Okay, so we can first we need to establish the connection, Bluetooth device, okay, from the device and then the apps. And once the connection established and data sent and received, we display the temperature reading because we have the room temperature sensor to read the current temperature. All right, and then we can choose the button, okay, for fans, for example, for lamps. All right, and choose button for lamps, display fans and lamp status. Okay, so these are the information that we need to display and to provide in the apps. All right, so we can say that this is the circuit simulation of main control unit. Okay, and then this is the interface. All right, so we have some kind of the mobile apps application. Okay, so this is the front page. Okay, here at the top, here this one. Okay, here is the top, is the front page, okay, from the mobile, and this one is the controller. Okay, the controller interface. Okay, what we can say that once it is connected with this kind of devices, okay, it will show the connected here. So that is mean that this device is currently connected to this board. All right, and then it will show the current temperature of the room. Okay, to show that the current temperature, and we have the switch for fan and lamp. Okay, so one which we can push the low, medium, and size, so the fan speed also will reflect to this board. All right, and then we have this the lamp for the on and off. Okay, we can on and off the lamp. All right, so that we can have this kind of controller. All right, so however, this prototype can prove that the concept of this application can work properly. All right, however, there is some limitation. Okay, the interface is fixed to control only fan and lamp. All right, so that we need to do some modification on that things. All right, so we utilize this kind of Bluetooth. Okay, because of Bluetooth coverage is about the maximum is 25 meters. However, when we install inside the house, okay, so this is the design of the floor of the house. Okay, we can see when we put at the MCU unit here. Okay, so it still can be connected from the location A and location B. All right, so this is is about 20 meters. Okay, from the left to right. Okay, so what we can say from the result, so we tested that, okay, the application can be up into 15 meters. Okay, 15 meters because of the obstacle. Okay, as we all know, this most of these Bluetooth connection will be reduced when we have obstacle. Okay, so that we do some testing on the 5 meters, 10 meters, and up to 15 meters. Okay, up to the 15 meters, the success rate is about 66%. And for the 20 meters and 25 meters, it cannot be detected. So that what we can see from that, the location of the MCU play an important role for us to ensure that this kind of application can work together, right, from the left and right. So any place, if you put the mobile apps, we can connect to the MCU unit. So the MCU unit need to be placed at the center of the house, so that it can establish the connection from front and back. Okay. All right, and after that we try to commercialize it within this device into the companies, and we try to find the collaboration within the two companies in Kuala Lumpur. Okay, one of these we have the discussion in 2015 because their prototype is already in 2015. Okay, but now we have in this 2022. All right, so that the discussion established as early as 2015. We try to make this one as one of this application. However, the limitation, as I mentioned, the fix in the interface need to be adjusted. All right, due to some of these limitation. Okay, one of the issue raised by the industry that every home equipped with all the switch. Okay, so it is not practical for us to remove all this kind of switch just for this one mobile apps. So they come up with the ideas is to integrate with these mobile apps and the current switch. So we did some modification on the current switch at the home, okay, by adding the Bluetooth module inside and the switch here, and we changed a little bit about the interface of the mobile apps. So the mobile apps will follow based on the number of panels available here. Okay, if there are 2 panels here, there will be 2 panels here. Okay, so that this switch can work. Okay, can work is vice versa. Okay, if you switch on from here, you can off from here. If you switch off from here, you can switch on from here. So that the switch and the mobile switch and the physical switch can work independently. All right. So this kind of prototype also we try to exhibit at several innovation and exhibition to receive some comments from the audience. All right. So we sent to Pencipta, we sent to IDEA, and we sent to the IREA 2016, and we received some kind of recognition from there. All right. And then after that, we found that this kind of application also having a limitation. So that what about the other switch? Okay, so that we need to modify all the switch with the Bluetooth module is a costly. Okay, it's a cost. So that the company or the industry who taken this project has proposed in order to add up a new thing as a portable. Okay, so this is a picture of this second prototype. Okay, which is we just making modification of this wall switch, and then this is the application of these mobile apps, and this is the new application that we add up. We make it portable. Okay, we make it portable for the third improvement. Okay, based on the comments from the industry, so we try to make it portable so that this portable plug equipped with the Bluetooth module that can move to any power point. Okay, that can move to any power point. Okay, so from this, we make it more convenient, more friendly, and more easy to modify. So we don't need to modify at the wall. We just created the plug, and we can sell this plug to all the users. All right. So from this, we received the one of the special award from Taiwan. Okay, recognizing this plug. And then we received the gold medal and silver medal at Riau, Indonesia, and the Bangkok, Thailand. All right. So because they like this kind of the portable, easy to move plug in everywhere, so that it will ease these kind of people. So they don't need to buy 10 or 20 pieces. They just buy 1 or 2. They can move, okay, where they want to stay. If the wheelchair people want to stay at the living hall, okay, there might be some plug, a point to that plug in the living hall. Okay, they can bring into the room if they change to the room. Okay, so it can be easily to modify on these things. All right. Okay, so this is some of this exhibition that we made during the exhibition day. Okay, for the products. Okay, you can see all these. These are the prototype for the second, and this one is a prototype for the third prototype. Okay, and then this one is the latest version, since the coming of this, most of the house are equipped with the Wi-Fi. Okay, so that we need to change this plug that can support Wi-Fi as well. Okay, instead of Bluetooth. Okay, so we have the Bluetooth and we have the Wi-Fi technology. So this current prototype, okay, which is exhibited in 2020, okay, equipped with the Wi-Fi and equipped with this timing, okay, timer. All right, so we have the fourth improvement exhibit in the Bangkok exhibition, and we received some recognition from there. Okay, so this is about this, how we assist these kind of wheelchair people, whether elderly, whether disabled people, okay, to control some kinds of electrical appliance using the mobile apps application. Okay, and we have some of these written local magazine about these assistive technologies to support the disabled people. All right, so the article was written in Malay language, and we just published last 2020, okay, in the local magazine, the Science Technology local magazine. All right, so these are some of the other recent applications that we developed at our lab. However, this project is not led by me, but led by other researchers. Okay, these are some of these wristband, okay, wristband that can monitor these the elderly people and disabled people heartbeat rate and then body temperature. Okay, they just wear the bands, and the bands will be connected to the mobile apps through the IoT modules. Okay, and then we use the ThinkSpeak at this one, and then we develop using the MIT apps inventors. Okay, so when the elderly and these disabled people are wearing this kind of wristband, so we can easily monitor the heartbeat of the people. Okay, so that if there is something, the heartbeat suddenly increase or suddenly going down, so we can act fast, whether you can call the medical team or you can go to watch them. All right, so these are some of these simple application, okay, to assist the elderly and disabled people. All right, and this one also received international recognition from Japan. Okay, and then this one also another product that we developed by other researchers also is a wearable safety vest to monitor or track the autism patient. Okay, the autism people. Okay, which is very easy to locate them because we have some kind of the GPS location, because sometimes they are moving, okay, under control, so we can monitor from the mobile apps, okay, from this vest. Okay, so this one also we are under testing on this one, and we'll be testing with the real people later. Okay, maybe this year, this June, we try to bring this one and test to the autism center. Okay, this one also we receive several some kinds of recognition, okay, so that we can improve from time to time. Okay, however, this kind of vest still in this under testing, okay, because of this some kind of very sensitive equipment need to apply in the vest, so that we need to place somewhere and that is water resistant. Okay, the water cannot be entered. All right. And I think the final design, final application will be the MySign, okay, which is one kind of apps and mobile apps that can communicate with the mute people. Okay, it's a translator devices. Okay, normally we as a normal people, we having a problem to communicate with the normal people, the mute people, because they use the sign language. We as a normal people do not all of us having some kind of skill to communicate using the sign language. So that we design some smart gloves, okay, that wear by the mute people. So the mute people will move their fingers, talking using the sign language. So this smart glove will be connected via Bluetooth to the apps that we created, and then this movement will be translated. Okay, the flex sensor inside the gloves can be translated into some kind of words that trying to say by the mute people. So we as a normal people can understand, well, the mute people saying hello to us. Okay, and then this one of these currently we have a some kind of limitation, because we try to improve the movement of this glove, because every people having the same different threshold of movement. So we need to set some threshold to ensure that this kind of flex sensor having some kind of flexibility in order to detect certain words. All right. However, now we have improved the gloves, and we also improved the mobile app. So the mobile apps now can pronounce the words. Okay, instead of display, they can pronounce the words. All right. And the current progress of these devices. So we are trying to make these devices from these normal people try to talk with the mute people. Okay, using the sign language as well, so that we use the words, we just say the words to the mobile apps. So the mobile apps, we try to simulate the movement of fingers, and with the mute people we see at the apps and looking for the movement, they can understand what we are trying to say to them. Okay, so this one will improve. Okay, will improve the communication between we as a normal people talking to the mute people. All right, so that these applications are still ongoing because we are still considering a lot of dictionary words can be represented using the movement of the fingers, and then the dictionary inside the mobile apps, how many words they can translate. So at this point, we just focus on the what are the regularly we try what the normal question that we normally asking to the people. Okay, for example, hi, good morning, hello, okay, good evening, okay, how are you? Okay, the same question or the general question. All right. So this one also we have some achievement on this project. Okay, this one we received one grant from internal university, and one is a national grant from the Ministry of Education Malaysia. And this grant it should be ended in 2022, and we receive quite numbers of achievement and recognition from this Thailand as well, and we have also from the Indonesia. Okay, and then we try to make it in local language, in Malay language. All right, so now at this moment this application run under the English language. All right, so as a conclusion, okay, the application successfully developed and in the progress for pilot testing. Okay, however, the current prototypes still in final design issues, and we having also the problem to find to reach the low cost price with the great quality. Okay, because as I mentioned in the early presentation, most of the assistive technology is quite expensive. All right, so then we try to come out what are the lowest cost that we can provide to certain devices, and then it can be used by the normal people for the nation. And also applying the IoT concept inside this mobile application and in line with the IR 4.0 element, so that once it's in line with the IR 4.0 has been also in line with the government objective and government campaign, so that it will be easy to get some funding from them. So with that, I conclude my talk, and thank you very much.
Thank you, sir, for your enlightening words. It was a pleasure to listen to you give insights about a smart application to support elderly and disabled people. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth into smart applications. I believe your words have set new levels of expectation that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are.
Thank you very much for the Amity.
Yeah, knowing how busy you are, sir, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to you with us, and thank you very much, sir.
Thank you very much for the MIT for inviting me and giving the opportunity to give the talk here. Thank you very much.
Thank you, sir. For the next session, I'd like to invite our honorable speaker, Professor Dr. John Doming. Professor Dr. John is a professor of computer science at the Open University, director of the Knowledge Media Institute. He has published over 280 refereed articles in the area of semantics, the web, distributed ledgers, and e-learning. His current work focuses on how a combination of blockchain and linked data technologies can be used to process personal data in a decentralized, trusted manner, and how this can be applied to the educational domain. Professor Doming has given many talks on his work, including at the Royal Institutions in 2018 and TEDx. Sir, we invite you on the platform to share a few words with us. To you, sir.
Thank you. Thank you very much for inviting me. Speaking to you today from a very cold and grey England. So I wish I was there physically. So let me share my screen, share my PowerPoint. Hopefully you can see that now.
Yes, sir, it is visible.
If people do, Okay, that's good. So if people have a question of anything is not clear, then stop me. So this is I've only ever worked in one institution, the Open University, and I really love working there. It's a very special place in that students do not need any qualifications to start studying with us. That's the word open means. And we have a social mission, which I think overlaps with Amity, of really providing education for everyone. So we try to provide education for anyone who wants it. But of course, our standards are the highest in terms of the qualifications that we give out. So I'm going to talk today about a core part of my work. So as mentioned, as well as being a professor of computer science, I'm the director of the Knowledge Media Institute, which is the technology R&D center for the Open University. So we research and innovate on new technologies which can help the Open University to teach its many students. And today I'm talking about two: artificial intelligence and blockchains. The OU has just launched a new 5-year strategy just in the last weeks. And core in our strategy is the use of artificial intelligence for teaching. So a little bit about the Open University. We've taught 2.2 million students since we were set up just over 50 years ago. So people said when we were set up that this was crazy and there was no way it would succeed, the idea of teaching people at a distance. But of course, we proved them wrong. We currently have just over 200,000 students that are all studying at home. And you can see on this slide that 60% of our students are already working. So a lot of these are people, some of these are people who are upskilling. More that are people that never had the qualifications to start a degree. But through work, they realize that there's more to them and they want to change their lives and change their jobs. So we really, really do that. So you can see actually in the stats, it's 34%. 34% of our students did not have the qualifications to start a degree. 36,000 of our students have some sort of disability. There are 75 FTSE 100 companies that have sponsored their staff. And we also have open platforms. So OpenLearn has attracted nearly 100 million visitors to free learning resources since 2006. We also founded a MOOC company, these massive open online courses companies, and FutureLearn, which has 10 million students at any one time. And you can see that 26% of our undergrads live in the 25% most deprived areas in the United Kingdom. So we're really targeting students that need help and transforming their lives. And we really can do things at scale. So just one thing I would say about the things we do at scale is, I don't know if you're familiar with the nature programs that the BBC produces. So we collaborate with the BBC quite a lot. And anytime you see David Attenborough, if you know him on the TV, that's pretty much always a co-production with us. So the latest production that's going out right now is Green Planet, which gets towards 5 million viewers per episode. And then you can see on the main BBC website, which I've just copied on here, you can see in the bottom left-hand corner that there's a pointer to the Open University. So people can watch the program. If they're interested in some aspect of something that David Attenborough says, then they can download resources from us and they can start free learning with us, or they can actually start a degree. So we have a lot. So Blue Planet 2, Frozen Planet, also programs like Coast, More or Less, Big Bang are with us. So that's a context of the Open University. Over the last years, I've been developing an AI strategy for the Open University. So how can AI support education especially education in our context. So in this figure on the right, the core of all of this work is an enterprise data hub, which ours is called Titan. So that's where all of the data of the Open University would go to. And then around that, we have a machine understandable layer, which is actually a knowledge graph, which is the same technology that Google uses and something that we've been researching in my lab for 20 years. So it's basically making, imagine if you had machines that understood all of your course materials. They could basically read them and summarize them for you. They could talk to you. You could go home and speak over your mobile phone or on your smart home speakers and question machines about the content. In the machine understandable content, we'll understand the emails that we get from the students and we'll understand the chat. So you have this machine understandable knowledge graph in the center, conceptual graph, and then around that, we will create a number of AI services to support teaching. So if I start in the top left, the first one, which we're putting a lot of effort into, is something we call a digital assistant. So this is a, basically when you sign for a degree at the Open University in the future, you would get your own personal AI that would follow you through your lifetime. Students are studying part-time with us, so it takes them 6 years to finish their degree. So it will be able to answer the equivalent of FAQs, answer pastoral questions about how can I get help for X or Y, answer questions about the content of what I'm learning, share data. I'll show you more on this about the learning experience. The next one, going clockwise, is something we call the Dream Machine. So this is an AI, which is an AI career coach. So you could go to advice, I want to be a doctor, I want to be an astronaut, I want to be an engineer. These are the courses I'm taking now, the AI would know that. What should I take in the future to have a best chance of moving to that job? Or I'm taking these courses, what sorts of careers are open to me now? Next on the list is the AI for free learning. So we're working on AIs that can automatically mark your coursework. So mark your essays, mark quizzes, and then we want to put them on the free learning platforms. So when you go to a free learning platform like FutureLearn or Coursera or edX, the learning is free, but you pay for certification. You pay £60 or £100 to get a certificate because you take a test. So we think we could reduce that cost to zero by having AIs mark your coursework for you and give you free certification. Next is, and I'll show you a bit of this one, is an AI to create the materials. So anyone who's an educator knows that creating online materials is not easy. So this would find the materials for you in a way you can find programs on Netflix or find music on Spotify and then help you stitch them together. And then the final AI is a tutor assistant, which would monitor the student progress and support the tutor in personalizing intervention. So saying this student is in trouble, he or she needs extra help. Okay, so let me show you. I'm going to show you in the rest of the talk some elements of these, and then I'll move on to the blockchain side. So here's a proof of concept that we created for our tutors. So this is a sort of first version of a Netflix style recommendation engine, but it's for educational resources. So if I just start it, the educator goes in, they say, I want to create a course. You say a little bit about the course you want to create, how many blocks, what the types are. And then you see when you add the block, the recommendations at the bottom change. So as you're adding in more details about the students you're targeting and the type of course you're creating or involved in, the recommendations change. And then you can look at the recommendations, examine them, get an overview, see what the ratings are, see what the licensing is for that material, and then you can select one. So as you could in your Amazon shopping basket, you can add one in. and then do that. That's the AI for course creation. This is a version, actually we've had it for a long time, of the beginnings of an AI for tutors. This is something that we've deployed actually since 2013. It's called OU Analyze, and it's what's called it's called a learning analytics engine. So with this, we use 4 machine learning methods to predict, in the best cases with 95% accuracy, is this student going to pass the next assignment? Is this student going to pass the course overall? And what we're doing is the machine learning algorithms learn over the previous data for last year's students, and then use that to predict the behavior of this year's students. So you see, this is an old screen snapshot here. You see that I have 215J and 214J in the top bar. So J means the students who start in October, because that's the Jth month. And so I'm using the data from the students from 2014 to predict the behavior of the students who are studying in 2015 as the machine is running live. In this top level graph, the bar graphs are the student scores in the assignments. So, and then the orange graphs, orange bar lines are what the students got, or the predictions for what the students will get. The line graph are the students' interactions with the virtual learning environment. And then you can see that the behavior of the students are roughly always following the same pattern. In general, students tend to interact more when there's an assignment coming up or an exam. Then underneath that, I have the summary data for the students. We have 910 students registered for the course, which is slightly down, 635 active on the VLE. Number of students predicted to not submit, it's quite high, is 307. Last TMA is a tutor marked assignment, the average and the number of submissions. And then below that, each row is an individual student, and then the machine learning algorithms vote. And then you can see here for the first student, they're predicted to not submit. And the final result is the AI thinks that they will fail the course. For the second student, they're predicted to submit the next one, but still they will fail. So they will submit their assignment, but they will fail it. So the student, in fact, the first students aren't doing very well. But then if you look at the fourth student, they're predicted to get a distinction. You can click on the student and then you can zoom in, and then you get the comparison of their data to students like them. So you can imagine this is one big semantic graph, and there'll be students closer to other students, and then you can measure their distance either by the demographic data. So that is the where do they live, what type of job do they have, their gender and personal circumstances, or you can predict by the interactions with the virtual learning environment. So for some courses, we can predict with 80% accuracy, is this student going to pass the course even before the virtual learning environment, even before the course starts, because the virtual learning environment is actually open and your initial interactions are important. In fact, one advice I would give to students from this is start your coursework early. If you start your coursework early, you always do better in a course. Okay, so here's another AI they're involved in. So this is an initial design for an AI, an avatar that the students would interact with on a mobile and on the laptop. And so I could go up and say, hey, I submitted my assignment. What's happened to it? Okay, so you can get a nice personal interaction, find out information. And of course, the difference between this and a human tutor, even though human tutors are wonderful, is that this is available 24/7. And you can interact in any context that's amenable to you. I just want to show you a little bit under the hood of what's going on. So we have a database where we record all our interactions with the students. And we've run some data analytics over nearly 2.5 million service requests, which came in either by email or from other messaging system over the last 5 years. And then we can see the analysis is in these bubbles. And the bubbles, the size of the bubbles means that there are more intents. And what an intent is a particular task that the students want to carry out. And you can see that there are 4 main areas of tasks that students are inquiring about. One is a general inquiry. One is I want to enroll in the course. One is a fee. How do I pay? One is study intentions. I want to study to be an engineer. I want to study to be a doctor. What should I do? And it said these are by email, web chat, phone, or web forums. And we've categorized them into, as well as the size of the bubble, which is the intent, what's the volume, how many requests do we get, and how hard, that's the y-axis, and the x-axis is how hard would it be for us to implement. And by hard, it's not just the AI, but also the, how hard would it be to integrate into OU systems? So you can see here, for example, that most of the students' requests are about registering. I want to register for a course. And then you have some on funding, some on technical support, some on studying. So this is allowing us to build a virtual model of what a student is. So, okay. Other things that we're doing, I'll go over quickly. So we've built some proof of concepts of AIs to mark photographs, so which we deployed in an experimental fashion on a Future Learn digital photography course. And the AIs could give an aesthetic score, so how pretty the picture is, and also give technical feedback and suggest ways that the students could improve their image. Okay, so that's a lot about an AI. I'll say something about the work we're doing on blockchains now. So, so this is a vision that we have. So in general, many organizations can have a lot of data about you. So Google has a lot of data, Facebook has a lot of data, and universities could have a lot of data. So we want to, what we call, make students self-sovereign. So we would like students to be in charge of their own data and in control of that. And we think a blockchain can help. So we imagine a future where when the parents or guardians know that they're about to have a child, they would register that child on the blockchain. So the date of birth certificate, the birth certificate would go into the blockchain. You can already do this in Brazil. Then as the child goes up and they get other certificates for vaccinations, very important now, or they get awards at school, they would all be registered on the blockchain. And then eventually, if they join something like the Scouts, they get more badges. If they complete national certifications, they go on there. And then when they're 16 or has appropriate to the particular country, they take control and they get their driving license and a degree. And that would be there for them, all under their control, for them to manage. If you believe in lifelong learning, which I do, that you don't know everything when you're 22, then you're not going to learn in one institution. So obviously one needs a non-centralized way of storing certificates. We've been working on various projects of creating regional blockchains, so one for UK for computer science. So as computer science degrees are issued, an extra layer from us would add them onto the blockchain. So I was involved in a £40 million project called the Institute of Coding, which was launched by Theresa May when she was the Prime Minister. And this is one of our partners, Queen Mary University in London, with one of our certificates for beginner programmers, and that sat on the blockchain that we ran in my lab. I want to talk about, I'm going to switch between the AI and the blockchain work because there's a link between them. So I want to talk about the Dream Machine, the AI career coach that we're also working on. So here we use an ontology. Ontologies are used by all the big tech companies. It's something that we started looking at actually in the 90s. So if you type Amity University, I did this in the UK, so I found the London office, you get this panel on the right in Google. And that's because Google understands in some sense what Amity is and can tell you where Amity is located in London, can give you their phone number, tell you when they're open and closed, and tell you where you say they have Mumbai in there and other places. So Google knows that because it has a conceptual graph of the types of things that people look for. And underneath that is a conceptual semantic framework, which is an ontology. So we will have a skills ontology for the dream machine. So skills, for example, you can see here, we're going to borrow skills. So think about ontologies that they can be published on the web. So in a way that you can reuse web documents, you can reuse web ontologies. And we'll use one called ESCO, which comes from the European Union. And you can see that, for example, that project management, to be a project manager, you need skills like liaising with managers, performing resource planning, managing staff, etc. To be a management skills, including applying management, you need to be able to recruit employers, etc. So what we'll do is we'll have we're going to build a tool which ingests CVs. We'll ingest the CV, analyze it, understand the skills you have in terms of giving you future advice. We'll understand your past occupations, understand the skills that you list, etc. And then it will be able to reason on that. So for example, if Maxi is one of the people I'm working with, if Maxi has said that he was formerly a project manager, the system automatically understands that Maxi has all the project management skills that are required. So then we will use this functionality to map between 3 different types of stakeholders: students who are growing their CVs, employers who are looking for talent, and educators who provide courses. And the glue between all of these is skills. So we call it the dream machine because students have a dream, we believe. They want to be whatever, astronaut, professor, or footballer, whatever. Or somebody has a dream that they want to change job. And then we can use this with an ontology with reasoning to map between them. So here's an example of how we put this together. On the top left are physical badges, physical blockchain badges. The students were studying in a course at the summer school. They had a physical badge. Every time they completed the task, they would go to their tutor. The tutor would swipe them with a swipe card like this. And then the badge would change color and it would go onto the blockchain. On the top right, we have a mapping between the skills that employers are looking for, which is based on an international standard for computer science. And in the bottom right, I'll start playing the movie, is a proof of concept we created where Michelle Brown is studying short courses. She's acquiring skills. And behind the scenes, we're extracting the skills from online blockchain badges and mapping them to jobs, which we find online for her. So as you can see where all of those jobs are in Europe, she might be interested in moving across to another European country. And then below, there are jobs for which she's nearly qualified for. And the system will say, well, you're nearly qualified for this job. If you take these extra courses, then you'd be fully qualified. So you see she's missing data mining. So the system has found some data mining and data management courses, which will help Michelle. Okay, so let me move on to, here's another app we built in the same vein of helping students. So imagine the students have a smartphone app where you're storing all your certificates. So if you study at Amity, you study at the Open University, you study at Oxford, it doesn't matter. All these certificates go to you. And then you can, when you apply for a job, you can, and this was they get an email, this is from Tesco's, you can send your certificates there, just the ones you want. And then that person can only see it for a limited amount of time. They don't get to see them forever. So you remain in control. of all your certification. Just to wrap up, just some other things that we're working on, what I call student-centric machines. We did some work a while ago with students studying a sports fitness course at the Open University. So they had a Fitbit type device, a wearable device, so they could use themselves as their own subject. So they would go walking and running, and all of that data went into servers in my lab. Then they could see themselves and they could analyze, do my weekly calories change if I'm running or walking or cycling or swimming? And then we also used augmented reality. So on the top left is a human musculoskeletal system that the students could look at in 3D on a mobile device. And then a new project we're starting on, linked to the type of things that I was showing earlier, Green Planet, is we want to produce a new layer over your smartphone, which turns your smartphone into a haptic device. So children can feel leaves and can feel the bark of trees and stroke the fur of animals or insects out there. And then that will motivate them to engage in learning. So then to summarize, we have an OU AI strategy, which is now part of a new 5-year strategy for the OU. And I believe this will transform not just OU teaching, but all university teaching. It's based at its fundamentals around having machine understandable content. And we have 5 AIs envisaged, which I've gone over some of them. Okay, thank you. Thank you very much.
Thank you, sir, for your enlightening words. It was a pleasure to listen to you give insights about transforming higher education through AI. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth in the field of transforming higher education through AI. I believe your words have set new levels of expectation that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to have you with us, sir. Thank you so much.
Thank you, it's a pleasure. Hopefully next year I can come in person. So,
sure.
Okay, bye-bye. Have a good rest of the conference. Bye.
Thank you.
So, good afternoon to one and all. So, let me introduce the speaker today, right now, the current section. So, good afternoon to all the dignitaries, professors, and participants present today. So, on behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022, which is the 12th International Conference on Cloud Computing, Data Science, and Engineering. Even though we would like to invite you to our campus and have the keynote session in person, current world scenario impede us from doing so. So luckily, we are grateful to have the opportunity to keep keynote session in a virtual mode so that our student can reap the seeds from knowledge gathered in this section. So today, I am profusely elected to take the opportunity to invite our honorable speaker, Mr. Rajiv Singh. Sir is a senior management professional, part of the Sopra Steria India leadership team, with over 21 years of experience in IT industry, with proven leadership in driving medium to large transformational engagement. SAR has a long track record for successful delivering the strategic business change programs to a diverse range of organizations in the travel and activation industry. SAR has a unique combination of very strong technical, managerial, and leadership skill. So he holds end-to-end responsibilities for the cloud business, relationship management, account management, customer engagement, financial performance, and service deliver of large sized complex program. SAR has contributed delightfully in the field of Cloud Center of Excellence in Sopra Steria at the group level. So SAR has defined Sopra Steria cloud offering and go-to-market strategy. So with the current role, SAR has been able to win cloud deals from many, around 10 European large customers. In addition to that, Rajiv SAR is also responsible for delivering the digital enablement platform, which is digital component of top hybrid cloud leveraging Azure Stack. Okay, and SAR, you are the ideal knowledge, experience, and inspiration to many in the domain of the current cloud computing field of the work and with so much of broad area. Sir, you hardly need any introduction. So, sir, we invite you on the platform to share few words with us. Thank you, sir.
Thank you so much, sir. Thank you for the introduction. Much appreciated. So before I start, I just wanted to know about the audience, how many students we have, because I see just 4 participants. I understand you may have.
No, sir. Only the part is that here the administrative part we can see, but the student part we can able to see, sir, because more than 100 number of students are already there, sir.
Okay. And is it going to be interactive? Can they ask me questions? Can I ask them question?
No, it's not like that, because we have a limited of time. And sir, whatever the questions we have from the student side, that I have already been shared with the student. So that things we'll share with you, sir. So as per your convenience, we can give your feedback, sir.
Perfect. Thank you, Soumya, sir. So first of all, thank you so much for the invite. Such a pleasure to joining you all, especially the students. Before I start, I would say thank you to all respected professors. Great to be here. Topic is such that I can keep on talking for hours on this cloud and data science. And I've been thinking about how shall I unfold this conversation and make it very interesting for the students. So cloud is something wherein we should be looking at as a more of a business enabler than the technology enabler. 10 years ago, maybe in 2007, 2008, a lot of people looked at cloud as infrastructure. Now that view is changing. CIOs, CTOs have started looking at cloud to be a business driver. If you really want to innovate, the place is cloud. And I think what I have done is I have put together very few slides, just to put across my point onto the cloud. So let me present that slide to you. Can you see my screen, Soumya sir?
Yes.
If you can just confirm.
Yeah, it's visible at my end, sir. You can proceed.
Yeah. So I was thinking to put together something wherein we can have conversation, because cloud is different for different people. If you ask infrastructure expert, they will say, "Oh, cloud is infrastructure." If you really ask experts of data science, AI, ML guys, they will say, "Oh, a lot of tools and features are available there." So it is different for different people. Now, how do you use cloud for your own transformation is the key question. So before getting into, what cloud is in 2020 and what cloud is going to be 2025. So yeah, in 2020, it was just a popular computing style. Everybody wanted to learn cloud. Now in 2025, it's going to be pervasive computing style. It's going to be everywhere. Initially, people used to consider cloud as a technology innovation. Now it's a business innovation. If you really want to do any business innovation, for example, time to market, build new application, host new application, starting a new business, you go to cloud. It was a centralized cloud. It is centralized and distributed cloud. And distributed cloud by design. Earlier, people were saying, oh, we go to AWS, we go to Azure, we go to GCP. But now more and more people are doing multiple cloud. A lot of people are realizing everything can't be on cloud. So they really need to have hybrid cloud or private cloud for that matter. Initially, when I started having conversation a couple of years ago, multi-cloud was unintentional because our customers are large enterprises. They have the silos, and in the silos, they will have one function going to AWS, other function going to GCP. Now, intentional or intentional multi-cloud because people are deciding to go there. So these are the certain changes which are coming through. Now, if you look at, this cloud as from 5 dimension, what CEOs are saying. So pandemic accelerated transformation journey. If we are able to have this conference primarily because this Zoom is hosted somewhere onto the cloud and all of us can get connected. Years of transformation happened just in a couple of months. Google is significantly investing into cloud. And we talk about agile. A lot of people in software engineering world, think agile is a methodology. Scrum, therefore, they think it's a framework. But I think what we don't really understand is the speed. Agility is measure of speed. So it's no longer the big beating small, it's fast beating slow. And that's where I think cloud comes in. I remember my days wherein if we have to order a virtual machine on somewhere in some data center, the ETA was 22 working days. So imagine to have a just virtual machine, we had to wait for 22 working days. Now within a couple of seconds, maybe 22 seconds, I can just go to AWS and have my own virtual machine of whatever size I want. So that's the difference. Now, in terms of revenue trends, let's look at the business dimension of the cloud. So European cloud growth, we are European player, hence the numbers are for Europe. From $35 billion, it's going to be 140 in what, 6 years time. When you look at forecast from IDC, primarily infrastructure as a service and platform as a service, it's going to be more than $400 billion. Overall business is going to be almost 1 trillion in market size. Platform as an offering like FinOps, auto healing, control plane. I'm not sure if these words make sense to you, but these are very, very important topics. For example, FinOps. When enormous computing is available at your disposal, when almost access to all services is available to you, we end up using so many systems and services which we don't need. And cloud being a new field, we end up designing a system which may not be the right, and wastage comes in, which increase the cost instead of being cost effective. And that's where you really need financial operations. Auto healing, I think, is absolutely important. How application can be auto heal, how you design application for failure, and then application auto heal. Control plane is absolutely important. When you have thousands of servers in your environment, how you push your security policies, how you secure those VM servers, applications. Souvenir cloud is gaining momentum because data is important. I think this topic is anyway about data. Imagine the Aviation, which is manufacturer of Rafale, have to store their data on public cloud. I really don't think they are ever going to do that. The kind of systems they have, kind of application they have, but then they need cloud-like services, and that's where Souvenir cloud will come in picture. So more and more players are going to have, access to souvenir clouds like cloud player like OVH. We are working very closely with them. I'm not sure if people have heard about OVH cloud in India. And then everything as a service, is a smart cloud, omni cloud, new perspective. And then if you look at the technology trends, we did talk about hybrid multi-cloud. We did talk about migration, modernization. The last statement at the bottom is really interesting. Only 9 to 10% of the workloads have just moved to the cloud. Rest, everything else is still working on on-prem. So how you migrate, how you modernize, containers are going to be pervasive. Earlier, in last 20 years, we have been working with VMs. Now we are going to work with containers. Cloud security and standards, more and more, we are seeing that kind of cyber attacks we are having across the globe. All of us are hearing various challenges with the security. So this is going to be an absolutely important field of innovation. Cloud security. If cloud isn't secure, I think people won't go to cloud. And then analytics and AI, though there is a topic of data, but then analytics is of course equally important. What do you do with the data at rest? Now, what is that we are trying to do in the cloud? So a lot of banks, a lot of enterprises, 100 years ago, organization which came, they're still running mainframe. So we are helping them, taking their mainframe to cloud. So multi-skilled people are needed, those people who understand mainframe technology and understand cloud as well, which is a very rare combination. We did talk about cloud economics. The way costing has been designed, it is very, very important to understand how cloud works, how cloud cost will work. Cloud escalators, when customer is trying to go to cloud, how we can help them, because we are anyway helping many customers. So how can we have reusable solution which can be deployed again and again, and that's where we can have this escalators. VCPM is kind of a product which we use for the discovery, and we use intelligence inside this to take decisions, and output of this strategy goes into journey of go to cloud. Mature customer, we go with critical applications. The customer which are not mature into the cloud, we look at applications wherein compute is low, storage is low, and our customers can gain experience. Container as a service is key, because people ask for portability. They don't want to get into lock-in, and that's where I think containers are becoming key. Anyway, if you really want to run multiple versions of libraries of the same language, containers can be really very, very helpful, very, very effective, fast. SAP to cloud, a lot of people are still running ECC6 SAP. There was a point on control plane, similarly landing zone. So when you go to cloud, how you land, you can't just give access to your production environment to anybody. So yeah, various things we are doing. We are building our platforms as well. For example, the inner data platform you may see here. It's a AI platform which we have. Digital health platform, which is a trusted platform. Arrowline AI platform, which is primarily for manufacturers of the planes. So this is what we are trying to do. So starting from assessment and discovery to operations, we are helping our customer to go on end-to-end journey. If I may move to data, before I talk about this slide, I think it is important to understand data and what is happening in industry. And I think it is important to talk what I see in industry. I see a lot of data scientists, but when I interact with them, I feel they are more of AI ML engineers. They know Python, they have information about various models, but then they really don't understand business and application of AI. And AI is anyway the tail end of the data science. The most important requirement for AI is to have the data. And when you call it data science, it could be data analytics, it could be ML, it could be AI, whatever you want to call it. various functions of the data. But then biggest challenge is to have the access to the data. And remember, we are coming from a world wherein we first decide what we want to store, what we want to discard, and what we want to keep. Remember Y2K problem? The whole problem was that we did not want to store 2 bits of year, and that created big problems. Now we want to store everything. So the traditional IT is still there. It has not gone away. The silos of data has not gone away. What you really need to have is the data. If you really want to harness power of data, you really need to have unified view of data. Data is anyway proliferating to everywhere. A lot of people talked about big data, and I was doing some research and realized that big data term was coined in 1987. It's pretty old. When you look at what experts are saying, that exabyte data is going to be pretty normal. A lot of customers are going to have exabyte data, and getting value out of this data, which may be relational, which may be unstructured, which may be graphical, which may be key value, I think is going to be a big challenge. So before you land onto this slide, it is important to have end-to-end data platform, which is you have the data storage, you have access, and before you have access, you have data governance, and then you have analytics. And once you have analytics, then you decide how the data which you have can fuel innovation, fuel ML, and that's where prediction can come in. If you look at this slide, primarily there are 2 types of application: traditional application, the web-based application or client-server application, wherein you have the rules, you have the data, you are using traditional programming language, you interact with the application, you will get answer. But what happens with a data application or data use cases? You have the data, you have the answer, you apply the machine learning, and then you get the rules, and then you learn from the data. And of course, you need to monitor how your machine language is behaving so that you can keep on improving the gaps. And quality of output is anyway going to depend on quality of your data. It's pretty simple. If your data is biased, output is going to be biased. Unfortunately, we have a lot of biasness in data. So, sir, any question coming through? Can't hear you, sir. You are on mute.
Oh, sorry, sir. Actually, they have joined through a virtual platform, and we have given the link. So that link we'll share with you people, sir. Because
okay.
There are a lot more, I think more than 100 number of keynote speakers they are giving. So it's very difficult to give at each of the instance. So
okay, no problem. So I'm conscious of time. I'll just complete very quickly this data science. So yeah, so first step towards data science is to have the right data and right data platform. And right data platform is bigger than one data store, one data warehouse, one data lake, one analytics platform. You really need to have end-to-end data solution, unified view of data solution. And once you have unified data view, you can apply a lot of data science onto the data to innovate. And there are various use cases around us. If we start thinking through, imagine Zomato, Amazon, supply chain, any supply chain, when you order, where the order has to go, who has to supply. Even if we save 1 kilometer every order, imagine how much fuel we can save. And when you multiply with the kind of volume e-commerce players have, the kind of savings they can have, kind of carbon footprint they can save is incredible. And hence a lot of innovation can come through data. And the biggest important point is power of awareness. A lot of people have data. Data is at rest, but then they can't make anything out of data, especially a lot of traditional enterprises. If you can identify pattern in your data, and if you can predict using on data, if you are aware what's happening in your business, you can innovate, and you can innovate a lot of stuff. When you look at this traditional, ML code, there are various things happen around it. I won't go into details in interest of time. And once you have this ML powered by data, you get into prediction, and that's where you start innovating. You start taking informed decision in your business, and you bring efficiencies in your business. One more example of production readiness. You have a code, you have integration test, you have running traditional application. When you get into AI, the system may be very small in terms of code, but then it is much more difficult to deploy into the production and making sense out of it. So you have data test, you have SKU test, and you have data monitoring. What kind of data you have? Then you have ML infrastructure test, you have various models, and even for one use case, you may have to deploy multiple models. You deploy them, you predict, but you keep on monitoring your system for prediction, because its amount of data will decide how mature your models are going to be. So that's the key. So what kind of features and data set you have, what kind of infrastructure tests you have, what kind of monitoring tests you have, how much biasness you have in your outcomes. Something on artificial intelligence primarily. If you look at deep learning, machine learning, artificial intelligence, various functions, specialized in one area, solve one problem is ANI. Artificial general intelligence refers to a computer that is as smart as human across the boards, which is of course rare side, not yet. Artificial super intelligence and intellectual intellect that is much smarter than the best human brains, particularly in every field. Again, these are the stages which we are yet to reach, but I'm confident we are going to reach there eventually. What we need, of course, we need to have data. We need to have data platform, end-to-end platforms. We need to have various algorithms, and we really need to drive probabilistic models of complex events by training on the data set. As of now, the biggest challenge is to have the data. I was reading an article which came out from US that US chief AI program head has resigned because he feels that US has lost the battle in AI to China. And when I was reading the article, it was quite data, ethics, training. So a lot of challenges around AI with regards to data. I think last slide from me, 3 ways of learning in ML: supervised, semi-supervised, unsupervised. If you really have to achieve that scale huge, you will have to eventually go to unsupervised model. To main purpose of ML, of course, you need to have analytics. When we were talking about, you have the data, you do your various business intelligence, you have various types of analytics to draw inferences from the data. But then even on the ML, you really need to make prediction how things are going to happen, and then you reinforce learning, and that's how you improve your business. So last thing from me, don't look at data science or cloud as a technology. Try to link these technologies with the business outcomes. And once you understand business outcome, once you understand use cases where you can deploy data science, and that's where the value will come out of it. Thank you so much for inviting me. Thank you so much for listening to me. That's it from me, Soumya sir.
Thank you, sir. Thank you for your enlightening words, sir. So it was a pleasure to listen to you give insight about business context and drivers based upon the cloud market trends. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new idea to broaden their knowledge for expanding growth in the field of cloud computing in association with AI and deep learning based technique in current industry. I believe your words have set a new level of expectation that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. So we are highly grateful to have you with us, sir. Thank you very much, sir.
Thank you so much. Thanks for listening. Bye.
Thank you so much, sir. So our next speaker is Professor Dr. P.S. Grover. He is facing some technical issues, so he'll be joining us shortly. I want you all to please stay tuned. So I can see P.S. Grover sir has joined us. Good evening, sir.
Good evening, sir.
Good evening to all dignitaries, professors, and participants present today. On behalf of MIT University, Uttar Pradesh, Department of Computer Science and Engineering, ESET, I feel privileged to extend my warm welcome to one and all for this keynote session. Even though we would like to invite you to our campus and have this keynote session in person, the current world scenario impedes us from doing so. So we are lucky enough to have the technology with us to have this keynote session in our virtual mode. Today I am profoundly elated to take this opportunity to invite our honorable speaker, Professor Dr. P.S. Grover sir. P.S. Grover sir has been Professor, Dean, Director and Head of Computer Science Department at University of Delhi. His areas of research interest are software engineering, big data, and academic analytics, software quality and matrices, atomic computing, outcome-based education, and continuous improvement. He is a very active researcher and a prolific writer. He has published more than 200 research papers in various journals and international conferences of repute. He has been a regular consultant to software industries like TCS, IS Infotech, etc. He is a lifetime senior member and fellow of Computer Society of India, fellow Institute of Electronics and Electrical Engineer, member Indian Society of Technical Education, Quality Council of India, and IEEE USA. I welcome you, sir. I'm really honored to welcome you in Confluence 2020, the 12th edition of IEEE Confluence. Over to you, sir. I welcome you, sir.
Sir, you are in mute, sir.
Yes.
Kindly unmute.
Right.
Okay.
Thank you, Dr. Misha, Dr. Soumya. Is my screen visible?
Yes, sir.
Yes, sir.
Okay, thank you. Can we start?
Yes,
Yes.
sir.
Okay. Good evening, participants. It's really a great privilege and pleasure to be able and join this international conference on Confluence 2022, which is being organized by the MIT School of Engineering and Technology, MIT University. This is a feature which is so important from the academic world that everyone looks forward to participation in this. So I really appreciate the organizers to invite me to deliver a keynote address. And the topic that I'm going to talk with you is something which is a very important, latest. It is artificial intelligence for social good. Many of you must have been working in the area of artificial intelligence, doing a lot of work. Now, this talk will focus on how the applications of artificial intelligence, the research in this area, can prove or is proving useful for the welfare of humanity. What is the impact of what we do in the area of, as a researcher has on the social bearing? Now, what is social good? It will be interesting to appreciate. Social good is something that benefits the largest number of people in the largest possible way. such as education, clean air, clean water, healthcare, literacy, and so on. So social good is about getting people to engage in social work that benefits society, often by harnessing the society power of technology and social media. It's about engagement, shareability, and bringing people together to change the world for the better. Earlier, governments, multinational and large NGOs, they were involved in the welfare of humanity because they had the resources. But now, with the coming up of the internet age and the social media like Twitter, Facebook, and Instagram, there are tools that can be used to engage people in social good actions. They allow people to share ideas, advocate to solve pressing societal issues, maybe education, maybe healthcare, and so on. Those online platform communities, see, we are, there's a strong, there are very large communities, online communities, where people can express their views, where people can raise their voice. Individual can add their voice to a cause. It could be a cause for humanity more easily than ever before and feel like they are an agent of change. Because when we can express our views, then and they are taken care of, then we become a agent of change. Now, when we say social AI for social good, it's a relatively new research area at the intersection of AI and a number of other fields, science, technology, humanities, engineers, that focuses on tackling societal, environmental, and public health challenges that exist in the world today using artificial intelligence. Now, social good implies welfare of humans having a positive impact on individuals for society. Now, just to give you an example, people can just appreciate to begin with. Supposing we are concerned with the education of the children, because millions of students, small children, are not able to go to the college, or to go to the school, but to say the college or higher education. Now, there is an organization like Foundation to Educate Girls Globally. FEGG aims to find solution to enrollment and learning gaps in primary education of girls. Now, please help. There are millions of young girl students. They don't go to school. They don't know how to spend their time and develop. So this organization identifies who are out of school, enrolls them, and makes sure that they continue going to school. They don't miss the school. Now, using artificial intelligence and machine learning techniques, and with the help of, there is an organization, ID Insight, a global data analytics and research organization, they are able to identify villages that have the highest number of girls out of school with an accuracy of over 80%, and then focus on that village to improve the education of these girls. Otherwise, it was not knowing which is the village which has the highest number. Finding out these things is carried out with the help of artificial intelligence and machine learning techniques. Now, this application of AI is enabling the welfare of a large number of students and enable them in education. Not only this, United Nations has identified that in order this world to be a world where everyone gains, everyone is happy, they have identified some sustainable development goals, like there should be no poverty, there should be zero hunger, there should be good health and well-being for all, everyone should get quality education, then gender equality, clean water and sanitation, affordable and clean energy, and so on. So UNO has identified 17 areas which are of public utility, which are of social good, which needs close attention, because their sustainable development is essential for the welfare of humanity. Now, how it can be done? It cannot be done by the traditional methods. It is done, in order to do this thing, they are utilizing AI. Now, when I say AI and its relevance to human good, see, human good means when the standard of everyone is raising, people are getting educated, the climate, the environment is friendly with the human beings. There are hardly any crimes. So that means in order to these are these social good entities. So the artificial intelligence now is being devoted to making machine think and act like human beings. That's what artificial intelligence does. Artificial intelligence is the study of how to make computer do things that people do or would do better. And we would like to do it, but we want the computer to do it. Understand life interactable problems and suggest likely solutions. Human beings, they solve complex problems. AI is contributing human conveniences. AI and along with machine learning and deep learning can help to manage extremely complex problems such as human rights, good health for all, and so on. Now, see, machine learning, artificial intelligence, together with machine learning and deep learning, they are solving these problems. Artificial intelligence is a science devoted to making machines think and act like humans. Machine learning focuses on enabling computers to perform tasks without explicit programming. And deep learning is a subset of machine learning. So machine learning and deep learning, which are sub-subjects of artificial intelligence, are affect our lives for generations to come, and virtually every industry will be transformed by their capabilities. Dangerous jobs like space travel or work in harsh environments might be entirely replaced by this, like this. So AI contributes to all sectors of human activities in different fields, maybe agriculture, commerce, education, environment, medical, commerce, entertainment. Some examples are forecasting weather floods, monitoring marine life, detecting plant diseases, and so on. So AI is impacting the future of virtually every industry. Now, these are, for example, when we are involved in predicting diseases like COVID-19 is something which is good for the entire humanity. You all must have been, we have been in this epidemic for the last 2 years. And we get so many predictions. We get so many observations. Those all observations are coming out with the help of AI applications. So then AI is useful, used for human. AI has acted as the main impetus for emerging technologies like big data, robotics, IoT, and will continue to act as a technology innovator for foreseeable future. Like say in the homes, when we use digital watches, washing machine, these are all the devices which are using AI, and they are helping make our life better and more and comfortable. Expert systems or knowledge-based system, you're all familiar with this. They are a computer program which help us to capture knowledge of human experts and help in decision-making. So this has made our decision-making very simple. And rule-based systems involve the use of knowledge bases, inference engines, logic programming. Now this is, when we say knowledge bases, now we are having data in terabytes and petabytes and so on. How do we extract knowledge from there? How do we use this knowledge for that thing? So the AI-based software system have been designed which help in the medical domain. They help in the monitoring systems, process control, knowledge domain, commerce, and to mention a few. Now, these are all making the life of human beings or of us in a much better way. Now, other technologies which are contributing toward the welfare of the human being are, in addition to AI, are the computer vision, natural language recognition, natural language generation, speech recognition, and so on. And this has led to the development of devices like robots, the technologies like cobots, chatbots, software agents, and several others. These are the devices which, using AI and these technologies, are contributing to our life in many ways. See, when I say robots for social good, how? Robots are being increasingly deployed at several places such as airports, shopping malls, care centers, and even homes. Some robots even handle social situations or are designed specifically for emotional response. So researchers are developing robots for social good that contribute to positive social changes for socio-political issues like ageism. For example, robots are proving extremely useful for the senior citizens, for homeless, for environmental issues. These are what are known as social robots. So robots in hospital industry, we are all familiar with this thing. How they can walk, they can turn, they can go stairs, they can do a variety of things in the hotel. For example, doing housekeeping, cleaning floor, and so on. Now, domestic robots and cobots are there. We are all familiar with the domestic robots. Domestic robots are making the life of our living very convenient, very efficient. Maybe in the cleaning, maybe in the maintenance of the record, maybe in the monitoring, maybe in the sweeping, and so on. These are all commonly available. So another very important aspect of robots, which has been observed only during the pandemic, see, pre-pandemic season, applications in highly developed countries with declining populations such as Japan. Then the application of robots was to reduce costs and replace extensive human workers. But with the arrival, or let's say with the happening of the pandemic, COVID pandemic, post-pandemic, now the issue arises, can we use robotics to protect human workers, even if it means increasing costs? Can we use robotics to create new jobs and opportunity for entrepreneurship, not only for those who lost employment in the pandemic, but others as well? That means the use of robotics is proving in these things. Now, in the post-COVID world society, we need to adopt a more long-term, more holistic thought process. Now the issue is for the well-being of the human being, can we use human robots collaboration to overcome depression and isolation? We are all having a lot of effects of COVID after those lucky persons who were spared by this pandemic, or the school children. We know that they are undergoing, or we are undergoing, a lot of depression, isolation. Now the issue is, can robots, which is an AI enabled instrument, to overcome depression and isolation caused by quarantine and social distancing, and promote more holistic forms of post-pandemic human interaction? Can we leverage robotics to facilitate and promote micro-entrepreneurship, local market, and small businesses? Yes, this is where we are working, and that's where the human and social good is going to be a very focus area of AI applications. Then chatbot. Many of you are familiar with the chatbot, and the companies like Google, Apple, Amazon, they are applying these things. In fact, chatbot is an artificial intelligence application that can imitate a real conversation with the user in their natural language. We are using Alexa, we are using Siri. Chatbot enable communication via text or audio. Chatbots often integrate dialogue systems, and chatbots are sophisticated natural language processing systems. Now, this is where the well-being or the good of the humanity is coming forward. Now, chatbots and social good. Chatbot applications are being used for social good. Chatbot used by UNO to collect survey information via Facebook Messenger, with the goal of amplifying people's opinion to improve the lives of young people around the world. Now, there's a large number, millions of young people. They have their own ideas, they have their own views, but they are hardly heard by the let's say government or by the other organization. So UNO has come up with the chatbots where they collect the information of the young people, let us say providing legal advice to refugees, giving legal assistance to people who unjustly got parking tickets, connecting people to aid providing organization, understanding the impact of droughts, say on countries, supporting health promoting behavior and so on. So chatbots, in fact, these are being these. So examples of chatbots are Wobot. Here, you are 24/7 chatbot therapist. It advises, it gives the medical advice. Quit XT, helping users quit smoking. Mediate bot, creating a daily meditation habit. MSG voting bot, getting people to their voting. Do not pay, do get legal app, and so on. That means a variety of chatbots are coming forward. Now, there is a chatbot moved by the name YouReport, where say your voice matters. They collect the opinion of people across the world. Young people are concerned about a variety of issues ranging from climate change to the economy. UNICEF created its own bot, YouReport. This is a chatbot to give them a voice. The chatbot available via Twitter and Facebook Messenger polls its followers called YouReporters on a range of topics. That means this is the mechanism which the UNICEF has adopted to get the views of the young people of what is happening in this world. What do you think about various important issues? Here, idea is to gather opinion and experiences from those young and participants whose number is in millions and use them to influence public policy. So then AI-based intelligent agents, bots. So bots, anything that can be viewed as interactive, recognizing its environment, collecting data and acting upon that information, defined protocols is a software agent. Now, its software agents are available in abundance. People are being defined. The agents and multi-agent systems are being developed with the help of artificial intelligence system. Agents can be viewed as software systems which perform intelligent actions like human beings. So software agents are quite useful for data gathering. Now, I mentioned about software agents because the way data is being generated in big data, you all know, in petabytes, zettabytes. So that collection of that data, or in the internet, IoT, Internet of Things, so much data is generated, it's virtually impossible to collect that data by human being. So software agents are used to collect data, and then the data is analyzed using the techniques, AI techniques and machine learning, etc. So intelligent software agents for social good are increasingly being deployed into areas such as environment security, climate change, seismic safety, epidemic prevention, detection and response of diseases, disaster management, e-health and medical emergencies, and so on. So this is all for the public welfare. Then machine learning, you see, machine learning and AI are being used to develop wearable devices. Now, wearable devices, you are all familiar with smart finger, smart ring, watch, smart socks, smart shoes. They're all coming up. These are all AI-enabled wearable devices, which can detect potential early signs of diabetes. That means in the medical through heart rate sensor. See, heart rate sensors are available commonly, and they are all AI-enabled devices. So heart rate sensors can detect the diabetes with an accuracy of 85%. They could potentially contribute to helping millions of people afflicted by the disease worldwide. This thus indicating that the wearable devices, which are based on the huge amount of data collected by the software agents and then analyzed, can lead for the welfare of human beings. So wearable devices have been designed, and social good. Embrace is one device, a tiny sleeping bag-like device for premature infants in hospitals that can't afford incubators or that don't have electricity. The warming device can keep babies alive using a simple design. Another wearable device, Emotive. Wearable enabled in more remote, low-cost diagnosis like Emotive, a brain-reading headset that can help diagnose neurological diseases for consumer with more money, it can also be used to help tame stress. That means these devices can do social good by studying the human mind, by studying the human neurological diseases. So wearable devices are also playing growing role in keeping people safe. Smart bracelets are available, like the civil rights defender can trigger an alarm when an aid worker is in trouble. Several wearables are designed to protect women from attack, like Fearless is a wearable device, a device designed in India. Clip Fearless to a bra and it detects if you are being attacked or sends some GPS coordinates to friends and local police. Then sample, see AI and deep learning usage, see it helps to efficient detection of human system, identifying network video surveillance system, automated vision-based surveillance system, detect drowning, detect swimming, deep learning techniques for obstacle detection, real-time vehicle detection, tracking, and so on. So that means these, since AI, artificial intelligence is like human thinking. So we use, like a human making a decision as a human being, we use AI to carry out those kind of decisions and for the betterment of the environment, for the betterment of the health, for the betterment and so on. So AI and deep learning are given like this. And this has been possible because there has been a very extremely nice development in the hardware side also. That means AI is giving flip. The AI usage analysis is giving flip to another technology, that is the hardware technology, where central processing unit, graphical processing unit, tensor processing units are being designed, which in turn help us to accelerate AI calculations and algorithm. In fact, Google develops for neural network machine TensorFlow software using these hardware. Leveraging existing mobile deep learning networks like TensorFlow, Lite, Cafe2, Android, and so on, they can help to build efficient AI solution for the welfare of this. Now, prominent technologies, as I mentioned earlier, are language recognition and generation, computer vision, speech recognition, and so on. So now natural language processing for societal impact. See, natural language processing has created a considerable impact on the societal welfare, on the society, on society's function. So natural language processing is most useful in domains where information is commonly stored in unstructured textual form, such as accident reports, health records, newspapers, articles, and social media. Now, as with computer vision methods, we have, in some cases, a human may be able to perform a task with greater accuracy than a trained machine. So automated systems are there. There are also cases where AI models could outperform the human effectiveness, especially in situations that require processing and analyzing vast amounts of information. Examples are monitoring diseases outbreaks, like the COVID. There, we are observing that there are a variety of strains of COVID coming. We had Delta, now we are Omicron. Now these are being predicted with the help of artificial intelligence for the welfare of the whole humanity. So by analyzing tweets sent in a multiple local languages, as is presently the case during COVID-19, the Indian government has made AI, how it is helping us. So AI helps in language translation. They help in health, some capabilities. Then in health, we see changes in treatment due to language barriers between doctors and patients. Language translation can also be used in education to help students learn new languages. Now, some capabilities. Oh, okay. Now, Misha, I will just quickly go through this thing. Then the satellite data, which is collected with the satellites and analyzed with the help of AI, it helps us to interpret natural disasters, then it helps us to find out, for example, its application, object detection, and so on. So roads, building, and several other infrastructure are damaged with a lot of water, and this can all be analyzed with the help of AI for benefiting this tool, for the common man. Social media is internet-based technology that facilitates the sharing of ideas, thoughts, and information through building of virtual networks. By design, gives users quick electronic communication, user-engaged social media via computer, and so on. Now, the social media, the key component, AI is the key component of the social media networks. And you know that social media network, Facebook, Instagram, LinkedIn, Snap, etc., several others, how they are bringing the human being nearer to each other, how they are contributing to the welfare. They have the other effects also, but we are looking at how these social media networks, which are based on AI techniques, are contributing to the social well-being. For example, isolation, and they are helping us to reduce isolation. Then look at, there are 13 billion of people who are using these websites. There are, maybe it could be more, it could be 15 million people which are using. That means these people are able to communicate with each other. These serve as the welfare of the human being. People use various social media applications to network and find career opportunities, connect with people across the globe with like-minded interests, and share their own thoughts, feelings, and insights. So social media for social welfare is contributing a lot. Other social media impacts are on education challenges, public and social sector management, then hunger, health and hunger, security and justice, environment challenges, environment empowerment, equality and inclusion, because all these are being developed. Now, for example, infrastructure management, look at the metro cities. Metro cities are getting congested. The infrastructure challenges that could provide public good in the categories of energy, water and waste management, transportation, real estate, and urban planning. For example, traffic light networks can be optimized using real-time traffic camera, predictive maintenance of public transportation system, and so on. So then global warming, using AI and data science, researchers can analyze how trees have been disrupted in the forest. Without AI, such a study would not be possible. If we can develop a better understanding of how a forest change in the wake of hurricanes, we can look for measures to combat climate change for the social good. So I think I should stop it here. The reason being, time is running. I'm running short of time, and Dr. Misha
Thank you so much.
Give me a warning, right? Any questions, please?
So students, around 200 students were listening to you virtually, and their question will also come virtually, and we'll share the question with you, sir.
Thank you, please.
Thank you, sir, for your enlightening words. It was a pleasure listening to you, giving insights about how AI can be used for social good. We feel privileged to have your supervision backing us. On behalf of MIT University, Uttar Pradesh, I would like to extend my warmest welcome, warmest gratitude, knowing that you are so busy, you are engaged in so many tasks. You agreed for giving this keynote session. Thank you so much, sir, for imparting your valuable knowledge on us. We are highly grateful to have you here, sir. Thank you so much.
Thank you, Dr. Misha. I know I have quickly gone, we went very fast with the other slides, but I hope this will give just a feel of it. It's
Yes,
not an idea, this will give a feel how AI is important for the welfare of humanity. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, Dr. Somaya.
Thank you, sir.
Right.
So we are joined with our next keynote session, sir. Keynote speaker, sir.
Yes, sir. Professor Dr. Arun Somani, sir, have joined. Okay, so before going to start the session, So let me introduce Professor Dr. Arun Somani, sir. Good evening, sir.
Good morning or good evening, whatever it is, right?
Yeah. So
Early
from your
morning.
side, it's good morning. From our side, it's good evening. Okay. So good evening to all the dignitaries, professors, and participants present today. So on behalf of Amity University, Uttar Pradesh, Department of Computer Science, ASET, I feel privileged to extend my warm welcome to one and all for keynote address for this particular Confluence 2022. Even though we would like to have to invite you to our campus and have the keynote section in person, current world scenario impeded us from doing so. So luckily, we are grateful to have the opportunity to keep keynote session in the virtual mode so that our student can reap the seeds from the knowledge gathered in this section. So today I'm privileged to talk the opportunity and to invite our honorable speaker, Professor Dr. Arun Somani. Sir is the distinguished professor, senior associate dean, College of Engineering, IOWA State University, USA. Apart from that, Sir also associated with the with an Anson Marston Distinguished Professor, Association of Computing Machinery Distinguished Engineer, and a fellow of the Institute of Electrical Electronics Engineering. So during the time as department chair, he led the department to create 5 strategy research area in bioengineering, cyber infrastructure, distributed sensing and decision making, energy infrastructure, and small scale technology. SAR has designed a multi-computer system called Proteus and authored survivability and the traffic rooming with WDM optical networks. And in addition to that, more than 250 conference paper and journal article in his credit. So Saraz held in it an introduction to give because he has so much of things in his credit. So without any delay, sir, we invite you on the platform to share a few words with us. Thank you, sir.
Can I share my screen?
Yes, sir. You can.
You can see the slides?
Yes. Slides is visible. Yeah.
Okay. Thank you very much. I really appreciate this invitation, and I'm very happy to share some of the things we have been doing here at Iowa State University. Probably some of you know, if not, Iowa State University is the home of digital computer, and we are very proud of that. We believe that we invented computers before ENIAC was designed, and ENIAC was actually a copy of it. And it's not a belief, it was settled through a court case. But what I'm going to talk today is about neural architecture search. So we have been hearing a lot about neural networks, CNN, and how they need to perform and how much good they are doing to the society. The question always is, how do we find the best architecture which can do the job you have in hand and is more tuned to it? As you will all appreciate, that if you design the right system for the right task, then the system will perform the best. And since these tasks are so repeated so many times, if you're doing a face recognition, you're constantly looking for different faces. So the task is to be repeated, and to develop a network which will actually do this job more efficiently is very much required. I just want to give acknowledgement to my PhD student, right now, Mr. Krishna Teja Chitti Venkata. He's about to finish the dissertation probably in this year. And this paper should be cited as noted below. So I want to start the conversation with, if you look at IEEE Explorer and what are the hottest topic people are searching for. So, you know, IEEE Explorer is a platform where you have other publications. And when we look at this place and go and search for keywords, they keep track of the data. It's part of data mining. They say what people are searching for. And guess what the number one topic is? I didn't want to keep it surprise, so I put it on the slide, but something to think about. The number one topic being researched right now is word image processing. And this is as per the Spectrum of December 2021 issue. And then second word search is antenna. And then artificial intelligence, machine learning, data mining, cloud computing, VLSI, deep learning, big data, and Internet of Things. So Internet of Things used to be the topic a few years back where everybody was searching for IoT. IoT has reached to number 10. And then big data was the word we were using a few years back. And then when it keep going down, and then AI machine learning was the keyword, first but big buzzword is still there. It's searched a lot, but antenna and image processing. These are the two fundamental techniques which are being searched for. Why? And when I started my first job, we were doing image processing. You're dating the data of radar and sonar, and I worked for Indian government and developed a system called anti-submarine warfare system. And we developed this system and installed on 2 ships in India for Indian Navy. And that time the image processing was pretty primitive. We were looking at the radar data, sonar data, extracting the signal and figuring out what's going on. And then I joined with a project which were designing the multi-computer system Proteus. And that was doing a model-based computer vision. And image processing was the low-level component from which we were deriving features. And then we were looking for the model-based objects. We knew what we were looking for, and then we searched for them in that image processing task. So we're still looking for the features and trying to connect them, connect the dots to get a model of an object we are interested in. And if you could find something like that in one frame, multiple frames, we used it. That is what the Proteus was all about. It was using multiple computers. And then field progress, and now we have started going into what we call CNN, the convolution neural network, which is searching for this, but the underlying task is still the image processing. We're looking for that image and trying to figure out what the features are. So it's not surprising that AI and machine learning techniques, which we are using right now, we need to understand the fundamentals of that task. And what is the antenna doing at number 2? And this is all about to do with the 5G and what to do with how to design the better antennas for communication. Antenna is not the topic of the talk today, but image processing, AI, machine learning, etc. is. But I do want to tell you that all of these are very related topics. If you think about the remaining 9 out of the 10 topics here, they're all related to one way or other, because image processing is what needs to be done. AI and machine learning and data mining are the techniques to search for what we're looking for. And cloud computing and VLSI are the one which enables it. And the major technique used there is deep learning. And this is all because we have so much data to process. And who generates the data? Internet of Things. So it's the same revelation that what we can do with the data, and we are trying to study them under different things. But my topic today is to talk more about image processing. And not image processing, finding the right architecture to do this kind of a task. So I'm not going to go into the image processing details themselves, but we'll be continuing with this. So now switching back to the main topic of AI and deep learning, already may make the case that it's everywhere. And you already must have heard in multiple different conversations that how this is being used to design a lot of useful systems for the society. It's becoming one of the biggest tools for everything. And then AI has kind of come back. When I was doing my graduate class, I took a course in AI, which was 35 years ago. And that promise of AI can be delivered now because we have the computing power of it. But that doesn't mean that we have enough to do everything we want efficiently, inefficiently. It still needs to be done efficiently. That is the main point of the talk today. We want to do these tasks and we want to do them fast. We have to design the right algorithm, right computing platform, right method to do it, and that's what will make it work. So I'm not going to get into details of any of these applications. These pictures are pretty representative of what these applications will be. But what you see underneath is a classification network, which is multi-layered, and you give it an object and you want to come back with an outcome of saying which one of these objects you are looking for. Go back and relate to my original thing, model-based image processing. We knew what we were looking for. We tried to search for them. We still have the same task in hand to do that here. So then the next question comes is, what are the different hardwares available for deep learning? And this is where the thing comes, is that you look at variety of things. You have microcontrollers, you have mobile CPUs, you have high-end CPUs, you have edge CPUs, you have edge FPGAs, high-end FPGA, and other data centers and ASICs. So all of these are the computing platforms available to you, depending on what you can afford, what you want, how many times you want to do a particular task, who you are. If you're repeating for somebody else versus doing it for yourself, you're doing it on your cell phone. All of these need to be considered in order to design the network itself. And that's the problem. So what are the primitive convolution operations we are generally looking for? Well, deep convolution neural networks, so we call them CNNs. The different type of operations on spatial convolution, depth-wise convolution, dilation convolution, and so on and so forth. CNN stands for the convolution neural network. Basically, convolution is a way to figure out what kind of the features of interest and how do you connect them back to arrive at the conclusions you are interested in. So typical parameters will be the type of convolution operation, what should be the kernel size, which is the smallest size you look at in an image, how many channels you'll be operating in parallel, what is the actual model size, what precision you need to work with. Some of them can be just done with 1 or 2 bits saying yes or no kind of an answer. On the other hand, sometimes you need to have 8-bit data, so decide one of the 256 choices. Some of the times you have to look at 32, 62, 64 bits. Which size you should be using? It's not one size fit all. Can we afford it? And that's why you're seeing newer computer platforms which can sometimes support multiple different precisions, and you work with them. It's an evolution process. It's not that the first time we investigated this in hardware. We've been working on it. And what you're seeing at the bottom here in the picture is the kind of standard spatial convolution, depth-wise convolution, or some different kind of convolution. I'm not going to get into details of any of this. My point here will be to communicate that top level point to you, and then generate enough curiosity that you want to go and read more about it. The other part is that how to make it efficient. So people have explored 2 different kinds of things. Once you design the network, it is a very dense computing. It's designed for a matrix or matrix vector multiplication. And that's what each layer doing. It's basically taking a matrix, multiplying with the input vector, and then concluding something from it. And the process repeats in these multiple different layers. So people said, well, it turns out that a lot of this computation is redundant. Even if you don't do as much of computation, you could perform the operation and get the same conclusion. What it means is that when you have these nodes here, the layer 1, they're all connecting to layer 2 nodes. And you have this, what is called dense connection matrix. Well, you can take many of these away. How much away? Occasionally up to 90%. And then you still don't change your conclusion. So that's called pruning. The interesting thing about pruning is that on a piece of paper, it looks very interesting, and in some cases it will work very well. But in the wrong platform you are using for this, doing the prune network operation, you will find that it becomes inefficient. What it does is it creates a sparse matrix. And those of you who have worked in the sparse versus dense matrix work very well on a regular platform where you just flow the data and everything comes out cleanly. On a sparse matrix, you have to figure out which element is present or not, and therefore the computation becomes complicated. And so sparse matrix will do okay if there's a high level of sparsity on a CPU kind of an operation. But if you have a GPU kind of an operation, you'll find that the sparse network may not do well. more lately, we have now solution where some sparsity is afforded, but it's very limited. Similarly, quantization, this simply says what level of data precision you should be using. 1 bit, 4 bit, 8 bit, 16 bit, 32 bit we talked about. You have to select the right one. These are the two basic techniques to reduce the computation time. It also has implications on the memory you need to have to store the data. A pruned network can be stored more efficiently. A quantized network can be done more efficiently in processing. So you have to store fewer amount of data. You can work with that. So what is the design problem? It's basically that right now design is done by intelligently by choosing the right kind of layer so that we can have the proper feature extraction, can make the correlation, and then integrate it to derive the conclusion. The process design, manual design processes, a lot of intuition is used and domain knowledge is required. That's why the image processing becomes important. And networks have been designed. Here are some examples. So new applications will require exploration of new kind of architecture. It's not that the same layers can be used for another application. So the question is, can we automate this design process so that we come back with the right architecture for the given task? What that means is, if you give an application and you have these tools available to you to design different kind of filters, how to put them together that you will get a computation network which can be then used for this application. And our twist in this is that you also need to tweak the hardware parameters in there. So this is called the neural architecture search problem. And the task is to design this network. And so basically you need to have what are the things you need to consider? Well, you need to consider the search space primitives, what kind of dilation and convolutions you will be needing. You have the actual construct, whether you're doing a micro level or macro level. And again, I'm not going to get into details of that, but I'm assuming that you have some intuition about what that means. Depending on the type of kernel size and number of filters, then you will be having a search strategy, which will be saying, and there are two basic methods used here. One is called the reinforcement-based learning. Other is called evaluationary grade. And the three one here. And third one is called the gradient design. And then after you take the evaluation strategy, you take the validation, take the data and see whether the model will work for you. And then what comes out is the search model here. So the process is described here in the picture above. And the search element essentially will be the convolution type, kernel sizes, number of filters, and so on and so forth. So these are the parameters for your search, which you are working with. So what are we going to do here? Well, the two earlier methods were used were the reinforcement-based learning, and the way they will work is that in one case you have an agent and you perform some computation and you take some action that this is how we are going to convolve, this is the kernel size we'll use. That's an action. You apply in the environment and then see how it performs, and then based on that you get to the next state and get some reward. So agent is given a reward for making the right conclusion, and then if there's conclusion wrong, then reward is kind of negative, then it goes and fixes the strategy. In the other case, you have an RNN controller, which is called the recurrent neural network controller. It predicts a model and you evaluate that model, and if a model works or not work, that validation accuracy will be feedback to the controller, and the process repeats it until the answer comes here. Now, at this point in time, we are not looking into the hardware side of the world. We are only looking at the model itself. And a combined strategy will be, a strategy that you are doing one thing at a time. That's how you see in both the loops there in the previous slide. Now, if you can formulate the problem slightly differently and say that, and we call that a differentiable architectural search, where you say that when you go from one node in your neural network to the next node, there are more than one ways to go there. You might use a different kernel size, 1 by 1, 3 by 3, 5 by 5, whatever. You might use a different kind of filter. You might use different parameters. So you can think of this as a combined model where we're going from node 0 to node 1, from one layer to another layer. There are more than one ways to do it. And rather than doing one at a time and trying it and predicting it and trying it, if you could think of this as a saying that to go from node k minus 1 to node k, you will go, and these are the different methods, operation 1, operation 2, operation n type. You have n different types. We're representing them by these arrows in the colored picture. What it means is you're trying to use a different kind of an operation. And then you assign a weight to this one, that which one of them sort of works. And then your goal becomes that you want to choose the one which will work the best. So by combining this strategy, you're doing all of these computation at the same time. When the input comes, you try all of them and then try output. What it does, you save time in moving the data through the computation process. You analyze all the strategies. Sometimes you're able to reuse the computation, and effectively you define which one of these paths will work. So this alpha vector here is simply to choose which of these particular operation performs sort of the best. The one which maximizes to arrive at the node k from k minus 1 is what will be chosen. Eventually what will happen is you will get a final cell design which would have selected the right kind of an operation for each of the node transition. And that would be a final design. So it's a combined strategy. And now we are bringing the hardware in the picture. So what that means is that you take different possible hardware platform or the one which is of interest to you. So if you have a hardware dependent solution, you're looking for a hardware dependent solution, then you take the hardware platform characteristics, hardware platform definition, and also the corresponding characteristic, that how much time it will take to do on that, how much energy it will consume to do it, how many operations you might have to do. And here you can have a lookup table that you might have computed these in advance for each filter type, how much computation take to do on this particular platform, what is the latency of that. Or you might have a prediction based on the need. You can approach many of the strategy. So you take the hardware characteristics and the hardware platform definition, and that's what goes in your hardware aware search space. If you have a fixed search space, then you can directly feed that into that. You don't need to do the upper here. And then you go and then go into a search space construction, which is the microcell based or macrocell based. And then next step is to look at the multi-objective search strategies to figure out one of the, say, 3 methods we talked about earlier. And here you are also taking in consideration that how much accuracy you really need. In some cases, low precision is fine. In some cases, you need higher precision. Some cases, a coarse decision is fine. Some cases, you need to make a finer decision. And there again, you might like to use this hardware matrices in searching this accuracy piece of it. So when you combine both of these parameters into this multi-objective search strategy, you will get the final output, which will be very effective for you in the computation process. So that's the kind of main loop for the hardware-aware neural architecture, where the hardware is playing a role in deciding what you're going to do. And again, here you can have, as we talked about, there were 2 strategies. We talked about the fixed search space, which is just manually designed operations, which you're keeping track of, versus the hardware-aware search space. And I showed both of them combinedly in the previous slides. So the next step then comes with that when you're doing this micro search level basic, you're looking at each layer at a time and then saying what model will work best for that. And what you're seeing as example here, these are the different kind of models developed by different researchers. So almost every slide actually is 1 or 2 research papers which have been published on this issue. If you search for them, you'll be able to find it. Or we have been working on a comprehensive survey. So if you're interested in that, write to me and we'll be able to share that paper with you. But what you do is each layer by layer, you're designing what is the right approach for that layer. And what you will be using for designing this cell here is to use this combined strategy that, as I said earlier, to go from one node to another node, you might have different operations and you're picking up the right operation for that purpose. So you'll optimize the design for that using that step. In a macro or layer-wise search, you look at the entire search slightly differently. So And again, I'm throwing some numbers here without getting into details for you. But if you're designing some kind of a convolution network and it have a kernel size and an expansion ratio, you look at all of them together by doing these different techniques and then work with that. So there's a difference between a layer-wise and the micro search level and the macro search levels. And I encourage you to read more about it. So the point is, even if when you have the hardware design, you may still have the two different strategies to design your next step in the design piece. So common search space primitives, when you're doing it, this shows an example of what are the different parameters you might be working with and what are you trying to optimize here. So here are the three different search space primitives, and again, some jargons on you, but these are the way different people have designed their networks. So MB-convol is one method, MB-convol with an SE, which stands for squeeze and excitation, is another method, and FBNet, this is a Facebook Berkeley network for doing certain computation. The steps involved are that you take input, you do a convolution one by one, then you're doing the depth-wise convolution. Again, you're doing a one-by-one convolution, you're adding that up together. That's the basic step here. When you put the SE here, this becomes an additional step in that process. And FBNet is being designed slightly differently. It directly takes the connection, but the operations here will differ. And what are the parameters you're looking at? It's basically defined in this table here. Again, without going into detail, you basically what you're really trying to optimize is the kernel size, the depth-wise kernel size of the depth-wise convolution, and the expansion ratio of T, which is what you're trying to optimize on. So this gives you at least one step of what is needed for figuring out in the design, the convolutions. And in reinforcement-based learning hardware-aware architecture, what you will do is still doing the same search space, but keeping the hardware parameters in mind. So you are looking at maximize the accuracy, but you are subjecting it to the constraints of time, the latency of the computation. Or you might be also subjecting it to the accuracy times latency together with the feedback loop. And then finally, you might like to have a combination of things where you give certain percent of certain weightage to the accuracy itself and the other part to energy. So this will be more energy efficient, accurate network. So what you did, you still have the RNN controller. You're predicting a model, but you're estimating accuracy, you are estimating hardware cost, and two together help you decide what should be your predicted model. That's all the changes come in. And work with the hardware awareness. The same thing in the differentiable gradient-based hardware-aware neural network. You will still be doing the same thing. That is, you're looking at the design method here, where you're basically looking at your value of L, which is the loss function, and the latency, and assigning some weightage, and then subjecting it to some constraints which are being governed by the hardware parameter. That is the take-home point, really. That the search becomes hardware related again. And I'm emphasizing that point multiple times. And you're going to use the methodology we just talked about, which is combining all of the steps. So it picks the right operation for that particular layer. Okay. So, and in these two methods, you can have a lookup table. We talked about that either you can have already pre-computed parameters saying what the lookup table will lead to, saying this will be accuracy if you do this operation, or this will be the energy consumed in this operation, or this will be the accuracy in this operation, or you might predict it based on the experience. So you build those tables as you go along in the search process. And that's where the two differences come. So now what I'm just going to say that when you design this way correctly, and here are three cases where you say your proxyless NAS, example machine, but designed for GPU versus CPU versus the mobile platform. What would you expect? You would expect that this platform will work best on the GPU. It will work best on the CPU, and it will work on the best on the mobile latency. This will be the latency of the operation. But look at the same network. If you use one of these networks, and how much accuracy you're getting for each one of these models for the designated platform, you're getting that. But a GPU-based platform will perform worse at the CPU or in the mobile platform. And from 5 to 7 milliseconds is a 40% increase. Similarly, for this one was the least here, but if you run the same model on a different platform, you will see a different timing here. So the point I want to make is that this is the table which is giving an example of that when you design the network, and then the bottom layer here is the examples of what will be the efficient GPU model will look like, as opposed to efficient CPU model will look like. Because of the flow of the parameters from layer to layer, you will see a different combination of layers. That's all the take-home point here, because I don't want you to be reading this picture clearly, but you can appreciate that the model is different depending on the platform. And that's the key point. And they perform differently, another key point. And if you try to use that on a different platform, you will be paying penalty in computation. Now, it may not look like a big deal, 78 to 116 millisecond, but when you're running this operation multiple times, you obviously are having a problem here, because you'll be losing efficiency in a big way. So that's the point this slide makes here, that if you design it correctly, first thing, the design will be different. And second thing is that these models will perform well on the designated platform, but they will perform poorly on the other platforms. Therefore, it's very efficient, very necessary that you're doing a hardware approach, which is working best for you. So here are some examples, and I'm not going to get into very much details again, but one example is designing something with microcontroller. It's a design methodology. And the tininess then is simply looking at network for a given network, which will satisfy the memory constraint. Why? Because it is to be working on a microcontroller, you don't have that much memory. So it needs to be a lightweight inference engine with limited memory. And then you have a models of this and library models, library of the models, and you're picking up the right one for your microcontroller example. Second one, somebody is designing for a mobile CPU. Well, the goal is now like Google Pixel. The goal is to now design the network to work on this one here. So the search algorithm will then will look for the right kind of platform, and it basically uses lookup tables a lot more. And the search elements are the kernel sizes and expansion channels. And that's what the goal of this particular study was. Third study is about how to design a network which is for GPUs. So it's called the 3 freedom NS design. The goal of this design is to look for inference on, let's say, Titan GPU. And what you're optimizing are 3 different things. At the operational level, you are looking at the bit sampling search algorithms. At the depth level, you're looking for a proper connecting space. And for the width level, you're looking at a progressive elastic scaling method. And when you design this, the network design comes out differently. And again, I'm hoping that you will go and read more about each one of these steps, because each one of them is a research paper in itself. And that's the point here, is that the space becomes different for what you're designing right now. This is a more interesting example from my point of view, so I want to come to that. If you have multiple GPUs and you know that you are going to use this multiple GPUs for computation, and now at this point in time, one question always comes up that you can optimize where you will compute something in one GPU on the left side here, and then you will send those results from this GPU to the next GPU with next computation, which is happening in the second GPU, because you have, in this case, 2 GPUs, let's say. So it will look like efficient to compute something here. You do a I-2 layer computation, go feed it to I-1 layer computation, and then you do some computation and create the ith layer input, right? And then the second GPU is only playing a role here. It's going to use the same results from this one. It will look efficient to just communicate these results to that. But it turns out this could be more expensive in computation, because the latency of this communication is more problematic. And that is an interesting problem we face when we design the Proteus system. Because we had a multi-computer system, how should we communicate effectively? So we designed a very efficient communication network for that multi-processor computer system. I mean, nowadays, of course, the network technology has improved, but I'm talking about the 1990s. it turns out in this case here that if rather than doing this computation once and communicating, you might as well do the computation twice. Same computation on both the GPUs, you're repeating, and this model runs faster because you don't need to have the communication step. And maybe a small result goes from this side to this side again, just to maintain the accuracy of the model. So the point I want to make is that if you knew you are going to work on multi-GPU, then you will probably repeat some computation, which will look inefficient, but it turns out to be an efficient operation. And that's the take-home point from me. And the fifth study, which is more designed for the ASICs. So in that case, your goal becomes differently. Again, you're looking for the search spaces fused or unfused NVM blocks, and your search algorithm is still multi-objective RLNS. But what you will find is that this will be optimizing this computation very differently, and the result will come out differently again, as you can see on the screen. And that was another case study. So each one of these case studies has been done by a different research group, not mine. The second part, I know that I want to be cognizant of the time here as well. So search for precision, that one of the goals you will have is that each layer, whether you are going to, what kind of quantization level you will use, and that will play a different role. And having a multi-quantized combination network will work better for you overall in the computation if you have a choice of supporting that computation. If certain computation is not supported, you cannot do it. And you will find that the computing engines now support 1-bit, 4-bit, 8-bit precision. So, and the last part was for precision search, again, the only thing which comes up and start playing is the quantization policy. That plays a role. So you need to bring that quantization policy in play. And the bottom table here is simply showing that depending on which kind of network you design and how much latency you're looking for, with the right technology, right method, you will get an optimal design on the diagonal, and all others you'll be paying penalty. So here the right method will take, let's say, 99 milliseconds. Well, that will become 108 or 117 if you use a different kind of quantization method. And that means extra time. Extra time is extra money, and also extra energy. So looking for the quantization method, also you will have some possibilities of optimizing there. So when you can again use the same methodology that all the quantization you can look at together. You can do a multiple combination, 1-bit in the 2 layers, 1-bit, 2-bit in the second layer, or you can combine that you choose only one precision for one layer and a second precision for second layer. Two of these approaches will give you a different result, but one might be better for design, other might be better for performance. So depending on where you are spending more time, you may optimize it that level. You also need the right benchmarks. So when you're designing a network, you want to make sure that the right benchmark is used to evaluate the processor, because when you're training the network, if you don't use the right benchmark, it will have impact. And I think that makes sense. So I'm not going to explain more about that. And then finally, as you heard in some other talks as well, there have been now a lot of effort in designing accelerator for the neural network design. So when you want to do design search space for that one, design search space algorithm for this kind of architecture, it poses a different problem, because now your latencies are working differently, your computations are working differently. So what we have been doing more lately is that we are taking this specialized network, which are the accelerators, and we are applying all the methodology steps, that is the searching in parallel, that's number one. And number two, using these accelerators to come up with the right solution for a given problem has been the focus of our research. So if you read some of our recent papers, this is where you will see action in this thing. Without explaining any of the point here is that the hardware platform for us is this specialized accelerator processor. And then what we get is an architecture-aware array-aware architecture search, which is searching for this thing. There are two aspects here. For given array, what algorithm will work best? For given algorithm, what array size will work best? Just because you have a bigger array doesn't mean you have to use it all. Or just because you have a small array, you should continue to use it. Maybe there's a need for designing another array for it. And so we are basically trying to make the point of saying, what the methodology will be, and then what the result is, that what should be the architecture. So to conclude my talk, well, we talked about the hardware awareness problem, and try to show it to you that when you bring the hardware parameter, it really works well. Provide you an overview of the summary of the whole, some of the network designs which have been being done in this network and the research community. This point I want to emphasize most, that importance of hardware aware search space is very much to be considered. Without that, you will reach wrong solutions. And the process can be automated. So I want to leave you at that note. And if you have any questions, you can ask me now. Otherwise, I'm hoping that I did not take too much extra time here. I'm trying to finish the talk in a timely manner. Thank you very much for your attention. Mr. Nayak, you are actually muted, so I could not hear you at all.
Yes, sir. So thanks, thank you, sir, for your nice talk. So as far as our student is concerned, most of the students from CSE, we are enforcing them to do the research in AI-based technique, and most of the faculties are well acquired knowledge in AI. Even if I am also doing this image processing and this particular area, and in between a talk, many of your slide I have took the photograph for my reference. So I will take it note and I will make it done. And if so, I will contact with you for further collaboration. And for this particular talk, thank you for your enlightening words, sir. And it was pleasure to listen to you give insight about neural architecture search, a hardware perspective. We feel privileged to have your supervision backing us. Your talk was particularly insightful at the time when students are considering new idea to broaden their knowledge for expanding growth in the field of artificial intelligence. So I believe your words have set new level of expectation that our students aspire for. So on behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude, knowing you're busy you are. So we appreciate the time you took to import us with your valuable knowledge. So we are highly grateful to have you with you, sir. Thank you so much, sir. And soon we'll collaborate with you, and we are expecting many more outcomes will come out with the collaboration with your university and Amity. So particularly, I will keep in touch with you, sir.
Thank you, Soumya, and thank you, Professor Arun Somani ji, to be with us on a very short notice. We always enjoy your session, and even all the students, faculty who are attending your session from all the campus of Amity, even outside Amity also, because this time we have made delegate registration free, and we have allowed everyone from outside to attend and take advantage of all different research sessions happening through all experts who are coming from all over the world. From 35 plus country, we got 150 speakers. It was quite tough task, but we have done it, and thanks for all your guidance and for your valuable time to be with us. And Soumya, we have very strong, for your reference, we have very strong partnership with Iowa State University. Yes. We already have a tie-up. Anything you want to do with Iowa, Professor Somani is always there to help us, guide us, mentor us. Already many students have gone under global transfer program. There are students they have gone, they have done their summer internship, and experience of Iowa State University is amazing. All they have gone, nobody has came back. All they are doing good in states, and that is because
but they are all doing useful work.
Yeah, all doing good, useful work. And Iowa State is a wonderful university. I have seen many times, 1800 plus acre campus. And everyone there is so humble, polite, helping their students all the way. Thank you, Professor Somani, for extending all tie-ups. All we could do it with Iowa State University, and in times to come, we'll further multiply and see more we can achieve through our collaboration, through our efforts, which you have also put it, and we are going to see many more in times to come. And even one of our MTech student also got an offer where he'll be doing first year at Amity from civil engineering, and he got from civil engineering Iowa State University, as you rightly suggested. And there are more going to come, because Still, many have not understood how global transfer works, but with few cases as a role model, I'm sure many more are going to come up. And thank you so very much for your valuable time so early in the morning to be with us. And I'm sure your session, which is recorded, will be seen by many students who could not attend because of their exam, many other activities, but it's a pleasure. And thank you, Iowa State University, to be academic partner for Confluence, which we always keep you as our partner so that nobody should feel Iowa State is a new name for them. And thank you very much, Professor Somani.
Appreciate your collaboration and thank you for the kind words.
Thank you very much, Professor Somani, and wish you all the best. Take care, sir. And look forward to see you soon in India.
Absolutely. I should have been in India. I should have been this talk from there, but I had to change my program because of the acceleration in COVID.
Yes, we are thinking, we are all praying God that soon it should go. Otherwise,
I'm ready to come anytime. I need to wait. I'm just waiting for it.
Yes, and even myself also from last 2 years, we could not travel. We could not go and talk, visit. And that experience which even we get, our students get is amazing. And that's a need of our that everybody should travel now. But COVID has stopped everyone. But we look forward that situation should become normal and movement should start soon. And we look forward, Professor Somani. Thank you very much for your time to be with us. Thank you.
Bye for now.
And thank you, Soumya, for handling this session. Thank you.